Man, y'all got me fucked up, boy. On God, boy, y'all best go to that under channel and have them unmute me, boy, because boy, I'm about to do something, man.
Looks like someone else did something instead.
Hey, yo, how's everybody doing?
Good.
Hey, AJ, happy to hear that. Jim Z, are you here? Jim Z.
He's probably snoozing.
Oh, yeah, that's so annoying that we're different time zones. I can never catch that man when he's awake.
I'm driving down the interstate, so I don't know if you can hear me. Can you hear me okay?
Yeah.
I'm
Let's see
doing
if we
great.
can wake. Let's see if we can
Yeah.
wake Jimsy up.
Don the Monko. Let's not wake him up. I don't want to be a nuisance to him. I'll talk to him eventually.
It's going to be 95 with 80 some percent humidity today, and be about a buck 30 in the back of my truck. I'm going to kick ass and get it done today on this beautiful flat Earth.
Hell yeah, brother. I'm just off of work right now. I'm gonna go home, eat some good food, take a shower, do some stuff around the house, and I gotta learn.
I heard somebody say once, he said, if you're able, ABLE, then you should be able. Always be learning everything.
Yep.
So picture this. In a highly controlled experiment over Lake IJssel in the Netherlands, a specialized laser beam was fired 25.4 miles straight across the surface of the water.
Right.
And it was leveled exactly 2.92 meters above the surface. Now, according to the foundational, the geometric math of the standard globe model we all learned in school.
And math everyone relies on, yeah.
Exactly. That laser should have been physically blocked by a 440-foot wall of curved water.
Yeah.
I mean, the target should have been completely hidden.
A massive water right.
But it wasn't. The laser struck the receiver on the other side at exactly 1.5 meters above the waterline. It maintained near-perfect parallelism with the surface across that entire 25-mile expanse.
Which is, frankly, a staggering anomaly.
Yeah. So today, we aren't actually asking whether the Earth is flat. What we're asking is why humanity's most foundational scientific maps are like violently colliding with physical reality. And what happens to the human psyche when the models we trust just begin to crack?
Because that brings us to an incredibly precarious yet, fascinating epistemological landscape. When physical observations flatly contradict the foundational geometry of our world,
right,
the resulting debate isn't just some polite disagreement over data. It becomes a total psychological and cultural war.
It really does. Welcome to the deep dive, everyone. Yeah. You are in for a truly intense culinary exploration today.
Oh.
They're taking a magnifying glass to the psychology of belief, the mechanics of how we differ. And the second source is a skeptical cosmology booklet.
Which is really detailed.
Super detailed. It's a mathematically grounded pro-flat Earth document challenging the standard heliocentric globe model.
Now, before we go a single step further, I need to establish a very explicit ground rule for this analysis.
Yeah, this is crucial.
Because we are wading into deeply polarized geodetic debates, our role here must be fiercely analytical and, strictly impartial. We are not here to endorse, validate, or take sides on the cosmological viewpoints presented in these texts.
Absolutely not.
Our purpose is to impartially report the arguments exactly as they are constructed by the authors. We want to convey the ideas, examine the epistemological frameworks, meaning how these groups justify what they claim to know, and analyze the psychology of the conflict.
Right, we aren't declaring a winner here.
Exactly. We are performing an autopsy on the anatomy of the argument itself.
The goal is to make you, the listener, immune to the cognitive traps that catch almost everyone else when these topics come up. And to do that, we actually can't start with the physical anomalies. We can't jump straight into lasers or water measurements.
Right, because according to our academic source, before anyone even steps up to a telescope, both sides of this debate have usually already fallen victim to a foundational psychological trap.
A cognitive disease, basically.
Yeah, a disease the paper calls reification. And disease is an apt way to describe how the source frames it. Reification, at its core, is the cognitive error of mistaking an abstract representational construct for a concrete physical reality.
So like mistaking the idea for the thing itself.
Exactly. You take a concept, a mathematical formula, or a model, and you suddenly start treating it as if it has physical mass and dimension. To diagnose this, the academic paper leans on what it calls an epistemic trinity.
Okay.
3 philosophical pillars. The first comes from the mathematician and philosopher Alfred North Whitehead, who coined the term the fallacy of misplaced concreteness.
Mistaking the abstract for the concrete. I mean, that sounds simple enough, but how does it actually corrupt scientific reasoning?
Well, in science, abstraction is mandatory. When you measure the physical Earth, you are dealing with jagged mountains, deep ocean trenches, fluctuating tides.
Gravitational anomalies, all that messy stuff.
Exactly. It's incredibly messy. To make sense of it, scientists abstract. They select specific data points, ignore others, and apply mathematical formulas to smooth out that messy reality into a usable shape.
Right.
Whitehead pointed out that the fallacy occurs when we take that smoothed out, abstracted mathematical formula and suddenly grant it the same physical reality as the dirt and rock it was meant to describe.
Oh, wow.
For example, the source discusses the geodetic ellipsoid. That is the perfect mathematical egg shape used to model the Earth in standard physics.
But it's just an equation, right?
Exactly. It is an equation fitted to a data set. But when a person points to that mathematical equation and believes that's what the Earth actually physically is, they have committed the fallacy of misplaced concreteness. They have reified the math.
You know, I was trying to think of a way to visualize this for you listening right now. Think about looking at an incredibly curated, heavily filtered, like AI upscaled Instagram photo of a beach vacation.
That's a great analogy.
Right. It's stunning. The colors pop. The lighting is flawless. But if you stare at that photo long enough, you might genuinely start believing the 2D arrangement of digital pixels is the actual beach. You forget the trash that was cropped just outside the frame. You forget the suffocating humidity. You forget the smell of the rotting seaweed. You think the digital filter is the physical reality.
That is exactly the mechanism. The representation has completely hijacked your cognitive understanding of the real object, which transitions us perfectly to the second pillar of this trinity from Alfred Korzybski. His famous axiom is, the map is not the territory.
Yeah, I feel like everyone has heard that phrase. I don't think we actually respect how terrifying the implications are.
We really don't, mainly because we rely on maps too heavily to want to doubt them. Korzybski's point was that every single map or model inherently requires omission, scaling, and distortion just to function.
Right. Otherwise, it's just a clone of the world.
Exactly. If a map perfectly captured every single detail of the territory, every blade of grass, every pebble, it would be the size of the territory itself, rendering it completely useless as a navigational tool.
So a map is useful specifically because it lies to you by omission.
Yes. The academic source argues that the epistemic harm isn't that maps are flawed. The harm occurs when we forget the limitations of the map.
Oh.
When you navigate the world or engage in a scientific debate, as if the distortions in your map don't exist, you've lost your grip on reality.
Which totally sets us up for the third pillar, and this is where the paper gets downright surgical about modern science. It brings in Jean Baudrillard and his theory of simulacra.
Baudrillard is essential here. He outlined 4 stages of how representations function in human culture. Stage 1, a model faithfully reflects a basic reality. Stage 2, it begins to mask or pervert that reality.
Okay.
Stage 3, it masks the absence of a basic reality. But it is the 4th stage that the paper focuses on, hyperreality.
I always struggle with the concept of hyperreality.
Yeah.
It feels almost dystopian. What does a stage 4 representation actually look like in practice?
In the 4th stage, the model or the image bears absolutely no relation to any physical reality whatsoever. It is a pure simulacrum. It only references itself. It becomes its own truth.
Yeah.
The academic source explicitly argues that modern globe visualizations, the heavy CGI composites, the algorithmic satellite data sets that we see on the news or in textbooks, exist firmly in this 4th stage of hyperreality.
So they aren't even pictures of reality anymore.
Right. They circulate in our culture purely as self-evident depictions. In the human mind, these algorithmic outputs have aggressively replaced the physical territory. When someone thinks of the Earth, they don't think of the ground under their feet. They think of a glowing CGI blue marble on a black screen.
So the source isn't just saying we're making a minor error in judgment. It calls this a model affliction. We're like infected by our own representations.
Yes.
If this is a widespread cognitive disease, how does it actually play out in the scientific community? What happens when you put a bunch of people suffering from model affliction into a room to debate the physical shape of the world?
Well, it results in chaos, which the source attempts to categorize using a framework called the 2x3 epistemic matrix. This matrix maps out how human beings engage with cosmological models, dividing the population into 3 distinct behavioral paths.
As you were breaking this down, I was doing a mental audit of my own life, trying to figure out which path I'm on. And the brutal truth is, it's rarely the first one. Let's start with path A. The source labels this the pragmatist or the mappist tool stance.
This is the epistemological ideal, the aspirational path. And the source bluntly notes it is incredibly rare.
Why is it so rare?
Well, a path A individual possesses high awareness of the model's limitations and, crucially, extremely low identity fusion with the model itself.
Meaning they don't tie their personal ego to a mathematical formula.
Exactly. A path A actor treats a model, whether it's an ellipsoidal globe, a flat projection, or a quantum mechanic equation, strictly as a purpose-specific instrument.
Right.
Like a wrench.
Right.
They know the wrench's domain boundaries. They know what nuts it can turn and what nuts it will strip. If new data arrives that the wrench can't handle, revising the tool carries a very low personal cost. They don't have an existential crisis. They just go build a better wrench.
That sounds incredibly healthy. But the source points out that staying in path A requires a massive amount of ongoing cognitive labor, which is why almost everyone defaults to the other 2 paths.
Yes.
Let's look at path B. The source calls this the zealot, or identity fusion. This is a high-energy, highly volatile state.
This is where debate turns toxic. In path B, the model is no longer a tool. It has completely fused with the individual's core identity and worldview.
Oh, wow.
Because of this psychological fusion, any anomaly in the data or any challenger presenting an alternative model isn't perceived as an interesting scientific puzzle. It is perceived as a literal biological threat to their existence.
Their amygdala actually fires up. It's a fight or flight response to data.
Precisely. And this triggers massive defensive labor. We see aggressive tribalism, character assassination of challengers, and the rapid invention of ad hoc auxiliary hypotheses simply to patch the holes in the model and protect the ego.
Sounds exhausting.
It is. The ongoing psychological cost of maintaining a Path B stance is exhausting because you are constantly locked in a battle royale to defend your reality.
Which is why the vast majority of society opts for Path C, the mundane or the echo chamber. This is like the lowest energy state possible.
Yes. Path C actors are the passive conformists. They accept the cultural default model simply because everyone knows it.
Right, they just outsource it.
Oh, exactly. They outsource their intellectual authority entirely to society, to academia, to institutions. They don't actively defend the model because in their daily lives, they never have to.
So the model just becomes this invisible truth.
Yes. The model is treated as invisible, obvious truth. The immense historical struggle, the trial and error, the nuanced limitations that the Path A builders originally knew about the model, all of that is entirely forgotten.
And this creates what the source calls the degradation pipeline. This concept was a total light bulb moment for me.
It's fascinating.
The paper argues that scientific knowledge naturally degrades over time. It always starts at Path A. You have a brilliant, nuanced scientist who builds a highly qualified tool, a map with explicit limits. But over time, as that model is institutionalized, taught in grade schools, simplified for the public, it suffers from what the source calls epistemological amnesia.
Epistemological amnesia is a brilliant term. It describes the total generational forgetting of a model's origins and its mathematical borders.
Right, so the nuanced Path A tool degrades into unyielding Path C dogma. It becomes the truth, passed to the next generation without the instruction manual.
Exactly.
Now, here's the explosive part. The source argues that when a challenger finally arrives with new contradictory data, it isn't the Path A scientists who answer the door, it's the Path B zealots.
Oh, absolutely.
They enter through the side door to violently defend the Path C dogma, treating the challenger not as a peer, but as a heretic.
It perfectly explains the vitriol of modern scientific discourse. The defenders aren't defending the scientific method. They are defending an inherited, unquestioned cultural reality from an identity-level threat.
You know, think about your own profession for a second. Finance, medicine, software engineering. How many standard operating procedures or baseline models do you use every single day, putting you firmly in Path C without actually knowing the historical math behind them?
Probably most of them.
Right. And what happens to your body when a junior employee walks into a meeting and says, hey, this foundational model we use is broken? Do you calmly pull out the raw data like a Path A pragmatist? Or do you feel that defensive Path B heat rising in your chest?
It's a universal human vulnerability. And when the academic source applies this matrix to the specific geodetic debate, the shape of the Earth, it reveals what it calls a symmetrical trap.
Symmetrical meaning both sides, the mainstream defenders and the radical challengers, are falling into the exact same philosophical hole.
Yes. Both the institutionalists defending the globe and the challengers proposing a flat Earth commit the exact same reificatory error. They just commit it using different maps.
Let's examine the institutional trap first.
So the trap here is reifying the globe. It is treating composite, CGI blue marble images as if they are unprojected, physical realities captured by a single camera click.
But wait, when NASA releases a photo of the Earth, isn't that just a photograph? Why is the source calling it a simulacrum?
Because that fundamentally misunderstands how modern satellite imaging works. Most of the high-resolution images of the Earth are built from swath data.
Swath data.
Yeah. Satellites in low Earth orbit take narrow strips of data as they pass over the rotating planet. To create a full globe image, algorithms must stitch these strips together.
Oh, I see.
They have to map this 2D data onto a mathematical approximation like the WGS84 ellipsoid. They apply illumination models to ensure consistent lighting. They apply color correction because satellites often read outside the visible light spectrum.
Right.
They run algorithms to remove transient clouds or stitch over missing data gaps. By the time you look at a blue marble image on your screen, you are looking at a highly processed, mathematically stitched mosaic.
So it's not a snapshot.
Not at all. The trap occurs when an institutional defender points to that screen and says, there is the physical planet. entirely eliding the immense amount of mathematical modeling and human choice that generated that image. They are mistaking the map for the territory.
Okay, that makes total sense. You are looking at data draped over a math equation, not a Polaroid.
Oh.
But how do the challengers fall into the same trap?
Well, the Challenger trap is reifying the azimuthal equidistant projection, commonly known as the AE map.
Right. This is the map you see everywhere in the flat Earth community. It has the North Pole at the dead center, and Antarctica isn't a continent at the bottom. It's stretched out into a massive ice wall that surrounds the entire outer circumference of the Earth.
Exactly. Now, the AE projection itself is an accepted, mathematically well-defined transformation used by mainstream cartographers.
Mm-hmm.
It takes spherical geometry and projects it onto a flat 2D plane. It is a phenomenal path, a tool for specific tasks like calculating radio antenna ranges or flight paths from a central point, because it preserves distances and azimuths from its center perfectly.
But there is always a cost when you flatten a sphere, right? Like, think about trying to take an orange peel and smash it completely flat on a table. It's going to tear.
Yeah.
Or, if it's made of rubber, you have to stretch the outer edges massively just to get it to lie flat.
That is the perfect analogy. Mathematically, you cannot map a 3D sphere onto a 2D plane without introducing massive distortions in area, shape, or distance somewhere on the map.
You just can't do it.
Right. In the AE projection, as you move further away from the center point, the North Pole, the land masses become wildly stretched and distorted to maintain that mathematical projection.
Yeah.
Australia and South America become stretched way out of proportion.
Okay, I see where this is going.
The trap occurs when challengers take this specific mathematical projection, which was designed with known geometric distortions, and treat it as a literal, physical, one-to-one depiction of a flat Earth.
They just ignore the stretching.
Completely. They ignore the mathematical stretching required to make the map in the first place, turning the AE projection into their own unquestionable, reified territory.
So you literally have two opposing groups standing in a room holding up two different maps and screaming at each other, "My map is the actual dirt." But this immediately brings up a huge logistical question. If both sides are fundamentally caught in the exact same cognitive trap, how does the challenger actually wage war against the institutionalist? Like, how do you attack an entrenched scientific consensus if your own map is flawed?
And this transition leads us directly into the tactical strategies detailed in our second source, the Skeptical Cosmology booklet. Because the authors of this text are highly sophisticated in how they mount an attack.
They really are.
They divide their engagement strategies into two distinct pillars: transcendent critique and immanent critique.
Let's break these down, because understanding the difference between these two forms of critique is honestly like getting a masterclass in how ideas actually survive or die in the real world. What exactly is the transcendent critique?
A transcendent or external critique attempts to attack a paradigm from completely outside its own established rules. It attacks from an external moral, historical, or philosophical high ground.
So if I'm a challenger, this would be me saying that NASA is a corrupt institution embezzling taxpayer money, or that ancient religious texts dictate a flat cosmology, or that scientists are inherently biased and part of a secret society.
Yes.
I'm attacking their character and their motives, not their physics.
Precisely. And the booklet notes that while a transcendent critique might occasionally highlight institutional biases as a mechanism for overturning a scientific model, it is an absolute failure.
Why? Seems like pointing out corruption would be a strong argument.
Because it is defensively inert. Path B defenders of the standard model can effortlessly dismiss a transcendent critique as barbarism, ignorance, or simple conspiracy theory.
Because you aren't fighting on their turf.
Right. Because you are attacking from the outside using external values, the institutional defender never actually has to look at their own math or their own data or their own anomalies.
They just brush it off.
Exactly. The root physics of their model remains completely untouched. They simply label you a crank, walk the gates of the institution, and go back to sleep.
You essentially give them a free pass to ignore you. Which brings us to the significantly more dangerous strategy, immanent critique.
Immanent critique is devastating. To use this strategy, you must step completely inside your opponent's paradigm.
Inside their house.
Yes. You generously and temporarily adopt all of their standard models, their foundational assumptions, their formulas, and their accepted physical laws. You operate entirely within their house. And then, using only their rules, you systematically demonstrate how their own internal logic inevitably leads to physical absurdity or violently contradicts direct empirical data.
It's the chess analogy. I sit down at the board, but I let you kick the opening. I let you set the time controls. I play exactly by your preferred tactical style. And then I use your own momentum and your own rules to trap your king. I prove your strategy false by your own standards.
That is a phenomenal way to visualize it. And what happens to a dominant scientific model when it is subjected to a successful operation? Imminent critique is fascinating. The source argues it triggers entropy.
Entropy, like structural decay. The model literally starts falling apart.
Yes, informational decay. When a standard model is faced with an internal contradiction that it absolutely cannot solve using its original foundational rules, it cannot just admit defeat. To survive, the model must invent what philosophers of science call auxiliary hypotheses.
It has to invent a patch, like a software update to fix the bug.
Exactly. And historically, we see this everywhere. Think of Ptolemy's geocentric model of the universe, where everything orbited the Earth.
Okay.
When astronomers noticed that planets sometimes appeared to move backward in the sky retrograde motion, Ptolemy's foundational rule couldn't explain it, so they invented an auxiliary hypothesis called epicycles.
Right, the little circles.
Tiny little circles the planets were supposedly doing while orbiting the Earth. It saved the model temporarily, but it made the system incredibly complex and fragile. Every time a theory invents a patch, it becomes more entropic.
So the model gets bloated.
Yes. In modern cosmology, the skeptical source argues that concepts like dark matter, dark energy, or anomalous refraction function exactly like Ptolemy's epicycles. They are auxiliary hypotheses invisible, unproven patches invented after the fact to save a dying mathematical model from its own internal failures.
And the booklet states that the ultimate goal of the challenger, using an imminent critique, is to push the listener, to push you to a psychological breaking point they call honesty awareness.
Honesty awareness. The source defines this as the exact terrifying moment a thinker recognizes the sheer volume of free miracles, unverified assumptions, and invisible forces required to keep the standard model breathing.
Wow.
It's the moment you realize the map is collapsing under its own mathematical weight.
Okay, this is where the rubber meets the road. Let's take this theoretical framework of imminent critique and apply it to the physical Earth. Let's look at the exact anomalies presented in our second source, the Skeptical Cosmology booklet.
Let's do it.
We are going to walk through the exact physical challenges they lay out. And again, as a reminder, we are reporting the claims made in this text impartially to understand how they construct this imminent attack.
Understood. Let's begin with their first major offensive, which bypasses visual observation entirely and targets the foundational laws of physics. They call it the thermodynamic paradox.
Here is how the skeptics use physics against the globe. They go straight to the accepted laws of fluid dynamics.
Right.
The standard heliocentric model dictates that the Earth possesses a pressurized atmosphere. We know it's pressurized because we can measure atmospheric pressure at sea level. But the model also dictates that this pressurized atmosphere exists directly adjacent to the near-infinite vacuum of deep space. Specifically, the source cites the vacuum of space as being roughly 10 to the negative 17 torr.
To give the listener some context, a torr is a unit of pressure. 10 to the negative 17 torr is a vacuum so profound, so completely devoid of matter, that humanity struggles to replicate anything even close to it in our most advanced laboratory vacuum chambers.
It's basically a perfect vacuum.
Yes. And the imminent critique here is beautifully simple. The globe model accepts the second law of thermodynamics, which strictly dictates how gases behave.
Right.
According to these universally established laws, a gas will inexorably, instantaneously, and uniformly undergo free expansion to fill available volume in order to reach maximum entropy.
You only get a pressure gradient, like the pressure we feel at sea level versus the top of Mount Everest, if the gas is contained within a solid, physical, closed system and subjected to an asymmetric energy input.
Exactly.
Think about blowing up a balloon. The air inside is pressurized because the rubber of the balloon physically contains the gas. If you pop the rubber, the gas instantly undergoes free expansion into the room. It doesn't stay in a perfect sphere just because it wants to.
Precisely. So the imminent critique posed by the source is this. Using the standard model's own accepted laws of fluid dynamics and thermodynamics, how can a pressurized gas exist right next to a 10 to the negative 17 torr vacuum without a solid physical barrier separating them?
To a skeptic, asking a gas to sit next to a vacuum without expanding is like asking water to spontaneously flow uphill. It violates the rules of reality. Now, obviously, the standard model has an answer for this.
Right.
The answer is gravity. Gravity pulls the atmosphere down to the core of the Earth, preventing it from expanding into space.
But the booklet argues that this defense is exactly where the reification pathology occurs. The source claims that gravity, specifically in this context, is an unverified, reified mathematical formalism.
Wait, what does that mean in plain English?
It means it is a descriptor of an observed effect, things falling down, that has been illegitimately elevated to the status of an active physical cause capable of violating the fundamental laws of gas expansion.
No.
The critique asserts that using gravity to halt the free expansion of gas into a vacuum is an unfalsifiable assumption. It is an auxiliary patch.
Because you can't test it.
Exactly, because it cannot be isolated, demonstrated, or replicated as an independent variable in any controlled terrestrial experiment.
They're essentially challenging the institution, like, build me a vacuum chamber on Earth, introduce a pressurized gas, remove the physical container, and use the Earth's gravity to keep the gas from expanding into the vacuum.
And you can't do it.
You can't do it.
Yeah.
Therefore, your model violates your own physics. Regardless of whether you believe gravity handles this on a planetary scale, as an imminent critique, it is a brilliantly constructed trap.
It really is.
Okay, let's move to their second major argument, which tackles the physical geometry of the ground we walk on, the missing geometric curvature.
This is where they target the WGS-84 standard ellipsoid. According to this universally accepted geodetic model, the Earth has a radius of approximately 3,959 miles.
And if you have a sphere with a radius of 3,959 miles, the geometry isn't a secret.
Right.
You can calculate exactly how fast the surface of that sphere must curve downward away from a tangent line.
Yes. The standard spherical trigonometry yields a drop rate of approximately 8 inches per mile squared.
8 inches per mile squared.
That means for every mile you travel, the Earth should curve downward 8 inches. But because it's a curve, it compounds exponentially. At 2 miles, it's 2 squared, which is 4 times 8 inches, giving you 32 inches of drop.
Okay.
At 3 miles, it's 3 squared, 9 times 8 inches, yielding 72 inches.
Yeah, why the fuck is so quiet in here?
The further away an object is, the more it should physically be hidden behind the bulging curve of the Earth's surface.
Correct. And the skeptical source contrasts this rigid mathematical prediction with direct physical measurements taken over massive bodies of standing water.
Why water?
They focus on water because water seeks its own level. It makes up 72% of the Earth's surface and provides a naturally smooth testing ground devoid of hills and valleys.
And the booklet brings receipts. They detail several highly specific experiments.
Let's unpack the Lake Jessel laser transit, which I mentioned at the very beginning of the show.
The source describes an experiment where a highly focused, stabilized laser was leveled exactly 2.92 meters above the waterline. They targeted a receiver 41 kilometers away, which translates to 25.4 miles.
Now, applying the imminent critique, the challengers used the standard model's own WGS-84 math. At a distance of 25.4 miles, taking into account the starting height of the laser at 2.92 meters, the geometric drop should result in the target being completely obscured by approximately 440 feet of physical water curvature.
Wow.
The laser simply shouldn't be able to hit the target. It should hit the massive bulge of the water sitting between the 2 points.
440 feet. That's a 40-story building made of water that should be blocking the path.
Yes.
But according to the source, the laser struck the target at exactly 1.5 meters above the waterline. The laser maintained near-perfect parallelism with the water across the entire 25-mile expanse.
Which is astounding.
The source argues this is a definitive deductive falsification of the spherical geometry. The 440 feet of curvature is simply physically missing.
And they don't stop at 25 miles. To demonstrate the magnitude of the geometric failure, they scale up the distance to limits that strain comprehension.
Oh, this next one is wild.
The booklet cites a famous line-of-sight observation from Puig-Sulfort, a peak in the Pyrenees Mountains, to the Giraglia Lighthouse located on the island of Corsica in the Mediterranean.
I had to reread the numbers on this one 3 times to make sure I wasn't misunderstanding the math. The source states this is a 325-mile line of sight across the water. The observer in the Pyrenees is standing at an elevation of 3,211 feet.
Again, we execute the math of the WGS-84 model. Over a distance of 325 miles, even factoring in the observer's elevated starting position of 3,211 feet, the Giraglia Lighthouse should be physically buried under 43,680 feet of Earth curvature.
Over 40,000 feet.
Over 40,000 feet. That is significantly taller than Mount Everest. Yet, the source notes that the lighthouse and the island are clearly visible in photographs from that peak.
It's just sitting right there.
The argument is absolute. If the Earth were truly a sphere with a 3,959-mile radius, seeing that lighthouse through 40,000 feet of solid rock and water would be a physical impossibility.
So the challengers are laying down a devastating hand. Like, we are using your math, we are looking across your water, and the physical reality simply isn't matching your map.
Exactly.
But if the math fails so spectacularly on the ground, how does the standard model explain all the visual evidence we seem to have for a globe? Everyone has seen pictures from airplanes showing a curved horizon. Everyone knows ships disappear bottom first as they sail away.
Which brings us to argument 3 from the booklet, optical misattributions.
Okay, so I saw this coming.
The skeptical source fully anticipates this defense. They tackle it by claiming these visual proofs are purely optical and atmospheric phenomena that the mainstream is aggressively misattributing to physical geometry.
Let's talk about the airplane window first. The source actually cites peer-reviewed mainstream science here, right?
They do. They cite the work of Dr. David K. Lynch, published in the journal Applied Optics. According to the source, Lynch's research confirms that the human eye cannot visually discern the Earth's curvature even from commercial cruising altitudes of 35,000 feet.
Wait, really?
Yes. The math dictates the horizon should remain perfectly flat to the naked eye at that height. Therefore, the booklet claims that the curve frequently seen in high-altitude amateur photographs or videos is entirely an artifact.
An artifact of what?
It is a product of barrel distortion from wide-angle camera lenses like GoPros, which artificially warp straight lines at the edges of the frame to capture a wider field of view, combined with the refractive properties of looking through thick, curved airplane windows.
Oh, so you aren't seeing Earth's curve, you're seeing the curve of the glass.
Exactly.
Okay, but what about the ships going over the horizon? That has been the definitive proof since the ancient Greeks. You watch a ship sail away, and the hull disappears first. Then the sails, then the mast. It looks exactly like it's going over a hill.
Well, the skeptic source argues that objects vanishing bottom first on the horizon is governed entirely by the laws of perspective and optics, not physical curvature. They point to two distinct mechanisms.
Okay.
The first is the limit of human angular resolution. As an object moves further away, the angle it subtends on your eye gets smaller and smaller until it reaches a diffraction limit and simply compresses into the horizon line.
And the second mechanism,
The Laplace extinction theorem.
which sounds incredibly complex, but let's break it down.
The theorem basically describes how electromagnetic waves, which is what light is, behave as they pass through a medium. The lower atmosphere over the ocean isn't a perfectly clear pane of glass. It's a dirty, turbid soup. Yes, it is full of moisture, salt particulates, and thermal density gradients. As light travels horizontally through this soup, it suffers exponential attenuation and scattering.
Think about driving a car with your high beams on in a dense, heavy fog. You can't see the headlights of a car half a mile down the road. The car hasn't dropped off the edge of the earth. The light literally cannot penetrate the thickness of the moisture to reach your eyes. The optical signal just dies.
Exactly. The source claims that ships simply reach the vanishing point of perspective and are simultaneously swallowed by atmospheric opacity. They fade out visually and compress optically long before they ever physically drop behind a geometric curve.
Right.
The skeptics argue that attributing this optical extinction to physical Earth curvature is just another form of reification, mistaking a trick of the light for a physical hill of water.
Okay, so if the challengers bring this overwhelming pile of anomalies, the missing 440 feet of curve, the visible lighthouse 325 miles away, the optical explanations for disappearing, ships what is the mainstream scientific response? I mean, if the math says 40,000 feet of rock should be in the way, they can't just ignore a mountain. Which brings us to argument 4, post-diction.
They don't ignore it. They invoke what we discussed earlier, an auxiliary hypothesis. But the source classifies this specific behavior as post-fiction, which is a critical concept in epistemology.
What's the difference between prediction and post-diction?
Prediction is when your theory mathematically anticipates an outcome before the experiment happens. Post-diction is when your theory utterly fails the experiment and you invent a highly specific, localized physical anomaly after the fact to retroactively save the theory.
So when the laser doesn't drop over Lake Hazel, or when the lighthouse is visible 325 miles away, the institutional defenders do not abandon the geometric globe model. What do they do?
The source claims they invoke extreme downward refraction.
Downward refraction.
The institutional defense is that the Earth is curving downward, but the light from the laser or the lighthouse is magically bending downward at the exact same rate as the curvature of the Earth, allowing it to follow the curve and hit the observer's eye.
The light is surfing the curve.
Essentially, yes. The source references the combat experiment here.
Yeah, I remember reading about that.
The combat experiment was a mainstream study that involved projecting multi-wavelength lasers over a 149-kilometer path across the ocean, from Mauna Loa to Haleakala in Hawaii.
And the lasers hit the targets.
The lasers successfully hit the targets. The skeptic source interprets the extreme intensity scintillations observed in this experiment as completely defying existing atmospheric turbulence models.
Meaning they don't buy the refraction excuse.
Right. The skeptics argue that relying on extreme downward refraction to explain away flat laser transits requires an absurd, uniform, and physically impossible temperature gradient maintained perfectly over dozens or hundreds of miles of chaotic ocean atmosphere.
It's just too convenient.
They label this standard response as pure post-diction, a magical, invisible refractive property invented solely to save the failing geometric map.
It's like flipping a coin, calling heads, it lands on tails, and you say, well, an invisible, localized microburst of wind flipped it at the last microsecond, so I'm still right.
That's how they see it.
The source also points to historical examples of this, specifically Airy's failure.
Yes. George Airy was a 19th century astronomer who conducted an experiment using a water-filled telescope. His goal was to measure the starlight aberration to definitively prove the Earth was moving through space.
Right.
The experiment failed to detect the expected motion. The skeptic source claims this experiment structurally proved it is the stars moving above a stationary Earth rather than a moving Earth orbiting the stars.
Oh, wow.
Furthermore, the booklet asserts that the institution later embraced Einstein's theory of relativity, specifically as a massive overarching post-diction to excuse away the fact that numerous optical and interferometry experiments could not detect the Earth's physical motion.
To synthesize this entire middle section for you, the skeptic source is utilizing imminent critique with brutal efficiency. They're looking the institution in the eye and saying, we are using your WGS84 math, your highly stabilized lasers, and your thermodynamic laws, and the physical reality simply isn't matching your map. And when we force you to look at the missing 440 feet of curvature, you just invent invisible forces like anomalous refraction or relativistic spacetime to patch the gaping holes.
It's quite the argument.
Regardless of where you stand on the shape of the Earth, as a rhetorical and epistemological strategy, it is an incredibly powerful way to deconstruct a model.
And it demonstrates perfectly why Path B defensive energy gets so dangerously high. When your foundational model is attacked from the inside using its own rules and the anomalies pile up, the cognitive dissonance is profound. The mind struggles to handle it.
Which brings us to the crucial pivot, the final act of this deep dive. If our maps are fundamentally flawed, if the models are breaking down under scrutiny, and if scientific debate has devolved into a toxic, high-energy battle of Path B zealots screaming post-dictions at each other, how do we fix it?
Right.
How do we cure the model affliction?
For that, we return to the wisdom of our first source, the academic paper. If reification is the shared disease, the paper proposes a highly structured antidote called the de-reification protocols.
Protocols.
Yes. But the authors emphasize a critical caveat. Because Path C conformists and Path B zealots operate with completely different psychologies, the protocols must be highly differentiated. You cannot use the same tactic on both.
A one-size-fits-all approach will just blow up in your face. Yeah. Let's look at the protocol for Path C first.
Okay.
These are the mundane, low-energy conformists, the people who just outsource their beliefs to the evening news or their high school textbooks. The source says the primary goal here is to make outsourcing costly. How do you actually do that in a conversation?
The paper outlines a 4-step sequence. Step 1 is direct encounter. You have to force a minimally mediated encounter with raw physical data.
So cut out the middleman.
Exactly. If they believe in the globe, don't let them cite a NASA photo. If they believe in the flat Earth, don't let them cite a video online. Make them go outside.
I love this.
Tell them to buy a surveyor's transit, go to a large body of water, and attempt a personal measurement of the horizon under controlled conditions. The psychological goal is to create a small epistemic debt. They now have a personal, physical observation that they must actively reconcile with their inherited model rather than just passively trusting authority.
You take away their crutch. You take away their ability to shrug and say, well, the scientists say so. Step 2 is the pre-commitment device. I think this is one of the most powerful psychological tools in the entire paper.
It is brilliant because it tackles cognitive dissonance head on. Before you show them any anomalies, you elicit an explicit public statement
stuck right now. It's the year 2026, and we still have no verifiable measurement of curvature to support this globe myth. And that's what's so frustrating. That's why we're here. We're here to tell people about it.
I see it now. So your point is like opening the eyes of people, let's say, or like to give enlightenment in their lives.
I wouldn't presume to say that way. I just want people to consider that they've had no experience directly with the globe, and no matter how hard they try, they won't be able to, and they'll find that nobody who even claims to have actually did either.
Yeah, I see that.
You know, I'm a theist, specifically a Christian, and I've been in debate circles with atheists for a long time. And if I can make this analogous to anything, it kind of feels like how the atheist feels being surrounded by a bunch of religious nuts. Being the flat earther and surrounded by a bunch of globe religious nuts. So you'll have to forgive us sometimes when we get impassioned about this, because it is quite an important topic. It's important for your very dignity at the very core, right? I don't want to be pissed on my back and told it's raining. Now, does that mean it's going to change how I live my life? You know, I still need to go to the store to get groceries. I still need to fill up my gas tank to drive places. I still have to work my job and do the same thing at my job day in and day out. But I tell you what, I'm able to think and process my world without the burden of carrying somebody else's imaginary myth through which to process all of my firsthand direct knowledge and sensory experiences through anymore. I can process the world as I see it and I experience it, and not suffer the dictates and mandates of somebody else.
Yeah, I see it, but coming back to the example of being pissed at your back and the shape of the earth, like I still don't think that the example of being pissed on your back and being told that it's a rain, it's quite equal as the shape of the earth, because nothing of your
It's a bit
changes.
crude.
Yeah,
I get that. It's a bit crude, right? I mean, I understand the sentiment where it's coming from. There are space agencies that have lied about their achievements. Now, I don't think they're necessarily lying about Earth and the nature of it for that purpose. I do think that they are lying about achievements for the sole reason of projecting national pride, power, prestige, technological progress, whether that's for the end game of making more money, increasing military and technology sales, or for concealing the development of doomsday weapons like nuclear missiles. Whatever their true motivations are, they are projecting power and capabilities through this and technological achievements that never happened, provably. So there's where the piss comes from.
Mm. Well, I've recently read the chat and Yaga Bruno, but still, like, I wouldn't like to philosophize the words, but like the way eventually it was like weakness is like neglecting your duty, like the one you have aforementioned, but still, like, let's be realistic here. Then it goes to what is your meaning of life and what's your duty in life. Is it like to guide others? Then, like, why would you guide others? Is it because you feel better, or is it because you think that you have to guide them, or is it because they are in need of guidance? And if they are in need of guidance, what makes you not being in need of guidance as well? Like, or is it the someone you
Point.
want to? Yeah. So you see, like, the thing of weakness makes no sense. So I guess it's more of a claim that neglecting the
No,
specific duty is
I
weakness.
think
Like that.
I think you can objectify this sense of weakness that Jedi was talking about. Um, we have a tendency to sometimes do things that are not in our own best interests, but we delude ourselves into thinking they are. So when it comes to the psychology of economics, human behavior, it used to be called praxeology before it was called economics or catalactics. It's the psychology of human preference in a market. Now, the reason why we act is to dispel uneasiness, however that comes, but we have choices before us on how to do that, on how to act. A weaker choice is often associated with having a high time preference. A high time preference means you need something, want something now, and you'll do whatever it takes to get it now, immediately, to fulfill a sense of gratification now. There are biological reasons for this. But in many cases, it is more rewarding and beneficial to yourself, to those you love, and to those in the market if you have a low time preference, which means you defer gratification in order to save up and store for the future. And one of the reasons why a low time preference can be more beneficial is because it helps you mitigate risks that can also happen in the now. If you store up enough food for emergencies, you must have a low time preference in order to exercise that discipline. If you consume the food instead, you won't have any stores for those times that you might need it. So exercising that discipline requires inner strength. You can't be a weak person and exercise the discipline that's required for having a low time preference in order to store up food for the future, which would make you and your family and everyone else around you better off. Does that make sense?
Yeah.
All right. So I think that's where Jedi's mind was coming from. In a sense, coming to the conclusion of flat Earth requires discipline. It requires you to be honest with yourself about how you first experienced the world. And it requires you to then be honest about how you see others interpreting and experiencing the world and coming to the conclusion that it's a globe. When you start to understand not just the psychology, but the very methods and processes that they go through in order to arrive to that conclusion, it becomes quite obvious and clear that not only is the Earth not a globe, but people are taking their everyday observations and interpreting a globe out of it when it doesn't exist. And you know how exactly they're doing it. And you know how they're trying to justify it with math. And what's maddening is people believe that they are justified in their interpretations of a globe due to mainly societal pressure. It's kind of what it comes down to. This is like a big Ash conformity test. The globe is. You've got a room full of participants, right? And the mark doesn't know that all the other participants are in on it. And what happens is a proctor who is coordinated ahead of time with the other participants will tell them to answer falsely a simple question and to do it on purpose in order to instill confusion on the mark. So they'll go down a list of people, ask them stupid questions, and they'll give stupid answers. And the mark is meanwhile wondering what the hell is going on. How come people around me are answering so confidently that they believe these stupid things to be true? And when the proctor gets to the mark and asks him the stupid question, will this person conform and give a stupid answer? Or will he have the discipline, the resolve, the mental grit and fortitude to give the right answer and to be honest with himself and give the socially unacceptable answer? So when it comes to the question of weakness, yeah, we're tired of dealing with weak men. We need strong men who will pass the Ash conformity test, who will stand up against a room that seems to be out of control and crazy, but conforming to common silliness, and break through the mold and declare, no, you guys are actually all wrong, and I know what's right. This is the truth.
Is it the wisdom of Master Yoda or is it the wisdom of AI? Because I kind of feel like you were reading a text and not saying it. No, I mean, no offense, because like
No,
even I use AI to some points,
yeah,
but
I
let's be
don't. I
realistic.
don't. You'll have to just take my word for it. I'm sitting in a parking lot right now, and it's windy outside. I've got my phone in my hand. I'm waiting for my kids to be done with the gymnastics event, and it's crowded as shit in there, and I can't get in to see them. So just kind of waiting. Got another 10 minutes.
Oh, well, I see it now. Quite cool. Well, I gotta move. Goodbye. Have a nice day.
Okay.
Don't be
Adios.
stressing about everything and every people again. See ya.
Hasta lasagna.
Don't get it on ya.
That's a bizarre worldview. He listens to everything you said and he comes up with, was that AI?
Yeah.
Nothing about the content.
He was processing the content, though. I believe it. He seems to be very educated, and he does dwell on these issues a lot. And I think he prefers to dwell on these than the room topic of flat Earth. But I think it was worth tying it in. Now he I think prides himself on being able to ask thought-provoking questions and to get enlightened discussions going. But I'm not sure what his worldview is, but I suspect it's probably going to be closer to brain in a jar, postmodern relativism and solipsism than anything else.
Right.
I just kind of get that feeling. So, he wanted to ask a thought-provoking question back to Jedi is, well, what do you mean you're dealing with weak men who don't want to stand up for things? Like, what do you define as weakness? Earlier we had just talked about how this whole thing is a delusion and it takes a lot of strength to pull yourself out of it. We didn't quite get into the social pressure until we came back to it at the end.
Yeah, that's true though. That's very true.
Right, and it could have gone into places. I mean, so Jedi brought up the analogy of, they're pissing down your back and telling you it's raining anytime they show you basically a globe on TV or whatever the case is, when you're being inculcated with the globe all day on things that don't make any sense. Like you'll see a globe logo on a stick of butter for a commercial and be like, what the fuck? Why do you have to put a globe on that? I mean, it's almost like a sick, perverse obsession that people have that they're also not really consciously aware of at the same time. So it's just such an endemic part of our civilization and how we view ourselves is we are enlightened technologically and we are advanced civilization and we live on a globe. It's kind of part of our worldwide shared cultural identity.
Yeah, for sure.
So breaking free from that, I mean, really means rejecting all that it stands for. And people don't want to be put into that position because they don't want to be seen as a pariah by their friends and family and neighbors. There's an obvious risk issue there. We are herd-like people. We do know and recognize that we survive better when we come together and do things, whether it's participate in a market or otherwise. And if you've got a bad actor or a participant in your community that's just this oddball freak, the natural inclination is to peacefully disassociate, and ostracize. And ostracism is such a powerful, powerful way to deal with something you want to reject. I mean, they say that social ostracism psychologically inflicts more pain than physical pain ever could, than torture. And people inherently fear being socially ostracized as a consequence of rejecting what this world believes to be true. And so we're dealing with that psychology every time we're in here talking with people. And I think it's very deep. And whether or not the people we're talking to understand it and can articulate it this way is kind of irrelevant, because they're responding as if they intuitively feel this way. And so they're recoiling. We hear this all the time. They say, well, how could everybody be wrong? How could NASA be wrong? How could all the scientists be wrong? How could everybody else be wrong? And they turn it around and say, you flat earther must be the arrogant one. You must have this Dunning-Kruger complex. Who the hell are you to go against this entire mountain of belief? And well, who am I? I'm just somebody who has the mental fortitude to call it like it is, to describe the world as I see it, and to describe to the world how they're misinterpreting it. Quite obviously so, objectively so. We can prove it.
Yep.
So what Jedi said about us needing to basically foster a culture of strength and to deride weakness around us, I think is absolutely on point. It needed to be said, and he was fully right in engaging this guy in that way and saying so.
It's far away when it's above you, and you can't stare at it because it burns your eyes. But when it's on the horizon, you can. Why?
Because when it is above my head, let's say, it is closer than when it is.
That would make it worse, bro.
Welcome to Flat Earth.
Yeah, I mean, when I see it above my head, it hurts. When I see it on the horizon, it doesn't hurt.
Yeah, why is that? Why is that?
What do you mean, why is that?
Why can you stare at it when it's on the horizon and it doesn't hurt your eyes like it does when it's right above you?
Is it because I'm looking through all the air? Is it because I'm looking through all the air?
No, the air doesn't have anything to do.
Yeah, it does, bro. You need to look into it. Your own side says that you're looking through the thickest, densest part of the atmosphere, causing the scattering of light, thus the redness of the sun at sunset.
But we're talking about different things. Like, we're talking about why my eyes doesn't hurt when I see the sun when it's
so am I.
Horizon.
It's the same reason why when you look out at the horizon, you can't see 1,000 miles because you're looking through air. You're not looking through a vacuum.
Yeah, but it's the same sun, and it's different distances.
Yeah, there's air. The air is getting in the way. Gas molecules. Remember?
That's what I'm trying to understand. Like, why the air has to do when it's closer than when it's farther.
When the sun is directly over your head.
You're not supposed to think it's significantly closer or further in your paradigm of the globe. That little bit of difference that it makes is negligible. It wouldn't make a difference from your own side's point of view. You're not supposed to be arguing that. That'd be more like something that we're supposed to argue, that it gets closer and further away. Because it's not 93 million miles away.
I'm not arguing.
It's a known fact. It's a known fact, man, that when the sun is directly over your head, that the air is less dense, because as you go up in altitude, that there's less air.
We agree that it is closer when it is right above my head than when it is in the horizon, right?
I mean, if that's what you want to argue, we agree, because that's what we all see. Yeah.
On the scale of 93 million miles, bro, what difference is that going to make?
It's 93 million. It's 3 miles farther, so it's 93 million 3 miles.
Oh, that's going to help. That's going to make a huge difference, right?
Well,
93 million and 3.
Even if it's that close,
in the globe, this is what we're trying to tell you. In the globe model, the sun is 93 million miles away. Above your head versus on the horizon, it's 3 miles further away.
Okay, so but when
you think that matters?
Take the example, okay, but when we take the example of the table, it doesn't matter. But when we take the example of the sun, it does matter. That's what I'm trying to understand. The
air is thicker. The air is thicker.
but taking different objects of
Do you have
of,
weather?
of
Do you have a weather app? A weather app like on your phone?
I don't, but I can
A
search on
weather.
Google.
Okay. But if you
Yeah.
searched on Google right now and typed in whatever you live, like say you live in Tokyo, Tokyo,
I wish.
Japan visibility, it'll tell you how far you're going to see. Where does that number come from? Say it says 10 kilometers, visibility 10 kilometers. Why is that?
You tell me.
I did tell you. It's because the air
Because of
has
the
a
air,
thickness.
or air thickness.
You're
Okay.
looking
Yeah.
through the thickest part of the air if you're looking horizontally.
So it
There's
depends
less
where I
air
am.
looking up. Yeah, there's less air looking up. There's more air looking sideways.
So when I'm trying to see further, there's like more air particles. So
Yes,
I'm.
light comes to you, brother. And there's less water particles too on top of it.
Uh-huh.
Because
So
as you
what
go up higher and higher altitude, it's drier, right? There's less humidity.
because the sun is closer.
Doesn't matter what the
So
reason is. It only matters whether it is or not. So yes,
but I
there's less
think
humidity. The reason is irrelevant, dude. We only care about how much is there. We don't care about why. We only care about
but
whether it is or isn't.
that's the thing. That's why I don't get why in some topics it doesn't matter and in some does. Like
Okay.
why do we
Because right
take
now we're talking
like
about something
partial things?
you're being a sophist, and I'm starting to get annoyed. There's a
No, he
difference
doesn't get
between the
any of
question
the
of whether
topics.
something, listen, there's a difference between whether the question of whether something exists or does not exist and why it exists. Those are all
He,
different questions, right? We want to know
Well,
what does it exist or not.
well, it was you that
Like I
bring
can
God
say, hey, do you have
into
a
this.
sister? Do you have a sister? Do you have a brother?
I do.
Okay. Do I need to know why they're here to know if they're here or not?
I don't believe
Whether
why.
they exist or not. No,
No,
I
but
don't need
that's
to
the
ask you.
interesting part.
Well, when did your parents have sex? Like, I don't need to ask you that. Either you have
They
a
do.
sister or you don't. It doesn't matter how she got here.
Okay.
Okay, like
and
you're
doesn't matter
not this
why.
dumb, bro. Okay,
But that's my point. Like in
you don't have a
previous
point.
chat. Yeah, in previous chat
No,
that we
it's not
had
that he
before.
just. It's not that you don't have a point. You don't even have comprehended any of the points that people have been given to you. So you still have to be able to even steal one of the points that have been brought forward to you. You don't
The
get
thing is,
any of the points, not one.
I do get the point individually, but I don't connect them between them. Like we talked about God, we talked about how it was designed. Now we are talking that the sun does this, does that, the light, the tables. I cannot connect the meaning and prove with those all things together. That's what I'm trying to say. And if I may add, I know and I am thankful for that from you that there is a language barrier and you're being very patient. So I do thank you for that. Um, if you understand what I'm saying, is that
I
the
do. I understand.
all the points that we talked in this, I think it is an hour. Uh, they don't connect between them. All the topics that we talked before, you know. I'm trying to believe. I'm trying
Well,
to
whose
connect
fault
You
is
them.
know
that?
why? Listen, guys, one second. You know why? Because when the guys were trying to tell you about level, about water, about long distances, you were going to the moon, to the sun, to the sky. And those celestial things are not the ground that we can operate, check, verify across, the one that we can test and measure. And people have been trying to describe for you and trying to explain to you how to get it. Your mind is going outside of that, away from the thing in question. That's where you
Here's
don't
what
get
I
it.
don't, Jamesy, here's what I don't understand. How are you telling us they don't connect and they don't make sense when you brought up the sun?
I
We
think
didn't bring it up. You brought it
it
up.
is
If it doesn't make sense, it's because it's your topic.
I know. I'm think that it is available example, and
Who brought it? Who talked about the sun? Us or you? Who brought it up?
the guy that was talking.
So he said the
before
sun
me.
proves the flat Earth. Is that what he said?
No, he had a question about the light and the sunset.
I'll tell you how it got brought up in Indio. He was asking why we can't see the Eiffel Tower from New York, and I explained to him the thickness of the air, and he didn't understand what that meant. He thought that we could just see forever because we can see the moon and the sun. I said, yeah. So how come we can see the sun on the horizon? We can look at it, and it doesn't hurt our eyes, but when it's directly over our head, it'll blind you. And then that's how we got into this whole conversation. But he did.
Okay, I get it.
He did bring it up first. You just don't remember bringing it up.
Okay. Can things be too small to see?
Let's say it does.
Okay, let's just look. We're gonna start over. We're gonna can objects like the Eiffel Tower be so far away it's too small to see? Now let's say we took the Eiffel Tower and we put it on the moon. Would you be able to see it on the moon?
With bare eyes? No.
Okay, there's your
think I
answer.
couldn't.
There's your answer, dude. There's no way you're going to see a 500-foot tall building from 5,000 miles away. It's too small to see. Never mind the air, even if you were in a vacuum.
But it's like pretty
There's no
small.
but.
I mean, yeah, there is. I mean, if we are talking about a thing that it is,
I can promise you. I'm just going to say this real quick, and I'll back out. I can promise you that if we put the Eiffel Tower on the moon, you wouldn't be able to see it either, even with the world's most powerful telescope. If they say the moon is the size that it is, because they say that the moon is 238,000 miles away. So I don't think you'd be able to see a 500-foot tall object 238,000 miles away.
So now I have a question about that. Where I'm from, depends the day or actually the night. The moon.
Here we go. Sun, moon. This is flat Earth, dude. This isn't flat moon or flat sun. If it doesn't make sense, I just want you to remember you brought this up.
Yeah. I'm talking about the moon. Like we were talking about the Eiffel Tower in the moon. I'm like following the line. The moon in the night where I'm from.
You're following the line the wrong way.
I'm trying to understand the way I can.
The line that is being drawn for you, that the world that you operate in is a horizontal line, and you're trying to go away from that. If you don't comprehend the ground that you operate across, you're not gonna get anything about the moon or the celestials or the luminaries. You first have to come back to your senses, back to the ground, and figure that out first. Then maybe you can entertain the other things. But you're still in page 1. You haven't finished the test for page 1. You don't have the right answers. You don't have all the information to complete the comprehensive assignment that you can draw a logical conclusion about the whole thing. And you're asking about unknown wonders of nature like the moon and the sun. You're not gonna get that. So just chill.
Wouldn't be the sun and the moon and the stars a good measurement from where we are? Like we take
Definitely
different
debunk
things.
the idea of the globe. The movement of the luminaries as they move in cycles that repeat like clockwork. It will definitely easily show you that the globe idea is an impossibility.
So it is a good measurement to tell if it is flat or not.
No.
Right? It's what you're saying right now.
Not.
It is not. Why?
No. Because no matter what you do, you're making what's called an inductive argument. You can't look at something that is not the object to determine the object. Like if I wanted to know how tall you were, I wouldn't go measure Gemsy. I'd measure you. What you want to do is you want to look at something that's not the Earth to figure out what the Earth is, and that's not possible.
Well, that's the thing. I mean, if I say I am, which I am,
What's the thing? You're going to try to convince me the impossible is possible? No, brother. Are you going to try to convince me the impossible is possible? That's what you're going to try to convince me of.
Let me try. So if I am, yeah. I mean, let's talk it.
It's logically not possible, dude.
If I am
tell
190,
your height by measuring Gemsy?
If I am 190,
tell me how I can measure. No, brother. We're not moving on.
Hey,
stop.
Let me talk.
Can I measure? Can I figure out how tall you are by measuring Gemsy, the guy that was talking to you? Can I measure his height? How?
Yes. If you
he
put
just said yeah. You just said yes.
Next to, yes, I do. If you put one next to
another. No, we're not going to use you. No, just measuring Gemsy. That's it. Just Gemsy, not you.
That's what I'm saying. If we
have to measure you, right, to know how tall you are?
No. But let me finish. If you put how's it's
you're a bullshit artist,
MC. But why do you?
No,
why
you're
do
a bullshit
you get
artist.
angry,
You
man?
know you're trolling, dude.
I'm not trolling. I'm saying
being
you can't be this
Hey,
stupid,
Hippie
so
must
you have
also
to
be a
be
Puerto
trolling.
Rican. Hippie must also be a Puerto Rican, dude.
I am not. If you say
no, you're comparing yourself to
fridge.
Gemsy, man.
No, just keep it. No, let him to finish. Go ahead. Say what you're gonna say, and fucking put your foot right in your mouth.
Okay.
Because you're gonna. There's nothing you can say that's gonna fix this, dude.
Okay. If I say my fridge, it is 1 meter tall, right? Okay. And I say I am 1 meter 90, and we put both together. You can tell if I am saying the truth or not. That's reasonable, right?
Yeah, but we measured you, dude. We measured you. We used the fridge to measure you.
You are measuring
that's right, dude.
the fridge.
We used the refrigerator. Okay. Listen, we used the refrigerator as the unit of measure to measure you. Okay?
Exactly.
You're talking about not looking at you. Stop talking. You're talking about.
You can interrupt me, but I can interrupt you.
You got to over. No, you're over talking me because you know you sound stupid. So you're talking about not measuring you at all, and just measuring the sun and the moon.
No. I'm saying that if you take an object, you measure that, you can have at least an idea of the object that it is next to it. You know, that's what I'm
but
saying.
you would be seeing you like if I was measuring you next to your refrigerator, I would be the point of view looking at you in the refrigerator. I can't jump away from Earth and look at the Earth and the moon side by side. That's how retarded you sound.
Well, that's another topic.
Let's say you see the moon, right? You can see the Earth, you can see the ocean. You're on the beach, right? You can see the Earth, you can see the ocean, and you can see the moon.
Yeah.
Right? They're right next to each other in your vision. How big's the moon?
Yeah.
How big's the moon?
I couldn't tell.
Why not? They're right next to each other.
Yes, but as this other guy said,
this is what
I
you
am
said.
in
You
the
said
Earth.
that they're right next to each other.
No, but he had a good point, not you.
Yeah, that's right. Change it, dude. Yeah. You sound dumb, bro.
But why do you get aggressive, man? I'm saying he was right.
Because listen, you stopped being honest like 20 minutes ago, and you stopped engaging us honestly 20 minutes ago, and I'm not happy about it because you were being honest, but you stopped. Okay,
no,
and now you're just trolling.
You got angry.
You don't believe what you're saying, dude.
Yeah, I do. I'm trying to get from my perspective of ground Earth how you.
That's not your perspective, dude. No, brother, you've never had the perspective of around Earth.
It was indoctrinated from me that it is ground Earth. I mean, it is my beliefs.
What's
it's your belief, but it's your hold on. It's your belief, but you've never actually.
Yes, it is.
Will you let me finish? You've never actually had that perspective in reality, right? If I said from memory, what do you remember the Earth? When do you remember the Earth looking like a round Earth? You can't tell me from your memory, can you? You don't remember that.
Remembering what? That it was round?
Remembering when you saw with your eyes the Earth being round.
No, I don't.
Okay, neither do I. I don't remember that, and nobody in this chat remembers that ever happening. Okay, nobody you know and nobody they know remembers that. Okay, so when you say
I
from
agree.
my perspective, it's not actually a perspective you had in real life. It's what you imagine. It's your imagined perspective.
Hey, India,
and that's why we're
right.
trying to
I think
listen.
I think that the word that imagine, it isn't the word. I think that it, as you said, it is indoctrinated and taught like when we were a
Yeah, we
kid.
got taught the same thing. Yeah, I got
Okay,
taught the
but
same
it is
thing.
the word isn't imagine.
Hippie.
Yeah.
If the surface of the Earth is not curving into a ball, then the surface of the Earth must be what?
That's an assumption that it is kind of.
It's an if. It's a hypothetical.
Yeah, but why there's only two options? Why it isn't square, for example?
It could be square, but that would be flat, though.
Yeah.
Okay.
What's
so
the third option? If it's not curved, so you have
we're going to
two options.
something.
It's either curved or it's flat. And then once you define that it's curved, then you have two options from there. It's either convex or concave. Do you see how that works?
I'm talking about the shape as in square or circular.
We don't know what the shape is. We don't know what the shape is. It could be any shape. It could be an octagon. For all we know, the UFC got it right, and we live in an octagon. That's why we're always fighting each other.
Is that right?
Let's get ready to rumble.
That's actually that's actually something true. Like it's an octagon or
no. What he's trying to tell you is if the water, right? The water, it either curves into a ball, curves either way, or it's straight, right? So it's one or the other, and we can figure out.
Straight. Yeah. So if it is straight, does it fall?
Fall to where?
Hippie, look in the side
question. Fall to where? Where are you going to fall to?
I mean, the
water. Look in the side chat. Look in the side chat.
Yeah, where would the water fall to? First of all, it wouldn't fall because there'd be a vacuum, right? And water evaporates in a vacuum. So that isn't going to happen. So fall to where? See, this is more like imagination. See, when you think about the Earth, you have to rely completely on imagination. We're trying to get you to think about what you actually experience in your life, okay? Not what you imagine the Earth to be, but what you actually see it in real life to be, okay?
Hippie.
So
look in the side chat. Look in the side chat. I just tagged you. Which of these shapes are flat?
I'm trying not to look to the chat because Platter is going with all the jokes, and I can get the serious stuff, you know.
Just look at the picture I posted. That's all I'm at. Look at the picture I posted, the image I posted. Which of those shapes are flat?
Let me say, I like you, Platter. I like the jokes. I'm not that sensitive. I'm seeing the shapes. Yeah.
Yeah. Which one's flat and which one's not flat?
Could all be flat.
Okay, cool. So flat is not exclusive to like one shape, right? Flat is just a feature of the surface, right?
Yeah, I know. I thought that you like went farther and you knew the shape. Like it was something like you already achieved.
We just know it's not a ball because if in order for it to be a ball, it would have to curve.
So what's the next, let's say, step to know what the shape is?
It's a good question, man. You'd have to go to the extent of the entire universe to figure that out.
So, let's say, how do I make this question? So, we didn't went to the moon.
Hell no. Why would you
No.
think we did?
That's a trending question. I'm asking really seriously. Like, if we did
Nobody
get
went.
to the moon,
Nobody's been. Listen, brother, it's worse than that. Nobody's been to outer space.
so it was all a lie.
You got yes. It's made up. It's a fairy tale.
It was created
Oh,
to exert dominance over the rest of the world.
Now there's NASA documents from when NASA was created saying that they wanted to create the impression that the United States was so technologically advanced no one would oppose us. And that's why they created NASA.
so what's the point
In their
about
own
that?
words, it says that. It isn't what I say. It's in their own words. They
yeah,
said that.
no, I believe, I think I read it. I don't want to say I did because I don't remember. But the thing
Well,
is,
there's
I don't
declassified
understand why.
documents.
What's the point about that? That's what I don't get it. Like, why
I just
would they
told
do
you
that?
why. The reason they said they did it was to create the idea among foreign people that the United States was very technologically advanced, and if they tried to make war with us, we had such great technology that they would be destroyed.
So it's like a war power thing, let's say.
Okay, think about it like this. Say you could go out and buy, you know how there's people and they can inject in their, they can get implants, right? Like,
Yeah,
and make it look like they got big ass arms and they're jacked, but they couldn't freaking curl 10 pounds. So
yeah,
that's what we did, right? We basically put on a fake muscle suit and walk around
yeah.
like we're huge when we're freaking skinny.
So
Okay,
you try
so
to appear as someone like very strong, very powerful,
yes,
to other
That's the
countries.
art of war. That's the art
yes,
of war. When you're weak, appear strong.
So Russia, let's say, and China, and all the other, like the space war or space race.
there
I don't
wasn't
know
one.
how.
There was no
There
space
wasn't
race.
one.
Well, according to the Russians, the Soviets said that the United States made up the space race, that it only existed in Western media.
Well, I like what Platter said. Right now, I'm reading the chat,
Well, I mean, shouldn't
but
it? Listen, doesn't there need to be two people in a race? And if the other person says we're not racing, and the other person's running around the track by themselves, is that a race?
yeah, no, but yeah, no, but
Well, I'm just telling you what they said. They also say that the moon landing's fake, but
Yeah,
nobody
and if you
believes
want to
them
get
because they're the lying Russians, right? They're the
the
commies.
thing
Whatever
is,
they say is a lie.
the
if,
thing
if
is,
you want to get
us,
into why they would lie, like, okay, so let me explain this to you. Okay, there's a lot of
but can I?
sub reasons for why people lie. Oh, I lied because I didn't want you to get hurt. I lied
Yeah,
because I wanted to be better than you. I lied because of this. I lied because of that. But the real reason why people lie, there's only one reason, and then every reason under that is a sub reason. The reason why people lie is to control how other people think. That's
okay.
the
So
only reason why people lie.
have you ever thought that, as Platter said right now in the chat, this isn't like another way to divide in people, like being flat Earth or ground Earth,
No,
isn't like
it's
another way.
no. You're the only one divided from us.
But that's the point. Like, why are we divided? Like, we are in the same
Why,
Earth.
why are you defending the governments of the world?
No, no, no. I'm taking the point that Platter said that it is a way to divide in people. The thing that the space race and what NASA said, and like, why are we arguing if the Earth is flat and or the
I
Earth
don't
is
know.
ground? That's
Why
the
are you
point.
defending an
That's
idea you don't? Well, dude, you came in here, right? And you came
yeah.
and you
Trying to
started
understand.
Hold on. You started defending an idea that isn't yours, and you don't really
Mm,
understand it very much. I mean, you understand it a little. We all do because we all went to school, but most people don't understand the globe and all the stuff that goes along with it. But they'll defend it to their dying breath. Why? Why would they defend it? Like,
I'm
And
imagine
call us
somebody else
stupid.
like down the street had a good idea, right? Are you gonna run around and yell at people because their idea and take it up like it's yours? That's what people do. We've been doing this for nearly a decade, and we watch people every day, dozens of times a day, come in here and get angry, get mad, yell at us, swear at us. Someone last night saying we should kill ourselves, drink bleach, all this stuff because we don't think the Earth is a globe. Now, you tell me why they do that because I haven't figured it out, other than there must be an occult or something.
Well, I agree with you, like 100%, and that's why it hurts me when some people are trying to be open-minded, like me or the other girl that entered here and try to be. But you have to understand that we were taught that the Earth is ground all our lives, and it's like
So
I
were
don't
we.
know.
So were we.
Yeah, but if they
So
taught you,
were
let's say they
you.
taught you, brother, let's say they taught you frickin' Greenland was covered in ice and then you found out it was a desert, would you be upset?
I'm trying to finish the other idea. What I'm
Well,
trying to
but
say
I'm
is
saying
that
is people get upset about it. You're missing the point is that people are getting upset. Okay, learn something in school. They're getting told what they learned in school is wrong, and they're getting emotionally upset about it.
but
That's
being
not
you
normal.
upset, being you upset also doesn't like give us uh give us, when I say us, is like ground earth, uh the point. Like, why are you upset about it also? Like, if you
We're
are
not
right,
upset.
why
We're
would
not upset,
but
hippie. Hold on. Now, you
don't worry.
mentioned that girl earlier. Some guy came in and said, because you're a girl, you don't understand shit. That guy was
Yeah, that's
likely a globe. Hold on. That guy was likely a globe earther also, like you. He was just coming in here to talk shit because that's what globe earthers do with their low IQ personalities. Now, you think a little bit more sensibly because we did that. Remember, we did you missed it, India. We calculated the circumference of his kitchen by
yeah,
measuring two angles of the of soda cans on his floor. It was
yeah, we
fantastic.
did.
His kitchen is
Awesome, man.
24 meters in circumference.
Yeah, and the Little Prince planet, freaking awesome.
Now I have a fucking huge
But
kitchen, man.
but
Yeah, that was awesome.
so we don't go around shitting on people all day. That's not our nature. We actually, believe it or not, flat earthers have a genuine appreciation for the life around them. So when someone comes in and says, because you're a girl, you're a piece of shit, or whatever he said, that's not us. That's probably somebody that's on your side who thinks the earth is a ball and is a godless heathen and doesn't know how he's going to get live life once his mom and dad die. Like
Well,
it's just a thing, man. That's not
now
us.
now
That's your side.
if I'm being honest, like, since I don't believe in God and I feel kind of excluded just by that, I think like all the people that doesn't believe in God has to find a way to actually believe what you're saying without proving that there is a God. You know what
It's
I'm
not about
trying to.
belief. It's not about belief.
This is different
All
than
right.
God. Okay, God. The question of God is a metaphysical, supernatural question, and the question of what the Earth is a question about the natural world. Right? Those are two different things. You can't
So it
prove the
can be
existence or
proven.
non-existence of God with the natural world, but you
Okay,
can't like the thing. People that don't believe in God, I go, okay. I'll say to you this:
yeah,
what would prove to you God exists?
I I do not believe
What?
so.
Well, okay, I know you don't believe, but what would prove to you that God exists? What evidence? What type? You don't even have to tell me exactly what the evidence would be. What type of evidence? Would it be something from a scientist in a test tube? Would it be a freaking reading on an instrument? Like, what would it be that would prove God exists to you? And if you ask yourself this question, you'll find out that there's no evidence that would prove God exists to you that you'll accept because you don't want God to exist. This is a matter of desire. It's not a matter of whether it's true or not. And this is what we tend to find out with people. But I don't want to make this topic about atheism versus theism.
Yeah, no,
The
no,
thing
me
is,
neither. Me neither. I'm sorry
so
that I brought it
the
up,
point is
but
that they say this is how you figure out what in science. They say you do this to figure out what the natural world is. Okay, let's go do this. They say the Earth is a globe. Let's go check. And we in here, me personally, even as recently as last week, I go to the beach, I make measurements, I go check, and every time I go, it turns out that where they say the Earth is a globe and that the measurements do not match that and do not check out. Now, I'm supposed to ignore all that, what I've done personally in real life, and watch TV and go, listen to some guy that says, oh, I went to the moon in a rocket ship and I dropped stuff and they didn't fall. And I'm supposed to believe the words of some idiot on TV when I've gone out and actually checked, right? What am I supposed to believe, dude? Me or the TV set?
yeah,
Right?
that's
We're not trying to convince you the earth is flat. A lot of people come in here, they think we're trying to convince them the earth is flat. No, we are here to give you information that you did not have otherwise, right?
yeah,
Such as you,
yeah,
that's it. You can decide for yourself what you want to do with that information. You can fact check us and say those flat earthers, I'm checking to see what they said is true, and go on the internet and look and see what we said is true. You'll find out that everything we say is 100% factually accurate. Now, you might disagree with the conclusions about the facts, but that's a different thing, because there's
yeah.
always
That's just
interpretation. There's always
that's a you
interpretation of
thing.
facts.
Yeah, yeah,
Well, there's
yeah,
always
yeah.
interpretation, no matter what. You have data, and it has to be interpreted by a human being. So, but the thing is, there's certain things about the globe that they teach us in school that um, they don't tell. They only tell you the things that work, right? They never tell you. They don't. It's like selling a car, a used car. They tell you the good things about the car, but they don't tell you the bad things about the car. Now, in
Yeah,
certain respects, the globe model, I guess, if there is a model, it works in a certain there's a certain parts of the globe model that work, but there's other parts that don't work, right? So, but they don't tell us the parts that don't work. We in here, we know about the parts that don't work, and in the interest of full disclosure, we think that everybody should know, like, yeah, this globe idea isn't as solid as people think when you actually investigate it. And the only and I say, and I'm going to say it again, is the only way to know for sure is to test it yourself. You're not going to learn it from, I mean, you'll learn things from us, but you should check what we say. You shouldn't just listen to us and say, I don't believe NASA anymore. I'm going to believe the Flat Earth channel. No, don't do
yeah. As
that.
we
Go
did
out, go out, test it
with
yourself.
Smoke
Like,
Dog
I'm not worried
with the
about you
kid
testing it
challenge.
yourself. I encourage it. Go test it yourself. You'll find out the Earth is not a globe at all.
Yeah, and
So
he's already said that he's seen boats that he believes to be 20 kilometers away, uh, disappearing at a distance, right? But
mhm.
aside from that, hippie,
And you can
if
check. Hold
NASA
on,
came up,
just to give them. I want to give them a resource. Just to you can actually check their distance. There's a website called marinetraffic.com. It'll give
I'm
you the
searching it
positions
right
of
now.
boats. Huh?
I'm searching it right now. Marine
Marine traffic.
traffic.
TRAFFIC.com.
Yeah, yeah, yeah.
It's got boats all over the world. When you click on the boat, it'll give you its coordinate, right? Its latitude and longitude coordinate, right?
Yeah.
And then you can figure out there's all sorts of what's called Earth curve calculators. You can get your coordinate where you're viewing it from, its coordinate where it is. You can ask one of the AIs, say, how far away is this latitude from the latitude, longitude from this latitude, longitude? It'll do the calculation, and then you can see, hey, should I see this boat based upon the Earth curve calculator? So one I did was capture the boat on the horizon. It was 10 miles away. Well, the horizon should be 4 miles away. So that's a big problem. The horizon's 2 times farther than what it's supposed to be, right? And I've got all sorts of these. I've seen a boat 30 miles away. I've seen in 30, in case the conversion of that's like 50 kilometers. I watched a boat
But for
sail from,
example, yeah,
well, 50,
I'm
think
sorry.
about that, 50 kilometers away. I saw a ship that was sailed away from me. So it started in Boston Harbor and sailed out like directly away. And I could still see it at 50 kilometers away.
So at what point does the you know, the air particles start to
It depends on that day.
It depends
It
on the day.
depends. It depends on the pressure, the humidity, how much the wind, how much particles are in the air. The best day to do the best condition to do observations are you want high pressure and low humidity. So in Antarctica, right, they say in the Southern Ocean, there's a guide that the U.S. Geospatial Agency puts out. It's like a guide on how to sail in the Southern Ocean. Now, the Southern Ocean is the ocean that's, Chile and freaking South Africa, all that, and below Australia. Now, the
Let's say
air there,
like
the air
the
there is
Atlantic
very
Ocean.
dry. Yeah, the air there is very dry. And in their sailing guide, it says it is not uncommon to see mountains 300 miles away. Okay? Now, if you do the calculation for a globe Earth of seeing 300 miles from a ship, you shouldn't see any mountain that is shorter than 9.
Understand, like, be honest, because if you tell me 2 plus 2 is 4, for example, like hypothetically, and if I don't understand why is it 4, I should, if I say yeah it's 4, I've agreed to you without any understanding, that is even worse. I should ask you a question like, why? Tell me. You can explain it. If you can't, then I would ask you, then how do you believe that 2 plus 2 plus is 4? 2 plus 2 is 4.
Yeah.
So if you believe in a religious belief system with that, you believe that Earth is round, then I would ask you questions. Okay, I'm the stupidest person, but I have the questions. Would you like to answer or no?
Right.
That's it. I'm not going to believe in something that I don't have the answers to believe in.
Yeah, I mean, it seems to me when someone says, don't question something, that's just an obvious indicator that you must.
Okay. Yeah. I think people shouldn't believe many things. They just hear like majority agreeing to that because people are driven by their own inner desires and satisfaction. They make up norms. They make up like things that are just agreeing to majority's belief system, and they call it the moral thing to do. That's what they do. It's been
Yeah,
always that
well,
way. Back in the
keeps people
days,
in
yeah,
line,
back in
right?
the days.
Keeps them behaving.
Exactly.
Yeah.
Exactly.
Can't have them questioning what they're told. That could be dangerous for the state, for the structures
Exactly.
that keep people in place. So, what have you learned so far about Flat Earth from this room? What's
I
been
think this is my
presented to you?
second. Yeah, I think this is my second time, and I
Okay.
would tell you like I have a problem like like not talking to people. It's like if even somebody's having a really bad skill at speaking things, so I would just like help them out and understand them. So I wouldn't say I wasted my time. I was just like accompanying this guy who was a really beginner at English and he wanted to learn English. So I just spent some time with him, and I appreciate it. And with this guy, I'm so sorry I forgot his name again. It is
Ganja Rambo. Yeah, it's Ganja Rambo. You can just call him Rambo if you want. That's what.
Okay, yeah, Rambo is like much more suitable. Thank you, Rambo. So I had a conversation with him. He said like he kind of had a like he was not remembering me, couldn't recall me. So we had a conversation on that. So he did recall me after I told him that like I told you how I came to doubt my belief system, like the way people believed in round Earth. So he was like, oh yeah, I remember you. Then he sent me a friend request. We became friends today, not the 2 days before. And then that's you. And the 2 days before, we just talked about like how I think people shouldn't mock just because somebody has a different belief system. They should try to understand it, because what my siblings started doing is that when I say like, hey, why do you guys believe that Earth is round when you don't have any evidence? So they said, no, you're going vocal, you're becoming you're being brainwashed. So I was just telling him, like, my siblings and him, like, how people should not walk. The belief system, they should try to scrutinize it too. Like, you can scrutinize us too, right? If we are scrutinizing your belief system, you can scrutinize our claim, like, as to why we think what is like about Earth, right? They could ask me questions.
So you're new to like the evidence for Flat Earth, then, is what I'm hearing.
Yes, really. Yeah, really
Okay,
new.
so
Like, because I was to admit it, because I felt ashamed. Like I felt like I would be attacked, which is true. Like my family started mocking me. So this is a really common behavior in Asian cultures. Like if you go against the norm, they would just call you names and say you're going woke or something because they don't believe in Western values. To be honest, so yeah.
Well, it's honestly not any different here. So don't feel
Don't be surprised to encounter it. So you're saying you're questioning the idea of the Earth being a globe, or you believe it's flat, or I'm not quite sure
Mhm.
where you're at exactly. Could
Okay.
you just
Okay.
clarify that for me?
Yes, I would like to. So I am in the middle, like on the fence. Like I feel like that the belief system that I previously had that Earth was completely round, with a firm belief, just like other people in my family. But now I have started questioning it because I was never presented with any evidence. So I'm like
Okay.
now I have opened up to discussion. At first, I used to
Okay,
think
so
how
you
people are
haven't
even.
started to look for evidence then, correct?
Yeah,
Have
yeah,
Because I think the vast majority of us began this journey by looking for evidence of the things we were told to verify whether they were true or not. And having found no evidence, that's how we ended up here, and in fact, we found evidence to the contrary. So, I mean, I can just kind of walk you through it. It's really simple to prove that the Earth is not a globe. It's
yes,
really
please.
simple.
Yes, please.
Okay.
Yes, please, you
Okay.
can go ahead. But one thing I would like to ask you as a request, because I am still learning English and I wasn't I'm not educated on the topic. So if you use some vocabs that I've never heard
Yes,
of,
I
I
understand.
might ask you what that means. Okay? Would you be okay
Oh,
with that?
absolutely. And that's one of the benefits this
Okay,
room
then you
provides
go
is
ahead.
for advanced English learners to learn to expand their vocabulary because we do use a
Yes,
lot of
definitely
niche
go ahead.
vocabulary. Yeah, so yeah,
Okay,
please
I
stop me if I
appreciate
say
it.
anything. So, at its most fundamental level, it is well
Yeah.
understood that water is flat at rest, correct?
Yeah, exactly. Yeah.
Okay, and we're told the known Earth is, 72-73% water.
Yep. Definitely. That's
Okay,
what we have
so
been taught.
you cannot have a 73% flat sphere. Okay, so
Oh wow.
that's the basic
Okay.
understanding. Yeah. And then um we're told that the Earth is a specific size. No one is ever
Yep.
able to
We have.
say who measured it that way. In the 10 years our home server has been around. We have a home server. This is just an outpost of that. Our home server is 24/7 Flat Earth Discord. But home server's been around for, like 10 years. No one has ever provided any evidence of anyone actually taking a measurement of the sphere. So we're told to believe it was measured, but there's no evidence that it was. And when we go out and try to measure it, we don't find the curvature that they say should be there. So
Ye-
we are told that the Earth has a radius of
Yeah.
3,959 miles. Okay. And like I said, nobody can prove how that
Okay.
was measured. All right. So because of that number, we can just simply do the math and say how much curvature should exist on a sphere of that size, meaning how much
Okay. When you say
drop of
curvature,
the
you're
land over
meaning the
distance.
round side.
Yes. Uh-huh.
Okay.
So
Okay.
how
Yeah. Yeah.
much
Round, right? Like
yes.
how much it should
Yes.
go down.
Yeah,
Okay.
could someone in the
Okay.
side chat post the chart that has the drop over distance, the earth curve calculator kind of thing? So if you want to, you can just Google earth curvature calculator. There's many of them.
Yeah.
I like
You
one from
guys could also
OmniCalc.
recommend me any video on YouTube. By the way, if you
Oh
guys
yeah.
have a best video that you have come across, yeah, I would
Oh
watch it
yeah, we've
for
got even
educational purposes, right?
yeah, we've got even better than
Yeah.
that. So anyway, because of that,
Yes.
but because we're told the size of the earth, we can measure for it, and the size we're told means that we should expect to see a drop over distance, meaning the earth is falling away from you, going down, at approximately 8
Yeah.
inches per mile squared.
Okay.
All right. So what that means
It.
is there anything in the side chat? I
I-
can't access my phone right now. Let me see. Hold on a second. I do have a second. Okay. Let me look. Oh, thanks, DJ. So at 17 minutes past the hour, you have this lovely rainbow chart. Anyway, it's got the trig for the Earth. So the
Okay.
formula is at the bottom there on the bottom right. So 3959 is what we're told is the radius of the sphere. Okay? Do you see
Okay.
that?
Yeah. Yeah.
So
Yeah.
so based on
3959.
that, yeah, you see the formula that was used to derive these numbers.
Yes,
Okay.
Excel formula. Yeah.
Yeah.
Okay.
So over 10 miles of distance, so let's say a 10-mile flat body of water, like a lake, there should be, by the other end of the lake, there should be over 66 feet of curvature, of drop over distance. What that means is, at a distance of 10 miles, if there was a 6-story building at the other end, that 6-story building would be completely concealed by the curvature of the earth.
Yeah.
Does that make sense to you? Do you know what I'm saying?
I think it should be based on the math that we are doing. Like it should be hidden. But if we are measuring the Earth, I think it should hidden. What do you say? I think it should be
Well,
hidden, like the way
well,
we're.
yeah. Well, most people think that
Yeah.
the Earth is. They have this concept that it's not
Yeah.
measurable, that it wouldn't be that dramatic. So most people are pretty shocked to find out that that's how much curvature we should expect, because they've never done the
Oh.
math, right? And that's fine. But when we go out, let's say if you go to a 10-mile lake and you put your friend at the other end with a mirror and have him flash the sunlight at you, you will see him. He will not be hidden by over 66 feet of curvature. He will,
Okay. But
yeah.
then
And
how does a
so
building disappear?
that's just an observation, but we also do like laser tests where we shoot a laser at a distance, 10 miles, 21 miles, um, 25 miles, all sorts of things and all sorts of distances. Sorry. And we never measure any curvature anywhere. There's never any deviation. The lasers are hitting their targets every time. And so I can present to you some of those laser tests. I'm sure someone can post them in the side chat. And you will see that they're really well done, very professional. They go through all the variables and the methodology. They will show you exactly where they are.
Okay.
And
So
yeah, so you can just verify.
I would tell you
Yeah.
one thing, that we never measured the size of Earth, like we were never presented like who did it, to be honest. So
Right.
that's
That's what I
one thing
mentioned. Yeah.
actually, yeah, that you mentioned, because with math, because I have to be candid with you. Okay, I might not follow as much as I would follow with some other logics. When you said like we were never told who measured the Earth, which is a good
Right.
point. Yeah, we were never. They're just saying like we have measured it. Who measured it? And the one thing that you said, like when you like flow water, it takes the like plain state, right? So how when
Right.
we have 70% of water, and then they're saying like it is curve and turning? How?
Right.
Yeah, that these
And
2 points,
so, yeah.
they're like making a lot of sense to me at the moment.
Yeah, and the thing is, when anyone
Yeah.
observes the Earth, it presents itself as flat, right? That is our very fundamental understanding. And when they actually talk to children, until children are about age 4, they understand that the Earth is
Yeah.
flat too. And age 4 is like when the indoctrination really begins. I mean, it starts before then,
Yeah.
but that's when it really s- uh, is concretized. It becomes solidified in their minds at that age. So, um, if the Earth presents itself as flat, if we measure it if that's how it seems, then the impetus, the responsibility, is for the people claiming it's a sphere to prove that it's a sphere, and no one can do that. They can't show us a
Of course,
laser
it should be on
test
them.
where the laser at the other end of the 10-mile lake hits,
Yeah.
66 feet above the surface of the ground. There's no laser test showing Earth curvature. The only claims we hear are that, no, the Earth looks flat, it measures flat with lasers, but, it's just an optical illusion every single time. That's the argument from the globe side.
Yeah, I think they're just making this up. Like again, I think because I would have to do lots of research to actually come to a conclusion, because they have their own motives and they wanna present it in a way so they could use their ideologies. That's what I think, because they have some, conspiracy behind it.
Well, yeah, I mean,
I
they'll
think
say
they're
we're
doing
the
it.
conspiracy, but we would say that flat water isn't a conspiracy, right? Nobody can hide it. Anybody can go out and test for
Yeah.
this. That's the beauty of it. With conspiracies, you can never, unless you're on the inside of it, you never really know what happened, right? You can never know what people are thinking. You can never know what really went on. But with flat water, we can all go out and test it anytime, anywhere. It is entirely democratic. Anyone can access the
and it
information, and it
always
can't
takes
be
as
hidden. Yeah,
and
it can't be hidden.
yeah, and water always takes, no matter what the surface is, water always goes flat and straight line on the top surface
Exactly, and
becomes
that's why we
completely straight.
use yeah, and that's why
That
if you have a tube, you know, and you fill it with water, you can use it as a level. At any distance, it'll still remain level at both ends. It will not be lower or higher at one end, which it would have to be if the water on the surface of the earth was curving, right?
yeah.
Let me
Okay,
explain that to you better.
I
So if you had a tube, if you had a 10-mile long tube, right?
okay,
And
10 mile
you
long
you
tube.
pulled it up
Yeah.
at each end, and you pulled it up at each end, and you filled it with water,
Okay.
it would still remain
Yeah.
level at that distance, right?
Yeah, of course, like I think as like you, no matter how much you stretch the surface of the ground, but the moment you put like, water on it, it would always take the same level. Like the water would have the
Exactly.
same surface level.
Exactly.
It
Yeah,
cannot
and we
have
and
waves or some sort of up and down. Yeah.
exactly. Yeah, and, frozen water is good for this too. Or, there are salt flats, which are extremely flat areas, and they'll have rain on them, and so we can measure over those as well. At the bottom of the ocean, there's what's called the abyssal plains. So the bottom of the ocean is incredibly flat. That's supposed to be the flattest place on Earth. Um, which cannot you it just can't happen if the Earth is a sphere. So, we don't get into, um, speculation too much here. We really just try to deal with what we can prove, empirically,
Yeah,
right?
and I
So,
like that way.
measurements are simple.
Of course, that way is the best way.
Yeah,
Yep.
so if you look in the side chat, there's some laser tests for you to take a look at.
Okay, just giving it a go. And I would really appreciate if I get a video on like, with subtitles or on YouTube. I think somebody
Yeah,
posted
yeah.
like put a video.
DJ has a
Okay.
good one. DJ, can you just DM him your video?
I
And
would
then,
really watch it with subtitles, Yeah, yeah.
yeah, and anything else, yeah. There's a lot of good videos out there. You can probably subtitle these other ones too. I'm not sure. Um, what language do you speak? You said
I speak Hindi as my first language because
oh,
I
okay,
am
well,
from
yeah,
India,
then
so yeah.
that should be a common one to be able to use as a subtitle. So, do you have any questions about anything specific, like space or, satellite? Like a lot of people say,
It's,
"Oh,
I I was wondering because I can see it's like because I have got myself into this dilemma of like in exposing the truth, like not just as to exposing the truth, understanding what was hidden from us. So I also think like, what if we really went to moon or not? Like
yeah,
that could also be like, whole thing because they want to present the moon as round thing, sun as the round thing, earth as the round thing. So this just all
exactly.
comes down
Yeah,
to me as something that I should doubt.
What the
yeah.
hell, bro?
Well, okay. Can someone? Okay, yeah. See what I mean with that guy? Immediately trying to shut down any kind of questioning or deep thought about the topic.
Yeah.
That's what you'll see. Yeah, I mean, you're like way, way, way ahead of the average in here. Yeah, as far as the moon, okay, well, first of all, I didn't clear up a basic misconception that I should. We don't think Earth is like a disk floating in space, right? We don't take the solar system, the model, the heliocentric, meaning, sun-centered model that's
Okay,
presented in school with
heliocentric.
everything rotating, with everything orbiting the sun, and then stick a flat Earth
Okay.
in the middle of that. We don't do that. That's not what's happening. Right? We
Okay.
reject all of that entirely because it lacks evidence to support it. So, if the Earth is not and if the Earth is not a sphere, then that means there's no orbits. I mean, no one has ever observed an orbit anyway. We all see the same things in the sky. You can make up a story about what you're seeing, but that we don't see orbits, we don't see spheres. We see things that look spherical, maybe, but we can't prove that they are. And things can appear spherical that aren't. So, and even if they
Yeah.
are spheres, it has nothing to do with the surface of the Earth, right? Because the Earth in no way resembles the sun or the moon or the planets, right? Um, and we have access to the surface of the Earth. We don't have access to them to determine that. Um, yeah, definitely no one went to the moon. The whole idea of space is ridiculous. Like this vacuum adjacent to a pressurized atmosphere with no containment. You know what happens to gases next when a valve is opened and there's a vacuum on the other side, right?
Yeah, of course. I think this makes me question because when you like they take away the ability to question things. I would say it did come from the comedy because the guy said like oh, we never really actually meant to moon, we just like faked it all, it was staged. And I was like, okay, it might be a comedy, but what if, like we don't know, people can make fake diseases just to control population. They can do so many fake like fear mongering to see how much they can control people. So with that,
Right.
you
And
should always be open to question their claims. You just don't have to take them as accurate.
yeah, well, when NASA was founded, it was founded in order to establish Americans, supremacy in the world, sovereignty in the world. It was basically
That
founded as
explains
a
a lot.
propaganda agency, right? And
Yeah.
yeah, the moon
It's
landing,
like,
there's a lot of good stuff about that. It's totally ridiculous. It's easily debunked without much effort. There was definitely no moon landing. I mean, we don't know what the moon is. We don't know where the moon is. We don't know what size the moon is, and we definitely aren't going to a space vacuum adjacent to our atmosphere. Like it just defies thermodynamics.
yeah. Okay, I would like to say one more thing that Rainbow mentioned. I liked it. He told me that like when a space beneath your feet moves, you feel it, right? And I was like, yeah, I was thinking about a bus, a train, a plane, or a car, or even swings that we took when we were kids. So we can feel when the surface beneath us moves. Okay, it's not gonna impact our movement, but we can feel it, right? When something
Yeah,
moves beneath our feet. But they are telling
right.
us that Earth is like circulating, like it's taking these circles.
Spinning. Yeah, spinning and
But so,
orbiting and then also traveling through the solar system at an extremely fast rate, right?
and we are not feeling anything, and we are
We're
not
not
feeling
feeling
anything. At some point they say, oh, it's gravity because you're stuck, but then we can, with some strength of our muscles, we can jump up. But that strength of spinning Earth cannot shake us from our feet. But a child can use some sort of small muscles to jump,
right.
right?
Yeah.
The momentum of
Um
Earth spinning should actually shake you,
well,
but it
you know
doesn't
what,
make sense. I don't know why they're.
regardless of whether we would feel it or not, there is no evidence to support the claim that the earth is spinning. There are no experiments, there's no evidence. It's just a claim because people see the
Yeah.
sun move in the sky,
I think
and
one thing
rather than
again,
saying
I know like
we see the sun
I know
move
this
and
is
we
like all my questions, they
yeah.
come to my head because it's been only 2 days. Like this is yeah, this is my
Yeah.
second conversation, so these questions are gonna come to my head. I was thinking
Yeah,
if the Earth
it
is
is a
moving,
lot.
then
It's a
how
lot, and
many?
honestly, you should
Yeah,
probably instead of
yeah,
trying to give you everything right now, which is just a lot to digest, it's probably better if you just take some of the things we've talked about
yeah,
and think about them and go out and do your own research and then come back when you
yeah,
have more questions because
yeah.
there's an American expression called drinking from the fire hose, just which means just trying to take in too much at once, right?
I don't know.
And
Yeah. No, no.
this
I
is
for this
equivalent to
one,
that.
I appreciate it. Yeah, yeah, I appreciate, but this time I'm actually giving you the curious mind of peace. Like I was thinking, if the Earth is spinning, I don't need answers for that right now. I won't even be able
Okay.
to understand the answers right now because it's just so new to me. I was thinking, if
Yeah.
the Earth is moving, how are we traveling in planes? And then the planes are landing in the
Yeah.
same countries because if we are in
Yeah.
the air, then the
Yeah.
Earth should be rotated,
You are
and we should like
way
what?
ahead of the average people we talk in here. Yeah, exactly.
Okay,
Exactly,
but
because
I
the
don't need an
runways
answer,
would
but
be
this was just
moving,
my
right?
curiosity.
The runways would be
Yeah,
moving at the same
exactly,
speed
they
of the
would be.
Earth. right? And so they would have to be aligned that way as
Exactly.
well, right? You know, pilots would have to
Yes.
train for landing on runways pointing in all different directions and moving at
Exactly.
different rates, etc. Yeah, these are excellent questions. See, when you start to question it, you're going to find so many pieces of the puzzle come together for you, and honestly, you're going to be mad at yourself for not putting it together sooner. You really will.
Okay,
You
well,
will.
yeah,
Yeah.
but I am glad that I met you guys and I got some, like, understanding of the topic. And of course, I should not be in taking more than what I can digest, as you said. But this question just came out of curiosity. I didn't need an answer, but I was curious. Thank you for
Yeah,
your
no.
help, guys. And
We would
I
have
need to actually
answers for
check out
pretty
the
much
video with
everything you can
video.
ask. So, yeah.
Okay. Because of course
Yeah.
you guys are in this for a long time, right? So you would know a
Yeah.
lot, as you guys
Yeah,
just
we
said.
have and we have the home server, which has been around for 10, like I said, 10 years, and there's terabytes of information there on every topic you can think of related to this. And, even topics beyond this, we do have like a religion channel and such if you want to discuss that. But we cover pretty much everything. But
It,
well, if you friend request me, I'll send you an
yeah,
invite
definitely.
to the
Wow.
home server and I'll
Yeah,
VC verify you,
okay.
which will give you certain terms on the home site.
Okay, just doing that.
Okay, great. Yeah, I'll VC verify you and you will have access
Okay.
to all the
I
different
already
channels.
sent you a friend request. I like
Awesome.
you're
Thank you.
taking me to like you're taking me somewhere to. You're welcome. I appreciate it. Like I would be joining another server, right? Related to these
Yes,
topics.
it's the
Okay.
24/7 Flat Earth server, which is where we are from. This is just one room we maintain.
Okay.
Yep.
I understand it all. Okay, okay. It's just one room in this English hub, and you guys are
Right.
coming from that main server, Flat Earth's main
Exactly.
server. Okay,
Yeah.
got it. Yeah, you can take me there, no problem. You
Okay.
can actually include me there. Tell me the
Okay.
steps and I would follow.
Well, I'll just send you an invite once we get off the call. And
Okay.
like I said, I'll give you
Okay,
permissions
sure.
over there so you can access more of the server since I've talked to you in person.
Okay, thank you.
Yeah,
Sure,
thank you.
sure. Thank you so much. And I've already sent you a friend request, so you can proceed ahead, whatever you want.
Okay,
Thank you so
great.
much.
Well, yeah, it's been a pleasure. Have a good day.
You too, all of you guys.
All right, then that's how you handle Globers. Take notes, everyone. Good job.
Ladies and gentlemen, we got him.
As you can see, the flat earth ideology is now being associated with the Christian religion, specifically the Bible. If people are told by Christians that the Bible teaches a flat earth, that will all but guarantee they will lose any interest whatsoever in ever reading the Bible or taking it seriously. This is something that must be dealt with now before it gets out of hand. And at AKF, we are a small church that likes to do big things. So we are facing this head on, and stay tuned as next week we will be providing irrefutable evidence that we live on a globe. And coming in 2024, we are working on something massive, which we think will finally put this flat earth idea to bed for good.
So I'm sure by now a lot of you have heard of this thing called the Final Experiment, which is this trip that is being organized by this pastor from Colorado named Will Duffy. And if you haven't heard of it yet, basically what they're doing is inviting globe defenders and flat earth defenders down to Antarctica on a trip that takes place every year. It's nothing really special about this trip. It's part of this ALE expedition that happens every year, and he's offering to pay for tickets for people from both sides to go down to Antarctica and observe whether or not the 24-hour sun can be seen in Antarctica. And the whole claim being that this will be the final deciding thing and put the whole thing to bed once and for all. And I wanted to speak to that, the premise of it on its face, I think, being quite flawed. But even more than that, I wanted to kind of highlight, like, that clip that I just played was from that video in 2023, where he's explaining that, and of course we hear this all over the place, but this whole common refrain that the reason so many pastors and Christian leaders just are so desperate to put an end to the whole flat earth conversation is because they perceive that by associating the flat earth with the Bible, that this turns away people from ever picking up a Bible, and it's an embarrassment to the faith, and then it's harmful to the Christian witness, and so on. And I think more than anything, that is the claim that I wanted to address first and foremost. The reason being that, having now been kind of participating in this whole conversation for, the better part of a decade now, and having spoken to thousands of people at this point who didn't pick up a Bible until they had looked into the flat earth issue and had started to conclude that, maybe NASA and science has been operating on a number of false assumptions, and that there is indeed a massive false deception about the world in which we live, and causing them to turn to the scriptures. So personally, I can say, like, this idea that flat earth is an embarrassment to Christianity and is sort of an anti-apologetic, that it's something designed to make Christians look stupid. I mean, I've been hearing this since day one. We've all heard this a million times. And it's just absolutely false. And so I've read countless emails and comments from people all over the world who have come to faith in Christ because they not only flat earth, but the broader implications of getting to the point where you can grapple with the idea that we've been lied to on that kind of a scale, and that not just the U.S. government, but all the major governments of the world who are involved in all these, space programs and stuff are all participating in this hoax, this deception, and how that plays into so many other questions. And after COVID especially, it's kind of mind-blowing that to still hear Christians and pastors making this kind of an argument when the shape of the earth is hardly the only thing that we're being lied to about. And so, okay, in terms of this Antarctica trip, just personally, I wanted to come out and just give my 2 cents on this idea, the premise of it to begin with, claiming that this is going to actually prove anything, I would argue is quite faulty. And it kind of points back to the entire history of the debate between Copernicanism and geocentrism, and how the whole current model of the cosmos was created, where it's constantly appealing to trying to create a model and an explanation for how the luminaries work and what they are. And essentially, when I first kind of came across this issue in 2015, for me, the most compelling piece of it from a scientific point of view, from an experimentation point of view, was the issue of curvature. That is, the question of whether the ground is really curving beneath our feet into a sphere or not. And this has always been kind of the tension with the discussion, where the motions of the heavenly bodies and the observations thereof is the thing that supersedes the question of whether we're actually on a flat plane or a curved surface. And I know this Will Duffy guy has been going around and doing a lot of live streams and interviews, and when they're like 4 hours long, man, there's just no way I'm going to listen to something like that. But I did listen to the recent debate between Whitsitt and Professor Dave, who professes to be a professor. And, when Whitsitt brought out all... the thing that really stuck out to me about that whole thing was the same issue, where constantly it's like, well, explain the southern stars, explain this, explain how the heavenly bodies work according to your model. It's going back to doing the same thing of framing the whole debate in terms of, well, you have to be able to explain how the celestial bodies work, trying to suck you into that discussion. And then when Whitsitt shared the litany of ground-to-ground observations showing distances that should be impossible to see on a globe at 24,000 miles in circumference, it's just dismissed outright. And, oh, those are all, I can't verify that, so it's just nothing. So it's just completely disregarded. And no, we got to talk about the sun, moon, and the stars. And so after watching that and then seeing more stuff pop up about this final experiment thing, and it's like, oh, the flat earthers they're too chicken to, to me, it's a red herring to begin with. And so, my advice to anybody who's being invited to this thing is to not bother with it, because in a sense, you're already kind of handing them, regardless of what you might actually go and see. Let's say you really do see a 24-hour sun in December. Does that prove that the ground beneath your feet is curving? No, it does not. And for me, it's really no different than the issue of like the star trails and the southern hemisphere and things like this. Or it's no different from like being challenged with like, well, how do eclipses work? Or the phases of the moon, or all kinds of things. So this is, to me, it's just kind of falling back into the same false assumption that has kind of plagued the whole issue for hundreds, if not thousands of years. So no, I don't think, if you want to go and take a free trip, feel free. But, because here's the thing, it's like, so let's say they go down there and they don't see the 24-hour sun. Are they going to suddenly go, oh, well, we must be on a plane? Is that going to prove... the fact that the guy is already coming out and expressing his opinion of, he's clearly has a bias. Everyone in the debate does. But it's also interesting, too, that, here we are in 2024. The fact that you're going to have people from both sides going down on a trip together, as if that's going to conclusively prove anything when, people have been going down on this trip every year for how long, and shouldn't we already have copious amounts of 24-hour Antarctic sun already? The fact that you would even need to do this trip to supposedly prove anything kind of says something in itself in terms of how weird that is. Here we are in 2024 where there's supposedly, we have a space station and we claim to walk on the moon. And in that debate with Professor Dave and everything, it's like they didn't even get into any of that. All of the fakery that we've seen NASA and SpaceX do, in some ways, I guess it's kind of to me, that's pretty revealing in terms of how, like, they don't even want to get into that anymore. It's like, okay, well, you just say all the NASA stuff is fake, so we'll just avoid all that. And it's 'cause they want to avoid that because it's so embarrassing at this point. And regardless of what era of space flight footage you want to look at, from the 50s all the way to today, we've been scouring all this material for years now and putting together all these compilations of really questionable things that they're just going to continue to scoff at. And so it's like, okay, let's go to Antarctica and that'll just put it to bed once and for all. And the fact that this is being put together by a pastor, and I don't know much about this guy's background or what else he teaches in his theology, but for myself and for many other people, the scripture really was the deciding factor. When you go through from Genesis all the way through it, trying to find argumentation for a spinning, whirling Copernican universe with galaxies and black holes and all this stuff, like that's where it really just became impossible to unsee it, personally. And I know for many of you as well, that just going through the days of creation and going through Joshua's long day, and people have been debating the circle of the earth in Isaiah ad infinitum. But again, like listening to that clip where he's saying that, you know, this is just going to make people not want to pick up the Bible. To me, that really puts the finger on what is really the issue. And it's really not even about the shape of the earth. If you believe in a globe and you know Jesus as your Lord and Savior, and you believe he died and rose again, then, you know, amen. You know, I've not cut off fellowship with a single person because they didn't believe in the flat earth or questioned their integrity, you know, or their intentions and so forth. But I think what matters to me more and more is that whole issue of being afraid to be ridiculed. You know, and the one thing that really kind of stood out to me when I first started looking into this topic was the question of what did the biblical authors and the patriarchs actually believe about the cosmos. And this is another thing, too, I think that kind of came out in that discussion with Danny Faulkner and Peters or whatever, is that they really kind of want to downplay, like that's a real sticky one. Because if you're honest and you look into it, there's no getting around the fact that the people who wrote the Bible, and, you know, Michael Heiser famously affirmed this and then tried to kind of have this big roundabout, you know, argument to weasel his way out of it. But no one really, if you really press them, no one can deny that the authors of the scriptures, all the fathers of the faith, all believed in an enclosed, stationary earth, with the sky stretched over them like a tent, and the heavenly bodies are in motion, and we are not. And I mean, we've all seen the picture. So it's fascinating now that here we are going like, if you know anything about the history of the Greeks being the ones who supposedly figured out that it was a globe, it wasn't the Israelites who actually receiving revelation from the one true living God. But basically, you just see Christians trying to retcon the historical fact that the biblical authors and people who believed the Bible did not believe in the Copernican universe. And if they did, there would be no Copernican revolution. You couldn't have a Copernican revolution if it was already the predominant biblical cosmological view. It's completely illogical. So really, it's a bigger debate about being in the world and not of the world, and being willing to question not just cosmology, but all kinds of things that science and humanity as a whole claims to be true, namely evolution. And it's funny how that doesn't even seem to offend creationists as much as Flat Earth. Flat Earth offends pastors and creationists more than evolution does. Like, how many more people out there, you know, my entire life I've heard of Christians trying to argue that evolution and the Bible are both true, and trying to harmonize everything with, you know, whether it's Darwinism or the Big Bang. I mean, it's been around for a long, long time, and this, somehow that's not offensive. Even when you believe in creationism and you believe evolution to be a lie, somehow believing in a fixed stationary earth with a creator and 6,000-year history, you're more triggered by that. You're more afraid of being associated with that than you are with people who believe in evolution, believe that the Bible and evolution are compatible. That's probably been the thing overall that has fascinated me more than anything else with the flat earth debate within the church. How numb we have become to the teaching of evolution. Not just in an abstract classroom kind of way, but the way that evolution has manifested itself in society, in government, in the sciences, in everything. From politics to, sociology and medicine and everything. I mean, just the name, I've just been struck by the irony. The final experiment. That's your big, that's the name you came up for, basically your marketing campaign for this trip. And here we are 3 years into what I would say is the biggest experiment that's ever been done on humanity. Hands down. And you're more worried about people believing in the flat earth than you are for the millions of professing Christians and pastors who went along with an experiment that would put Joseph Mengele to shame. And the cognitive dissonance that is now rampant. So much has already come out about how the governments and corporations and news outlets knowingly lied about the origins of the disease, about the dangers of it, and about the effectiveness and the risk of the so-called vaccine. When I hear people making these arguments about essentially being afraid of being associated with the same cosmological view that Abraham, Isaac, and Jacob held, my next question is, well, what... Are you afraid of being labeled an anti-vaxxer? Are you afraid of Christians being associated with... I mean, think of all the pejoratives that are now being leveled against Christians and conservatives in the media and by the federal government. When the president goes before the world and is talking about white supremacists and the MAGA extremists, and it's like, at what point are you going to figure out that, you're living in a fantasy world of what the true dangers really are right now? I don't know what timeline you're living in. I don't know what kind of, it's ironic, right? Because the flat earth is ridiculous because it's like we live in this idea of living in a snow globe in a bubble. And I look around and I see people living in a bubble, particularly Christians. And maybe this is why the flat earth and the globe, it's almost more symbolic of the bigger divide. If you can cling to this scientific security blanket of the globe and space, and that the world is going to take us seriously because we're not like these stupid Stone Age people, how deluded are you about so many other things? I've yet to meet somebody who got into flat earth and decided that gender was a construct. 10 years ago, if you even told people that would be another big debate, is how many genders are there, or what is a woman? And so there's a sense to where you have to kind of let all that go and know that the world is going to hate you for following Christ and being true to his word. So in so many ways, it's like this whole debate has already been surpassed. So, okay, if you go to Antarctica and you see the 24-hour sun, and to you that convinces you that you're on a globe, then super, so be it. I don't know if you've been paying attention, but it's not enough to just believe in the globe. According to the high priests of scientism and government and the World Economic Forum, they demand that you inject yourself with whatever technology they come out with that they say needs to protect you in a global health emergency. It's kind of all or nothing with the globalists. I don't know if you figured this out yet. Climate change, unless you're prepared to go along with the entire narrative to the point where the carbon dioxide, the thing that we actually exhale when we breathe out, is poisoning the planet, along with your car and your lawnmower and your gas stove and this entire agenda. You're not going to appease the people pushing these narratives by the fact that you believe in the Bible, but you also believe in the globe. You're not going to win over the world by proving how compatible the Bible is with science. And I think that's really what's at the crux of it all. Because science has lied about all kinds of things. And, you know, if we're on this globe floating through space, the spaceship Earth, with limited resources, and all these scientists and experts coming up with all these models of, you know, what we need to do to reduce our carbon footprint, and we need the carbon tax, and this all ties into, you know, a social credit score and all, like, you know, believing in the globe isn't going to get you out of having to deal with any of these questions. It isn't going to get you out of having to face real difficult choices, and ridicule is the least of our problems at this point. Like, really, you know, a one world technocratic system is all based on the presumptions of the globe, and that we can measure all of the atmosphere. I mean, as I said, like, this isn't the only hoax that's been perpetrated upon humanity. So I don't know, it's kind of a ramble, it's kind of a rant. I mean, I've been talking about this stuff for years in terms of evolution and transhumanism being the driving factors of, you know, this false religion, this false one world religion that has already taken over pretty much every country, in the universities and schools. And when you realize that, like, yeah, none of that gets off the ground, but if you don't have the universe, and never mind the distant starlight problem, like, if you believe that the stars are millions of light years away, but how do you not have to concede? It's the same thing. It's the same thing as saying that, like, well, if the stars in the southern hemisphere prove it's a globe, then the claim that they're millions of light years away also proves that the universe is millions and billions of years old. You can't have it both ways. So go ahead and just concede evolution, concede it all. Just this idea that you're trying to just make the Bible conform to something that the Bible never taught. That's the problem. That's the issue. That's why it is such a kind of a line in the sand thing. And that's why, like, okay, you can go down to Antarctica. It's not going to end the debate, because the scriptures, we still have the Bible, and people are still able to read it for themselves and see that, like, yeah, there's nothing in there that, like, if you didn't have all this other propaganda, there's no way you would pick up a Bible and come up with the idea that there's worlds out there and black holes and, you know, dark matter. But in contrast, what the Bible tells us is that the physical world that we can taste and see and touch and experiment on is not the full scope of reality. There is an entire spiritual dimension full of sentient spiritual beings, angelic beings, holy angels and fallen angels, that do not fit within a scientific paradigm at all. And they are real and in the world today, even though we cannot scientifically prove them. We know this not because of human philosophy or human experimentation or the scientific method. We know it because God has revealed it to us. The whole way of salvation, the gospel itself is not something we know because of the scientific method. Christ was crucified for our sins and raised on the third day because of divine revelation. And if you think that, like, that isn't what they're scoffing at, the idea that there is a God who made the heavens and the earth, and that one day the heavens and the earth will be shaken, not just the earth, but the heavens also, and that only that which is redeemed by Christ will remain. This is kind of what I've been thinking about as I've been going through questions of eschatology, and specifically Revelation 20 and this whole little season topic. I think my next video is going to be on that. I've been working on it for a while, but I've just been continuing to study and, you know, really kind of look into this whole idea of the millennium, and just been praying about it. And it's pretty exciting in terms of, like, how much I think clearer it continues to get as I'm kind of unlearning a lot of this dispensationalist programming. So not to get too into that, but that's, I think, my next video. But what I keep coming across is that, like, if you believe if you believe what the Bible says about the judgment at the end of history, that there will be a new heavens and a new earth, then in reality, arguing about, like, the current heavens and earth and what the shape is and how to it's like, it all really does kind of become moot when you really step back and look at it. Like, it's all going to be wiped. So we don't know what the new heavens and the new earth were going to be like. In Revelation, it says that there's no more sun and moon. It says that the stars will fall from heaven like figs from a fig tree. I don't know, how does that work on a globe in space? It's going to sound absurd to the world. Are you still worried about sounding absurd when you're talking about if you say you believe that the Christ is reigning on his throne right now, up at the right hand of the Father, and that ties into what I think the millennium really is in Revelation 20. But yeah, the final experiment. I think we are the final experiment. Humanity,
Oh my
society,
God.
not just with mRNA, but scientism, this religion, the experiment of like how much will people obey just out of sheer arrogance and thinking they're so educated and they're so, completely oblivious to how, all these worldly institutions and governments and corporations are not serving the purposes of God. So that's my rant. Yeah, you don't prove the shape of the floor by examining the ceiling. You don't prove that the earth is a globe by looking at the sun, moon, and stars. That's been a refrain that I've had since the beginning of this, and I think it's still true. And the Bible is still true. It's truer than ever. And it's not all about the flat earth. It's weird that like I now look at the earth being stationary and enclosed. It's just being another fact along with it being, a young earth. It's like that's not the gospel. That's not. And yeah, a lot of people are going to laugh at you for believing that the earth is only 6,000 years old, give or take. So what? Let them laugh. Let them talk to any evolutionist and they will laugh in your face at the claim that the earth is not millions of years old. So according to your own argument, is young earth creationism an impediment to the gospel? Should we be ashamed? Because science has disproven that too. I hate to, remind y'all. Why is flat earth so anathema to the point where you're more worried about flat earth than you are about the people who literally teach that we came from the primordial ooze and the Big Bang and billions of years of cosmic evolution? Think about it.
The fires burn the meadow sky. The day we realize the time is running down, far removed from the wounds they still bleed. Every open door is a world turned on its side. All these dreams we shared before hollow echoes today. Ways I refuse to leave. Far removed, iris blues from the sea. Every open door, a new world come alive. All those things that came before, little by little, the memory fades away.
Yeah, they dragged that song on as long as they could, didn't they? All right, so I'm not sure if the music bot's gonna work, but here is so what I'm gonna play is basically it's Notebook LM. I don't know if you're familiar with Notebook LM, but it's an AI that breaks down PDFs or videos and things like that, and then makes various different types of presentations out of them. This is an audio presentation. I did was upload Dr. John Dee's peer-to-peer laser test and just say give an honest review on this test. And I listened to about the first 20 minutes of it. It seemed pretty interesting, so I thought I'd give that a play. The bot works. Right, somehow the bot's messed up.
Just plant your feet on the pebbles of Worthing Beach.
Right, getting that sea breeze.
Exactly. And you look out over, it's about 15.3 kilometers of open ocean straight toward Brighton.
Which is a pretty massive stretch of water.
And it really is. And the thing is, conventional physics dictates that there's a massive obstacle blocking your line of sight right there.
Yeah, according to standard geometric models of the Earth, there should be this literal 35-foot wall of curved water.
Right, like a 3-story hill made entirely of ocean, just standing right between you and the other side.
Which is just wild to visualize, but that's what the math says.
It is. So what actually happens when a team of, grassroots researchers goes out there and shines a laser straight through that exact physical space?
And a camera looking dead ahead actually sees the light.
Yes. Today, for this deep dive, we're exploring a geometric landscape that just completely shatters the expected blueprint.
We really are. We're diving into an incredibly detailed, painstakingly documented scientific observation that just leaves us with this glaring, unavoidable mathematical anomaly.
It's an anomaly that really forces you to question how we measure the physical reality right in front of us.
Completely. And the source we're using today is the transcript and the raw data from a YouTube video. It's titled Peer-to-Peer-to Results and Observations.
Uploaded by a researcher who goes by the name Dr. John D. Right?
Yeah, exactly. But before we get deep into the weeds of optical physics and geopotential surfaces, I think we need to establish the ground rules for what you and I are actually doing here today.
Definitely. We need a clear mission.
Right. Because our mission is not to, relitigate centuries of cosmological debate or dive into these grand overarching theories.
No, we're staying highly focused.
Hyper-focused. We are going to analyze the metrics, the weather data, and the methodology presented in this specific 15.3-kilometer laser test.
We're taking it at face value.
Exactly. We are accepting the results exactly as they were documented on that beach, and we're just going to follow the logical conclusions dictated purely by that localized data.
Okay, let's unpack this. Because that localized data is staggering, It directly challenges the automatic default assumption we all just kind of have when it comes to standard models.
We definitely like to think of our physical reality as being mathematically settled.
We do. But this observation, it takes a laser, points it across the water, and essentially asks, does the physical world actually match the textbook?
So let's build the anatomy of this observation from the ground up for everyone listening.
Yeah, let's set the scene. The test takes place in February 2019, spanning from Worthing Pier to Brighton West Pier.
Like you said, a distance of 15.3 kilometers.
Which is about 9.5 miles of uninterrupted English Channel. And the core objective is almost shockingly simple.
Simple, yeah, but profound. They wanted to see if a laser positioned just 1 meter or even less above the tide level could be seen by a camera positioned at that exact same height on the other side.
Right. Which, that brings up a pretty long history of people trying to measure the surface of water over long distances to detect curvature.
Oh, absolutely. If you look back to the 19th century, you had the famous Bedford Level experiment.
I remember that one. In Cambridgeshire, right?
Yeah, exactly. Researchers were trying to measure flags placed along a drainage canal, and that just sparked decades of fierce, really bitter scientific arguments about what people were actually seeing through their telescopes.
But what makes this modern observation in 2019 so vital to analyze, I think, is the technological rigor.
Yes, the strict criteria for what constituted acceptable data.
Because Dr. John D. and his team, they didn't just walk out on a random Saturday, see something weird, and then upload a video claiming they broke physics.
Not at all. The preamble to this successful night is honestly a masterclass in establishing a pristine, uncompromised baseline.
They actually had a series of completely documented failures first, which is so important.
It really is. If you're going to challenge the geometric model of the Earth, you cannot have confounding variables.
Right. For instance, the source material notes that on February 2nd, so a few weeks prior to the successful test, they attempted the exact same 1 meter setup.
They fired the laser, but it just could not be observed from the other side.
And rather than forcing a conclusion, they actually analyzed the environmental data and realized there was a measurable density gradient in the air above the sea that night.
The environmental conditions were just unstable.
So what did they do? They packed up their equipment and they logged it as a failure due to weather interference.
Which is real science.
Yeah.
And that transparency continues. On Friday, February 22nd, which is the literal night before the observation we're about to dissect, they tried again.
And this time, a dense fog rolled in.
Yeah. Now, the source notes a fascinating detail here. Cameras at Worthing actually could see the intense light of the Brighton lasers penetrating through the fog.
Oh, wait, really? The photons were actually making it across.
They were. The light was visible, but Dr. John Dee completely discarded the observation. He just threw the data out.
Wow. Which is such a critical constraint to place on yourself as a researcher. I mean, if you are seeing the light, the temptation is to just say, look, it works. Hit record.
Oh, totally. But what's fascinating here is that the methodology demanded absolute visual clarity.
Right, because of the fog, crisp, undeniable photographs and videos just couldn't be taken to prove exactly what they were looking at.
Exactly. If it couldn't be cleanly documented for public verification, it was just deemed useless.
It establishes this baseline where only pristine, verifiable data makes it into the final analysis.
Which brings us to Saturday, February 23rd, 2019. The team identifies conditions that they deem perfectly non-specialized.
Non-specialized, meaning what exactly?
Meaning a low tide, a calm breeze, and clear skies under the stars. Just a very standard, quiet night.
Okay, got it. So to really understand the gravity of what happens next, we have to formally lay out the mathematical problem at the center of this 15.3 kilometer stretch of water.
Right, we have to define the globe model.
Right, because standard geographic, astronomical, and geodetic models dictate that the Earth is an oblate spheroid.
With a circumference of approximately 40,075 kilometers.
Or roughly 24,901 miles, for those of us using miles. And on a sphere of that specific known dimension, the surface of a body of water cannot be a perfectly flat plane.
No, it mathematically can't be. It must curve downward in all directions from the observer as it just conforms to the geometry of the Earth.
It's kind of like, think of it like trying to see a penny taped to the far side of a basketball while your eye is resting on the near side.
That's a great analogy. The bulge of the ball just naturally gets in the way.
The mass of the thing itself blocks your view. And this isn't just an abstract concept either. It is a highly specific geometric formula.
Right. Using the Pythagorean theorem applied to the radius of the Earth, we can calculate exactly how much a distant object should be obscured by the physical curvature of the water between 2 points.
And the source utilizes the Minibunk curve calculator for this, right?
Yeah, which is an entirely standard, accepted tool in the scientific community for determining these exact geographic figures.
Okay, so let's run the numbers. We have a distance of 15.3 kilometers. We have an observer at Worthing with a camera sitting exactly 1 meter above the tide level.
And we have a target at Brighton, the laser, also sitting exactly 1 meter above the tide level.
So when we plug those specific parameters into the standard mathematical model of the globe, the resulting geometry dictates that the physical curvature of the water should block 10.8 meters of the target.
That is the hidden height. 10.8 meters of the target should be physically obscured from view, assuming light travels in a straight line.
10.8 meters. That is nearly 35.5 feet.
It's massive.
If you are standing on that beach, the math tells you that there is a physical convex bulge of water reaching 3.5 stories high, right in the middle of your line of sight to Brighton.
The mass of the ocean itself should be an impenetrable wall.
Right. And this is where I think we really have to talk about human perception versus macro scale geometry. Because the visual representation of this math often really trips people up.
It does. And Dr. John Dee actually includes a very specific caveat about this in the source material.
Yeah, the scaling problem. Okay.
Exactly. When you watch an educational video or, look at a textbook diagram explaining Earth's curvature, the curve is almost always wildly exaggerated.
They draw this massive sweeping arc so your eye can immediately comprehend the concept on a tiny little screen.
Right. But Dr. John Dee points out that if his presentation diagrams were drawn perfectly to scale, meaning if you drew a line on your screen representing the 15.3 kilometers, and then you tried to accurately depict the 4.6 meter peak of the curvature bulge right in the center, the line on your screen would look completely, perfectly flat to the human eye.
Wow. So the variation is just so slight over that massive distance relative to the whole that your eye physically cannot detect the geometry.
Exactly. The 4.6 meter bulge over a 15.3 kilometer span is something like 0.03% of the total length. It is macro scale geometry.
So you really cannot just stand on the beach, look at the horizon, and say, yep, that looks curved, or nope, that looks flat.
No, our biological optics simply aren't built for it. We have to rely on precision tools.
We have to rely on lasers.
And fundamentally, we have to trust the math. And the math unequivocally states that over this distance, between these two 1-meter elevations, the bottom 10.8 meters of Brighton should be completely invisible from Worthing.
It should be totally hidden.
Yeah.
But here is where the scientific method collides head-on with the physical world.
Right.
If that 10.8-meter wall of water exists, but a camera somehow captures the laser shining from the other side, standard physics does not immediately conclude that the geometry of the Earth is wrong.
Oh, definitely not. The immediate reflexive answer from the scientific community is that the light is just cheating.
The answer is atmospheric refraction.
Exactly. So if I'm a conventional physicist looking at this footage, my first thought isn't, oh, the water is flat. My first thought is that the light beam is bending over the obstacle.
So let's dig deeply into refraction, because this is the primary roadblock the researchers had to dismantle. What is the actual optical physics happening when a scientist claims refraction is allowing us to see over the curvature of the Earth?
Well, refraction, at its core, is governed by Snell's law. When a wave of light passes from a medium of one density into a medium of a different density, its speed changes.
Okay, and that causes the path of the light to bend.
Exactly. A great way to visualize this is to imagine a marching band walking in tight, straight rows across a paved parking lot.
Okay, I'm picturing it.
And then they cross at an angle into a field of thick, muddy grass.
Ah, so the musicians who hit the mud first are going to be physically slowed down by the thicker medium, while the musicians on the outside of the row who are still on the pavement are still marching at full speed.
Exactly, because one side of the line slows down before the other. The entire row of the marching band is forced to pivot. The direction of their march actually bends.
That makes perfect sense.
And that is precisely what happens to a wavefront of photons. When light passes through atmospheric layers that have different temperatures and different humidities, it encounters different air densities.
So if the air right above the freezing ocean water is very cold and dense, and the air slightly higher up is warmer and less dense, you've created a density gradient.
A thermal inversion.
Right. And as the light from the laser travels horizontally, the bottom edge of the light beam hits that denser, colder air and slows down, while the top edge in the warmer air keeps moving faster.
Yes. So the entire beam pivots downward. It hugs the curvature of the water in what physicists call an optical duct.
It literally curves around the bulge of the Earth.
It does. It carries the image of the laser to your camera lens, making it appear as though you're seeing in a straight line right through an obstacle. But in reality, the light is taking a curved path right over it.
So it's basically the exact same optical illusion as a mirage on a hot highway in the summer, just inverted.
Exactly. On the highway, the asphalt is boiling hot, heating the air right above it, making it less dense than the cooler air higher up.
Right, and the light from the blue sky comes down, hits that less dense air, speeds up, and bends upward into your eye.
You think you are looking at a puddle of blue water on the road, but you are literally seeing a refracted projection of the sky.
Wow. Okay, so the researchers at Worthing and Brighton, they absolutely knew this.
Oh, they knew that if they simply filmed a laser, every skeptic would instantly yell, it's just standard atmospheric refraction, the light is bending.
So they had to prove that the marching band never hit the mud.
Exactly. They had to prove there were no differing layers of density.
And their methodology for isolating this variable is what makes this observation so compelling. I mean, they didn't just guess at the weather.
No, first they established macro environmental conditions by pulling data from the UK Met Office and AccuWeather.
For 3 specific points along the 15.3 kilometer path, right?
Yeah, Worthing at the start, Shoreham by Sea right in the middle, and Brighton at the very end.
So they checked the entire corridor. And the macro data confirmed the conditions were non-specialized. It was just a standard, calm February night. No freak weather fronts, no massive barometric anomalies.
But let's be real, an app on your phone telling you the weather in Brighton doesn't tell you what the air is actually doing 1 meter above the surface of the freezing ocean.
No, you need micro-localized on-site data.
Which is exactly what they gathered. The team at Worthing physically measured the temperature and the relative humidity of the air at very specific, crucial elevations.
They took readings starting at 0.5 meters above the tide level and went up to 1.5 meters above the tide level.
They are measuring the exact geometric corridor that the laser beam is passing through.
Precisely. They aren't just taking the temperature at eye level on the pier.
Right.
They're taking it directly in the path of the photons.
And the data they recorded is the linchpin that mathematically eliminates the refraction argument.
What did it show?
The source material states that between 0.5 meters and 1.5 meters, The temperature and relative humidity readings were completely indistinguishable from each other within the precision uncertainty of their instruments.
Wait, let me stop you right there.
Yeah.
Because if you're listening to this in your car right now, you might be shouting at the dashboard, it's a mirage. Your thermometers are just cheap.
And you would be right to ask that question, because that is science's default safety net.
Right. I have to push back on this on behalf of the listener. Are we really saying that consumer-grade thermometers on a wet beach are precise enough to dismantle 2,000 years of spherical geometry?
That's a fair point.
I mean, what if there are invisible microgradients? Tiny, localized fluctuations in the air density that the thermometer just doesn't have the processing power to detect, but they're still severe enough to bend a highly concentrated laser over a 9.5-mile stretch.
It is the absolute right question to ask, and it is a fundamental challenge in empirical observation. But Dr. John Dee addresses this through the principle of corroborative evidence.
Okay, how so?
Well, yes, a thermometer has a margin of error. But if there were invisible microgradients in the air severe enough to cause a massive 10.8-meter refraction of a light beam, that extreme optical bending would not just affect the laser.
Oh, I see. It would manifest visually on the entire landscape.
Exactly. The optical physics wouldn't isolate just the laser beam, it would warp everything in the frame. When refraction is actively occurring over a body of water, it creates very distinct visual artifacts on the camera sensor.
Like what kind of artifacts?
If the light is bending sharply downward to hug the curve of the Earth, it creates what is known as a superior mirage, or fata morgana.
Right, where things look like they're floating.
Yes. The distant shoreline of Brighton would appear to loom upward. The city lights would vertically stretch, duplicate, or appear to just hover in the sky above the horizon. The whole image becomes wildly distorted and unstable.
And conversely, an inferior mirage would make the shoreline look like it was melting into a mirror, like the highway mirage.
Exactly. But the photographic and video evidence gathered that night showed none of that.
The visual field was completely stable.
There were absolutely no inferior or superior mirages captured on camera. The shoreline looked entirely normal, just distant.
So, according to the strict parameters of this data set, the macro visual evidence of a stable, undistorted horizon perfectly corroborates the micro instrumental data showing uniform temperature and humidity.
The air was uniform, and if the air density is uniform, Snell's law dictates that the light must travel in a perfectly straight line.
The marching band stays on the pavement. The light does not bend.
Exactly. And just to put the final nail in the refraction coffin, the source points out that even if we were to grant standard refraction just for the sake of argument...
Right, like applying standard refractive indices to the math, even though the localized weather data proves it wasn't happening.
Right, standard refraction models only reduce the hidden height from 10.8 meters to 8.8 meters.
Still a nearly 29-foot wall of ocean. Standard refraction is not a magic wand that just makes mountains of water disappear. It has mathematical limits based on standard atmospheric pressure.
Even with the absolute maximum theoretical allowance for refraction, there is still this massive physical barrier blocking the line of sight.
So we have a mathematically established baseline. The geometry says there should be 10.8 meters of water in the way. The physical readings and the visual evidence prove the light is traveling in a straight line.
So it is time for the main event. Let's examine the 1 meter test and the power of their live verification protocol.
The conditions are locked in. The tide is extraordinarily low. It is measured at exactly 0.6 meters above the lowest astronomical tide, or LAT, at both Worthing Pier and Brighton West Pier.
That's such a great detail. They checked the tide at both locations to ensure the surface of the water was at an even baseline across the entire 15.3-kilometer stretch.
Yes, they even verified the tide at Shoreham right in the middle. The water is calm, the cameras are positioned. But crucial to the scientific transparency of this observation, they aren't just hitting record on an SD card.
No, they are broadcasting the entire event live on YouTube.
Which is such a brilliant, modern methodological choice. Why does live streaming fundamentally change the weight of this observation?
Because it completely removes the possibility of post-production trickery. In a digital age where, literally any video can be seamlessly edited, spliced, or manipulated in Premiere, a live stream forces the researchers to perform without a safety net.
The public is viewing the raw data unfolding in real time.
Yes. It provides an unalterable timestamp and visual verification that what is happening on the screen is happening right now, in reality.
And the coordination between the two teams during this live stream is where the data just becomes undeniable.
You have Dr. John D. stationed behind his camera at Worthing, and you have his counterpart, Roxanne, 15.3 kilometers away in the dark at Brighton.
They're communicating via mobile phone, right? Coordinating the laser pulses to definitively prove to the live audience that the light blinking on the camera sensor is in fact the laser, and not just some random boat light or a street lamp reflection.
And the source transcript captures this interaction. Here's where it gets really interesting, because it is a fantastic example of establishing absolute cause and effect over a massive distance.
You can almost feel the tension in the transcript. Dr. John says, "Okay, Roxanne, what I want you to do, please, is go to the front of the red laser and get ready to put your hand in front of it. On my mark, I'll say 1, 2, 3, and then block the laser."
And then he initiates the countdown. 1, 2, 3, block. Brilliant. Right, keep it blocked. 1, 2, 3, release.
Block, release, block, release, block, release. And as Roxanne is physically stepping in front of the blinding red laser on the pebbles in Brighton, the camera sensor in Worthing is capturing that exact red dot, winking out and flaring back up in absolute perfect synchronization with the audio commands.
The causality is totally locked.
And we should talk about the optical physics of the equipment doing the capturing, because they weren't using like classified military satellite optics. They were using high-end consumer hardware.
Right. Dr. John D. was operating a Nikon P900 camera, and Dave Marsh at Brighton was using a Nikon B700.
These are bridge cameras famous for their optical zoom lenses. But how does a small consumer sensor actually manage to resolve a point of light from 9.5 miles away?
Because light scatters.
Yeah, it does. Over 15 kilometers of atmosphere, photons are bouncing off dust, water vapor, and air molecules. The beam widens and loses intensity.
Right.
So the signal-to-noise ratio in optical physics over that distance is incredibly challenging. But a laser provides highly collimated, coherent light, meaning all the light waves are traveling parallel to each other, so the beam spreads out far less than the standard flashlight.
Okay.
So the optical zoom on the P900 essentially acts as a massive photon funnel, gathering that very specific wavelength of red light and focusing it onto the sensor. And because it was a dark, clear night with no funug to scatter the beam, the intense source of the laser remained cohesive enough to trigger the pixels on the camera sensor.
Which brings us to the results of the coordinated 1-meter test. Both sides, Worthing looking at Brighton and Brighton looking at Worthing successfully, undeniably recorded the intense source of the other team's laser. The laser at Worthing was positioned at exactly 0.9 meters, 90 centimeters above the tide level. The cameras capturing the light were sitting at exactly 1 meter.
Let's run the mathematical reality check on what that observation actually means. We established that according to the geometry of a 40,075 kilometer globe, for an observer at 1 meter looking at a target at 1 meter across 15.3 kilometers, the geometric hidden height is 10.8 meters.
The 35.5-foot wall of water.
Yes. Even if we forcefully apply the standard atmospheric refraction allowance, which the environmental data and the lack of mirages explicitly prove was physically invalid for that night, the refracted hidden height is still 8.8 meters.
Still a nearly 29-foot wall of ocean.
But the intense source of the laser was clearly captured on a live stream at roughly 1 meter high. So when you calculate the physical discrepancy between the model and the observation, it means the laser was observed a staggering 91% lower than is geometrically possible on a globe.
91% lower. It's critical to understand that this isn't just a slight margin of error.
No, not at all.
It isn't a rounding mistake on a spreadsheet or a thermometer being a half degree off. An observation that is 91% out of bounds is almost diametrically opposed to the mathematical prediction.
The data we are looking at leaves us with an unreconciled, massive gap between the theoretical model and the physical reality.
And even if you give the globe model the absolute maximum benefit of the doubt and apply the refraction math that the physical environment did not support, the laser is still observed 87% lower than the maximum theoretical refracted allowance.
The math is literally failing the reality check. The light is piercing straight through physical space where the geometry insists a mountain of water must exist.
And there is an incredibly compelling visual detail in the source material that provides a powerful contextual anchor for this discrepancy. It's not just a red dot blinking in a black void.
Right. The source highlights a color-enhanced still image taken from the video of the red laser.
This is a vital piece of geographic evidence, because when they color-enhance the still to bring up the exposure of the background, you can clearly make out the landscape of Brighton illuminated behind the laser.
Specifically, The image shows the red laser positioned significantly below the structure of the Kings Road Upper Promenade in Brighton.
Now, why is that so important? Because the Kings Road Upper Promenade is a fixed, known, measurable geographical landmark.
According to Google Earth Pro elevation data, that promenade sits approximately 10 meters above mean sea level.
And when you factor in the specific low tide level of that evening, the physical, real-world vertical difference in height between the laser sitting down on the beach pebbles and the promenade towering up on the seawall is 12.9 meters.
12.9 meters of physical vertical space. So let's visualize the geometry here. You have a camera at Worthing, sitting just 1 meter high. It is looking 15.3 kilometers across the water. It sees the laser.
And directly behind the laser, it sees the massive vertical structure of the promenade towering 12.9 meters above the light source.
If there were a 10.8 meter convex bulge of water in the middle of the channel, that hill of water would be physically obscuring the laser entirely.
Exactly. The camera wouldn't see the laser at all. Instead, it would be looking up at the very top 3 or 4 meters of the promenade, peeking over the top of the water wave. The bottom 2/3 of the city would be completely hidden by the curve.
But that is emphatically not what the image displays. The photographic evidence shows a direct, horizontal, flat line of sight. The camera is seeing the laser perfectly level against the backdrop of the massive vertical wall of the promenade.
Which means the 1 meter test was an absolute, undisputed success within the strict parameters of their methodology. They set out to determine if collimated light could travel in a straight line across 9.5 miles of water at an elevation of 1 meter, and it unequivocally did.
So, as any rigorous scientific investigators would do upon finding an anomaly, they decided to push the boundary. They decided to make the physics even harder on themselves.
The team realized they had an opportunity to test the absolute extreme limits of the geometric model. They decided to lower the stakes, literally.
Dr. John D. takes his green laser at Worthing and lowers it from 0.9 meters down to approximately 0.5 meters above the tide level.
0.5 meters. We are talking roughly a 1.5 feet above the freezing surface of the ocean.
Simultaneously, Dave Marsh over at Brighton positions his camera down to 0.7 meters above the tide level.
So the light beam now has to travel 15.3 kilometers, skimming just inches above the waves the entire time.
Let's look at the mathematics of this new elevation. What does the globe calculator say happens when you drop the target and the observer closer to the surface?
It's actually an inverse relationship. As you lower the elevations of the observer and the target, the amount of physical curvature blocking your line of sight increases.
Oh, wow.
At these new heights of 0.7 meters and 0.5 meters, the geometric hidden height on a 40,075 kilometer globe increases to 11.9 meters.
So the wall of water just got taller. It went from a 10.8 meter obstacle up to an 11.9 meter obstacle.
Yes. And again, calculating for the invalid standard refraction model, the hidden height would still be an immense 9.81 meters. A massive physical barrier of ocean should be entirely blocking the path of the photons.
And what were the results of the 0.5 meter test?
The camera, sitting at 0.7 meters, perfectly and clearly captures the intense green source of the 0.5 meter laser from 15.3 kilometers away.
The beam cuts right through again. Unbelievable.
Yes. When we analyze the percentages for this new elevation, the laser is being observed an astonishing 95.8% lower than mathematically possible on the standard geometric globe model.
95.8% lower. The discrepancy is growing exponentially. The closer they get to the water, the more the physical observation completely defies the accepted mathematics.
It's wild.
But what I find incredibly charming about this specific section of the source material is that it highlights the friction of doing real-world data collection. Yep.
Oh, yeah. Conduct precision optical measurements on a dark, wet, freezing beach in the middle of February is not a sterile laboratory environment. The physical world fights back.
You're referring to the technical difficulties they experienced with the YouTube live stream.
Exactly. The source explicitly includes the transcript of the live stream buffering and dropping out. They are out there in the cold, trying to encode and transmit high-definition video over a 4G mobile network on a desolate beach.
The transcript reads, "We've lost live stream, it's reconnecting, come on." And then you hear a voice in the background say, "We're getting messages off my phone. It's very whack to do conspiracies under it." It's quite funny, right?
It is such a vital methodological detail to include, because leaving those raw, unpolished, buffering moments in the final presentation acts as an undeniable timestamp authentication.
If you were trying to fake this data, if you were trying to manipulate a video to trick the public into believing a geometrical impossibility, you would edit that out.
Of course. You would present a slick, seamlessly produced video.
But they leave the buffering in. They leave the freezing frustration in. It proves that this is a real live event struggling against real-world technological limitations and that absolutely no video manipulation occurred. It completely authenticates the timeline of the raw data.
And that real-world pressure is mounting rapidly in the background because they aren't just fighting bad cellular service, they're fighting the gravitational pull of the moon.
They are racing against the incoming tide.
The water level of the English Channel is starting to rise up the beach, actively threatening to engulf their lasers and cameras, which leads to the absolute climax of the entire observation.
The last try.
The source transcript details Dr. John D. announcing frantically on the live stream, "Last try, last try." He knows the water is going to wipe them out in minutes.
So what does he do?
He takes the laser, removes it from the tripod, and places it a mere 15 centimeters above the churning incoming tide level.
15 centimeters. For you listening right now, 15 centimeters is roughly 6 inches. Take your smartphone, look at the length of it. That is roughly how high this high-powered laser is sitting above the dark, chaotic water of the English Channel.
If we connect this to the bigger picture, we have to dive into the deep physics context of what the atmosphere is like 6 inches above the ocean to really understand the severity of this angle.
Right, because this isn't just about geometry anymore, it's an optical nightmare.
When a laser is placed 15 centimeters above the water, it is grazing the very skin of the ocean. It is passing through the absolute thickest, most turbulent, most moisture-heavy part of the lower atmosphere. You have microwave action, you have evaporation, you have dense salt aerosols constantly spraying into the air.
From a physics standpoint, that 6-inch corridor is basically a blender of optical interference. It is the absolute worst-case scenario for trying to maintain the cohesion of a light beam over a long distance.
The salt and water vapor should scatter those photons into oblivion within a few miles. It should be physically impossible for the light to survive that journey intact.
And yet the intense green source of the laser, sitting just 15 centimeters above the water, remains clearly, undeniably visible to Dave Marsh's camera sensor sitting at 0.7 meters on the other side of the bay.
The photons survived the blender.
Let's do the final devastating math on this last try scenario. What are the geometric parameters?
At an observer height of 0.7 meters and a target height of a mere 0.15 meters, the geometric hidden height of the standard globe model is still sitting at approximately 11.9 meters.
The nearly 40-foot wall of water is still mathematically standing there. And what is the percentage of the discrepancy?
The laser is observed an astonishing 98.7% lower than should be geometrically possible on a globe of 40,075 kilometers in circumference.
98.7%. Almost 100% of the mathematical model is defied by the physical observation. The math insists there is nearly 12 meters of convex water in the way.
And the camera sensor clearly sees the light skimming 6 inches above the surface.
According to the parameters of this specific test, the data we are looking at leaves us with a completely unreconciled gap between the model and the observation.
The light simply ignores the mathematical obstacle. It travels in a cohesive, straight line, perfectly parallel to the surface of the water for 9.5 miles.
So what does this all mean? We have an accepted mathematical baseline that failed to predict reality. We have rigorous localized weather data that eliminated the refraction excuse.
We have verified live-streamed result that pushed the limits down to a mind-bending 15 centimeters.
In the source video, Dr. John D. takes all of this meticulously gathered data and synthesizes it into 5 formal logical conclusions. Let's walk through them, not as a list, but as the logical, unbroken chain of deduction they represent.
The first conclusion directly addresses and dismisses the primary scientific counterargument,
which is refraction.
Right. Based on the data, it states that the temperature, the relative humidity, and the observational visual evidence of the stable horizon explicitly do not support the occurrence of atmospheric refraction between 0.5 meters and 1.5 meters above tide level on that specific night.
So they successfully isolated the variable of the weather. The air was uniform, meaning the light traveled straight, which allows them to definitively trust the result of the baseline test, leading to the second logical conclusion.
Yes, the baseline success. The intense source of the laser, positioned at a maximum height of 1 meter, was clearly observed and videoed by cameras at a maximum height of 1 meter, 15.3 kilometers away.
The photons traveled straight across 9.5 miles without hitting a bulge of water, which emboldened them to test the extreme limit of the atmosphere, bringing us to the third point in the chain.
The extreme limit test. The intense source of the laser, positioned less than 15 centimeters or 6 inches above the tide level, was observed and videoed by a camera at a maximum height of 0.7 meters, 15.3 kilometers away.
The light survived the most turbulent, dense part of the atmosphere right above the waves. Now, this is where the geometry meets the physical reality, and the fourth conclusion synthesizes the anomaly.
Conclusion number 4 states, these physical observations would not be mathematically or physically possible if we were living on a globe with a circumference of approximately 40,075 kilometers, or a similar-sized oblate spheroid on which water follows the geopotential surface of that globe.
I want to pause on that term, geopotential surface, because it gets thrown around in these debates a lot without being properly explained. What does that actually mean in the context of ocean water?
A geopotential surface essentially refers to how water behaves under the influence of gravity. Gravity is not perfectly uniform across the Earth. It varies slightly depending on the density of the rock beneath you and the rotation of the Earth.
Okay.
Water, as a fluid, will always seek its level, meaning it will settle into a shape where the pull of gravity is perfectly perpendicular to the surface at every single point. On a sphere the size of the Earth, that surface cannot be flat. The geopotential surface must curve around the center of mass.
So if the Earth is a ball of that specific size, gravity dictates that the 11.9 meter convex bulge of water must physically exist between Worthing and Brighton.
Exactly.
But if the camera sees the 15 centimeter light traveling in a straight line, the 11.9 meters of water does not exist in that physical space.
Right. Therefore, the physical observation is geometrically impossible on that specific model, which inevitably leads to the final ultimate conclusion drawn by the source material.
What's the final verdict?
Conclusion number 5 states that, therefore, within the strict documented parameters of this specific observation, the globe model is completely indistinguishable from a non-curvature or flat model, all the way down to a height of 15 centimeters above the water.
The surface of the English Channel behaved optically and geometrically as though it were a perfectly flat plane for 15.3 kilometers.
It did.
Now, there is an incredibly small but vital detail regarding that 15 centimeter limit. I can hear the skeptics asking, why didn't they test it even lower? Why not put the laser 2 centimeters above the water to see when it finally gets blocked?
The source is very clear on this limitation. The reason they couldn't test below 15 centimeters had absolutely nothing to do with Earth's curvature, hidden height, or geometry.
What was it then?
It was purely a mechanical limitation caused by the physical, rocky nature of Worthing Beach. At less than 15 centimeters, the physical mounds of rocks and pebbles on the beach itself simply block the path of the laser lens.
So the local topography of the beach got in the way, not the global geometry of the ocean. Now, this brings us to a part of the source material that I find profoundly inspiring from a purely scientific methodology standpoint.
Yeah, how he wraps it all up.
Right, because Dr. John D. doesn't just drop these 5 explosive model-breaking conclusions in a video and walk away, demanding that his YouTube subscribers just blindly believe his math. He ends the presentation with an open invitation.
He issues a public challenge. It is the very essence of the scientific method in action.
He explicitly invites anyone, scientists, geologists, casual skeptics, curious locals, to come to Brighton with their own laser. He says, you sit on the pebbles at Brighton Beach with your equipment. I will sit on Worthing Beach with mine. We will FaceTime each other so you know I'm not faking it. We'll shine the lights, and you can measure the geometry for yourself.
It is a complete and utter rejection of relying solely on theoretical models, unverified textbook diagrams, and assumed math. It is a demand for repeatable, observable, and measurable physical reality. He is essentially saying, do not take my word for it. Trust your own eyes. Trust your own instruments.
And that prompt to go out and do a similar observation for yourself is so vital because it completely demystifies the scientific process for the average person. It reminds us that science isn't just something that happens in sterile billion-dollar laboratories with particle accelerators and white coats.
Exactly. Science is measuring the world around you. Science is setting up a camera and a laser on a freezing beach, checking the thermometer, and seeing if the physical reality actually matches the math in the textbook.
And in this incredibly detailed, meticulously documented instance, the textbook math failed the reality test in a spectacular fashion.
It really did.
So let's take a step back and look at the massive journey we just unpacked. We started with an accepted mathematical baseline over 15.3 kilometers. Earth's curvature dictates nearly 11 meters of hidden height, a 3-story wall of water.
We examined a grassroots experiment that set out to empirically test that premise using highly collimated lasers and optical zoom cameras. positioned just inches above the ocean surface.
We rigorously analyzed their microenvironmental data, confirming that they eliminated the standard scientific crutch of atmospheric refraction by proving a complete lack of density gradients through perfectly consistent temperature and humidity readings.
We followed their live-streamed transparent methodology as they lowered the laser from an established 1 meter baseline down to 0.5 meters and finally to a harrowing 15 centimeters above the churning tide, surviving the worst optical turbulence the atmosphere has to offer.
And we tracked the resulting math, finding that the laser was observed a staggering 98.7% lower than the globe model mathematically allows. If you accept the data exactly as it was presented that night, it forces you to confront a massive, undeniable geometrical discrepancy.
It does.
But if you are listening to this right now, you might be asking yourself, okay, this is wild. It's a fascinating anomaly. But why should I care? I'm not a cartographer. I'm not trying to navigate a ship using the stars. How does the hidden height of the English Channel impact my daily life?
It impacts you because this entire deep dive is a masterclass in critical thinking and empirical demand. It is a stark reminder not to blindly accept that the math works out without demanding to see that math applied to the physical, observable world.
Especially today.
Exactly. We live in an era of unprecedented information overload, where we are constantly handed theoretical models, whether they are economic projections, epidemiological models, or complex geometrical models, and we are told by authorities to just trust the experts because the math is too complicated.
But this one dark, freezing night on the English coast shows us the incredible power of challenging those established narratives with localized, verifiable physical data. It shows you that you have the power to step outside, use basic tools, and question the fundamental shape and behavior of your own reality.
It empowers the individual to realize that empiricism belongs to everyone, not just institutions.
Exactly. And that leads me to a final provocative thought, a concept inspired by this source material, but something new for you to mull over as you go about your day. We've seen what happened on this one night of pristine, non-specialized conditions. The physical data completely defied the standard curvature model down to a margin of 6 inches, a 98.7% anomaly.
A near total failure of the geometric prediction.
Right. But what if we didn't just rely on a couple of dedicated guys shivering on a beach with a tripod for one night? What if we automated the empiricism? Imagine for a moment that we secured funding to build permanent, indestructible concrete pillars on the beaches at Worthing and Brighton.
Oh, I like where this is going.
We install weatherproof, computer-aligned lasers and high-definition optical sensors bolted down inside protective glass, positioned precisely 15 centimeters above the mean water level. And we turn them on, and we leave them running continuously, 24 hours a day, 7 days a week, 365 days a year.
You're talking about a permanent, automated empirical data stream, a continuous tripwire of light.
Yes. If we remove the human element entirely, we took away the cold hands and the buffering mobile internet, and we captured millions upon millions of data points across every single possible weather permutation, winter blizzards, summer heat waves, massive barometric pressure shifts, high tides, low tides, torrential rain, and perfect calms.
Wow.
If a computer recorded the laser's visibility every single second for an entire year.
You're asking, under millions of permutations of atmospheric conditions, would the 11.9 meter wall of water ever actually reveal itself and block the laser?
Exactly. If the math is real, at some point, the curvature has to manifest.
Yeah.
Or would the light simply keep shining straight through the data, day after day, month after month, completely ignoring the theoretical geometry of the Earth?
That is a staggering thought experiment, because if you run that automated test for a year and that beam of light never breaks against a wall of water, it proves that the map we've been handed is simply not the territory we are living on.
We want to thank you so much for joining us on this incredibly dense, fascinating deep dive. Keep questioning the math, keep testing your reality, and never be afraid to shine a light into the dark to see what's actually there. We'll see you next time.
Hello. Wow, nobody talks here.
Hello.
Yo, what's up?
Yeah, we can talk. What do you want to talk about?
Why do you guys believe that Earth is flat?
Well, it's not a belief really. It's more of a knowledge thing because we have we've done measurements, right?
Yeah, we checked.
I'm sorry.
No, it's that simple. We checked. It's flat. So yeah, we can confirm it.
Would you like to
Okay.
be with the evidence?
Well, do you have the evidences to prove that Earth is flat?
Yes. Would you like to be presented with it?
Please, show it to me.
Okay, I'm gonna do it in a fun way, right? Are you familiar with escape room games?
Escape room games, like the back rooms?
Escape room. Do you know what an escape room is?
No.
Like you're in a room and we give you a few items and you have to use those items to get out of the room.
Yeah, it's like the back rooms.
So I'm gonna paste it in the chat. Are you able to read the chat?
The side chat, right?
Yeah.
I will try.
Okay, cool. So here is the premise of the game and the items that we will give you and see if you can crack it. Can you read it?
How is it related to flat
Can you read it?
Earth?
Well, you're gonna find out. It's fun to play too, right? So we have listeners on YouTube listening right now. So if you would be so kind to read the premise and the question. Just play it with us. It's fun. Promise.
Yeah, I'm reading. A laser, a friend, a ruler, a lake. If waters. Okay. I don't know, but let's see.
I believe in you. I think you can figure it out.
Thank you. Bro, what is this?
Well, you know those pictures from space? Have you seen Earth, like NASA send out? They look like big round balls with some water and some land and
Yeah,
clouds and stuff.
yeah. They look just so round.
Right. So
Spherical.
yeah, you notice that the water is curving around the ball, right?
Yeah.
And they have told us the size of Earth. Do you happen to know the size of Earth?
No.
Right. So the radius is 3,959 miles.
Yeah, I know that.
3959, right? So because they have told us this, we can use math to figure out how much it has to curve over small distances. For example, over 10 miles, there has to be 66 foot of curvature if their claim is correct. If we live on a ball, there has to be 66 foot of curvature. Now, this game here has a calculator where you can do these kind of calculations, right? So you have all the data you need, and the question is, how high over your friend's head will that laser end up if you live on a ball?
Okay.
Take your time.
Okay.
Yep. How's it going for you? Are you on the calculator?
Yeah, I'm trying to calculate.
Okay, cool. Right, so while you do that, I'm going to talk to the YouTube listeners a little bit. We have a player currently, Rex. He is using the items we have given him. He's going to see if he can crack it here. It'll be interesting. It's called Escape from the Globe game. It's an escape room variant. SIQ6 says, this is good, by the way. You get Ipu to do it, so I'm amazed. Yeah, she actually, I don't think she understood it, but she did actually tell us the correct number. So a couple of people has been able to crack it. Maybe 9 out of 10 fail, but there's a chance.
Wow. Wow.
Kathus says, did she understand it? No, I'm not sure. I don't know. I guess we can ask her next time she's in here. She has some kind of short-term memory loss, so when you tell her something, the next day she forgets about it. Yeah, factory reset. Yeah, I don't know what she's the queen of either. You know, she's unemployed. He's the queen of unemployment, I guess.
Wait, how am I supposed to put the laser?
Yeah, you can put the laser any height, right? But I suggest you place it
I'm not
3
asking about the height. I'm asking how should I like how should I tilt it?
I'll give you a really good tripod. How about that?
But she didn't add it in the description.
Yeah, you're right. I better edit it then. You get a tripod as well.
What's up, guys?
Please wait your turn. We're talking to Rex right now. Mute yourself. We will get to you.
I'm sorry. No.
No problem.
Okay, then how? No, wait.
You got this. Take your time. No stress. We're going to be super chill in here today. No shouting, no swearing, no name calling. Just answering questions.
Okay, then no. Yeah, like if you give me a tripod, how am I supposed to like do the I don't know what's the word. It's called
Well, you're going to shoot it to the other side and you have a friend, right? So maybe your friend can help you. Or are you
like
asking
how am I supposed to align the alignment of the laser of the tripod?
Yeah, just put
Even
it at
if you
90 just put it at 90 degrees. You'll be fine.
Okay.
You have a ruler too, right? So you can use that to help you level it. The ruler is exactly 3 foot long, so
Wait, but
3.5.
okay. Bro, how what the how am I supposed to put it at 90-degree? Like, okay, if you're telling me that it's 90-degree, What's the reference? What's we taking as a reference?
The sea level, the water, you're right next to it. It's flat, close to you, right? Or is it curving? I mean, that's what you need to figure out. But you can use the
Okay.
ruler. Put the ruler put the ruler there and, make sure it's 3.5 foot over the water. Katos is saying, is he asking how to establish the tangent? Yeah, maybe he is, Should we give him some help? He should be able to do this with the ruler and the laser and a nice tripod. Get one of those nice tripods with like a water leveling thing, a water bubble in it.
I'm trying.
They can do it with built in water. All right, there you go. I gave you a better tripod. It has a little water bubble now, so you can make sure it's perfectly level, shooting straight over that lake.
Okay. Okay. Um, is it 60 feet?
Well, the tangent, you're getting close, actually. Which numbers did you put in?
Oh, I put 3.5 laser above the water, and then I'm assuming that the tripod you have given me is laser. Like it makes a perfectly what I don't know, like
So if we
it's
look at the
perfect. It's just
calculator,
perfect. Yeah, it's
good. We put
it's
the
basically
distance.
parallel to the water surface.
Let's put the distance to the object in first. What's the distance to the object according to the game? Is it
What's
9.5?
yeah, it's 9.5 miles, yeah.
Okay. The eyesight level or laser level is 3.5, right?
Above the
Good.
water, yeah?
Yeah, 3.5 foot is the eyesight level. Okay, and then you get some values there. If you answer the obscured object part correctly, you win.
Is it 60 feet?
No. Try again.
It's not 60 feet above the water.
Not according to the calculator, no. I can do a screenshot here and see if it looks the same for you.
No, wait. Trying.
Yeah, you can do it.
Bro, it's 54.
But you're getting closer.
Is it 54 feet? Is it a
No.
54 feet?
No. What did you type in for distance to the object? 9.5 miles, right?
Yeah,
And
9.5. Then for the
eyesight level
observe,
is 3.5 foot. And then it will tell you the distance to the horizon in miles, and it will tell you the obscured object part in foot.
Yeah, I told you 54 feet. Yeah.
Must have typed in the wrong number. Are you using commas or a dot? I think the calculator wants you to put 9.5 as the distance and the eyesight level 3.5. That should be it. It should give you an obscured object part at the bottom. It's not 54.
It's not.
No.
Okay, that's amazing. Wait.
Take your time. Yeah, maybe you have it in kilometers. It has to be in miles. That could be it, sick. Let me see if that's it. Go to the calculator.
Oh shit, my bad. Oh shit. Wait. There we go.
You can do it, brother.
Yeah, I guess. I'm not sure. 0.5 miles, 3.5 feet. Okay, so it gives me 10.5 meter, 10.5
Yes,
feet.
that's good. And you have it in meters. I'll accept your answer. You actually managed to crack it. Do you know what this means? It means that
No,
unless
wait.
yeah, you can change it to feet if you want to FT, right? And then you're gonna get another number. But 10 meters is correct answer actually.
But it's not the height to the head.
Well, the thing is, if you shoot the laser 3.5 foot over the water on one side, you shoot it 9.5 miles. That's the width of the lake. And you have your friend over there. That laser has to end up over 10 meters up in the air, you know? So if you have a 2 meter tall friend, that laser needs to be about 8 meters above his head if you live on a ball with the size that they have told us. Do you understand? I can post a little graphic that shows how it works, right? Let's see.
Okay. Like the person, the observer, is he above 3.5 feet? The
I mean,
watcher.
your friend is standing on the beach on the other side, right? So when you shoot that laser, if you live on a ball, the laser is going to end up 10 meters up in the air. Look at the picture I just posted, right? Imagine you're up on the top of the ball there, the Earth or whatever. This is a NASA picture. And you shoot the laser straight out, and your friend is 9.5 miles away from you. The laser ends up over 10 meters above the water on the other side if you live on a ball. You understand the logic in that?
I'm trying.
Yeah. I mean, obviously, you're new to this, so I don't expect you to get it immediately. But if you look at the pictures, you can grab it. You can grasp it. I'm very proud of you. You actually did a calculation. Very good. 10 meters. So,
Okay. Appreciate it.
yeah. Well, the problem here is that there is a problem, right? Because when we do this test, and we have done this, the laser doesn't end up 10 meters up over the other beach like it should do if you live on a ball. If you shoot the laser 3.5 foot over the water on your side, it actually ends up 3.5 foot over the water on the other side because water isn't curving, it's flat. And we have a proof. Here's a live video. That exact distance, peer to peer. This guy, Dr. John D, He is a doctor in spectrometry, and he was a glober, right? He thought that the Earth was curving, so he went out to try to prove, that it's curving. But he's done many of these tests, and his laser shot in this video.
Showed me send the video.
Yeah, I sent it in the chat. So in this video, he does this exact thing, the exact distance, 9.5 miles. He put this laser 3.5 foot over the water, and he shot it 9.5 miles, and it ends up 3.5 foot. It doesn't end up 10 meters up in the air on the other side, which it has to do if we live on a ball. So water doesn't curve, dude. So you don't live on a ball. Earth is covered by about 70% water, so I don't know what shape it is, but it's definitely not a ball because 70% of it is flat.
Oh.
And that's our evidence for Earth being flat, right? So that's the presentation. Do you have any questions? Feel free to ask.
Wait. I'm trying to process.
Yeah, of course. Take your time. And we have hundreds of these. We could paste a whole bunch of these tests. So you can go out and do it yourself. I don't know how
Okay,
tall you are.
wait. Let me
Okay,
process.
sure.
Okay. Okay, so okay, I got you. Take time. Yeah. So I was asking that are you there?
Yeah, here. Go ahead.
So let's suppose if the laser does not end up like where you're expecting, so how will you distinguish between like the between Earth is flat and it was not aligned like the laser was not aligned perfectly?
Well, it
How
hits
would you
the target.
distinguish?
It hits the target 3.5 foot over on both sides, right? So that's how we know. If there was a curvature, it should end up 10 meters up in the air, right? As a matter of fact, you have a distance to the horizon in your shot there. Let me paste my screenshot here. You see the distance to horizon is 2.29 miles, right? So that's where the laser actually should hit the water. Look at the picture DJ posted. It doesn't do that. It goes straight over the lake. Now, I was going to ask you before about your height. You don't have to tell me, but if you're about 2 meters tall, the horizon is about 3 miles out for you, but I promise you, in your lifetime, you've seen things further away than 3 miles. That's where water starts curving away from you if you live on a ball. But I think you've seen things 10 miles, 20
Can
miles
you
out.
well, yeah, okay. Um, can you show me the like the measurements, like which experiment are you referring to?
Yeah, of course. DJ has pasted it in the chat. I don't know if you have time, DJ, but you're better than me at this. So if you wanna go over it with him.
Oh, great. I was not looking at the side chat. Wait.
Okay, he can't VC right now. But yeah, we have these pictures in the video I sent there. They go over it in detail. They tell you where it was done. This was a live shot too. They did it live. There was an audience too, right? This was done 2019. We have hundreds of these, but I don't want to overload you either. But if you have questions about the
Yeah,
distance,
great. Wait, calm down.
yeah.
Oh, this is the real one. Like the Brington from Wooding.
Yep.
Okay. Um 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 can you tell me what does no observable refraction mean?
Yeah, no observable refraction. They did measure water and air temperature to make sure that there was no interference, by the environment that the laser was going straight over.
Bro, but even small amounts of refraction can noticeably change a long distance laser path, right?
Yeah, so he made sure that didn't happen, and we have a refraction calculator where we can grant you 120% refraction, which you can't even do that in a lab, basically. And that's going to take
What about the mirage? Was there any visible mirage?
mirage. There is no mirage, no.
Mirage, my bad.
Yeah, no.
Wait,
So even
wait.
okay,
There was no visible mirage, right?
no.
Wait, so this does not prove that light was not bent? This doesn't prove light wasn't bent at all?
Yeah, it proves that light isn't bending because we took temperature and readings over the whole, in the middle, at the end, and at the beginning. So no, there was no
Wait,
refraction. But I can
how?
grant you refraction. I can give you refraction, right? If you want it. Look, I'm gonna do it. I'll paste it in the chat here.
Like send me another photo which says like absence of the visible mirage, like proves that light was bent. Like
Yeah,
I
no,
don't think so. Like absence of visible mirage, it does not prove that light wasn't bent at all.
the light didn't bend because he
Right.
did the temperature. Go ahead.
What causes miraging, what causes the light to bend wasn't present because we have uniform temperature and humidity. So you don't have the mechanism for the light to bend.
And also like you literally ruled out the atmospheric refraction, bro. Like you're just saying there wasn't any.
No, it was measured that it's not possible because if you knew what caused atmospheric refraction, it was accounted for. And those charts right there show you.
Okay, wait, let me read. Oh, by the way, did you only measure temperature and humidity? That's it?
Temperature is the primary controlling factor of the refractive index in the lower atmosphere, along with humidity being second. There's nothing else that you would need to take into consideration over such a small vertical height above the water.
Okay, okay. I got you.
Like what causes mirages and minor refraction effects is temperature gradient differences. It's temperature usually. That's what
Also, like
causes it.
the experiment you're talking about, is it published?
Well, it's done by a PhD, right? Dr. John D. And it's not published in a journal, if that's what you're talking about, right? No journal's going to accept this. This goes against the globe.
Rex, listen, the point of showing you this is that you can go and replicate it yourself. You don't even need a laser. You can just buy a signal mirror over on Amazon for $20, right? Take your friend over to a beach on the other side of a 10-mile wide lake. If you see that mirror flash to you, there's no curvature between you guys. But he should be hidden by over 10 meters of curving
Wait,
water.
wait. I'm not listening to you. I'm reading the temperature and relative humidity.
Okay, go ahead.
Okay, okay. So you did something. That's great. That's great. Hmm. Um, like these measurements, like how would you say that these measurements will say that the atmospheric refraction was like it was not observable, like negligible, yeah? Like entire 15 15.3 kilometers, right? It was 15.3 kilometers, right? Like, how would you say that these measurements determine that there was no um atmospheric refraction over the entire 15.3 baud?
Because for this to work on a globe, you would need extreme levels of downward bending light. And when the laser was placed just 15 centimeters above the surface of the water, if the laser was bending down at all, it would just hit the water. It would never make it to the target. Also,
No, wait.
the
Wait. Start from
Mhm.
the beginning. Like whatever you say, start again. Just repeat.
Okay. Right. So they shot the laser from different heights above the water. From 1 meter being the first height, and then they lowered it all the way down to 15 centimeters in the last observation. Now, for this observation to work on a globe, you would need extreme levels of atmospheric refraction, and that would be bending the laser beam downward extremely, right? Extreme levels of downward bending light for this to work on a globe. Because the laser wasn't bending downward, it was making it to the target, and the laser was shot from 15 centimeters above the surface. If the light was bending downward, the laser would have hit the water and not been able to make it across the distance. Also, to have extreme levels of atmospheric refraction, you would have to have miraging effects. Low levels of atmospheric refraction, you wouldn't have miraging effects, but that wouldn't help this observation for the globe. You would need extreme atmospheric refraction. Basically, standard refraction, normal refraction, right? When you have a clear view, that's 15%, right? So basically, you would be able to see 15% further.
Okay, wait. Did you say extreme refraction, which would be like giving strong mirage?
Yeah, once you start getting extreme refraction effects with visible light, you start getting superior miraging effects. Yep.
So you're saying no mirage means no refraction? Meaningful or whatever
No.
acceptable refraction?
Yeah, if we have like minor levels of refraction, you don't have a mirage. But you
Bro.
also don't have the observation being able to work on a globe if you have low levels of refraction.
Bro, this needs so much calculation. Like, do you have anything like how like the calculation that somehow proves your temperature measurements, pressure, humidity, whatever? Like, do you have anything like that? All the calculations?
Yeah, with the temperature and the humidity readings, you would have no refraction. There's nothing there to give you any refraction because we have uniform temperatures and
No,
uniform
I'm asking
humidity.
for a quantitative analysis, not that.
Yeah, it's in the video.
Which video?
Uh,
Wait, which video are we talking?
yeah, I'll tag you. I mean, I'll repost it.
No, I have to watch the whole video. Is it so long? Bruh, I have to watch the match.
I
Oh
mean,
my god, it's
I
43
can,
minutes long.
yeah, I mean, I posted the data, but I mean, you'd probably have to spend a month learning about atmospheric refraction if you want to understand it correctly. So look, here's the charts. I mean, this is what you asked for, but
I asked for quantitative analysis, but I have to watch the video as you're saying.
well, I've given you the mathematical analysis in the side chat there from the video.
Wait. I was looking at the scoreboard. I'm not looking at the side chat. Give me a second. All right, I'm back. All right. Let me read. Oh shit, it's half time. Fuck. Bro, was it the PhD project? Like, did he made all this as a part of his PhD project?
Oh, he's been a professor, right? This is his career. So he's actually a retired PhD professor. He did his PhD in spectrophotometry, but this is something else that he was doing. He was trying to debunk flat earthers originally.
Oh, okay.
If you want to hear a really good review on this, there's a 45-minute presentation done about it, where it's just fed into Notebook LM. I don't know if you know what Notebook LM is.
What is it?
It's an AI software run by Google, Google Notebook LM, and
Oh, Notebook LM.
it
Oh yeah, I just know it by LM.
yeah, it's really right. So yeah, there's a 45-minute audio presentation where they basically just break down the entire thing and explain it in a really articulate way that makes it very easy to understand everything.
Oh, that's great. Drop it. I would watch it for sure.
Yeah, I will. Just a second. Here it is.
This is cool. Hmm. Bro, all I see is just inputs and conclusions. Like I'm trying to find calculations which connect the measured um some atmospheric values to your claimed refraction. I can't find it. I just see inputs and conclusion. Am I reading it wrong?
You wanna know how to, do the equations on how to calculate the atmospheric refraction using those values? It's gonna come out to there being no refraction.
Yeah, I gave him a link to the refraction calculator, and even if we grant him 120%, his friend is going to have to be 11 foot tall for him to see him, so it doesn't help him. And there's never going to be 120% refraction either. But we can grant it if that helps him.
Oh, okay, this is a link. Alright, give me a sec. Wait, did they start playing? No, they're not playing. Bro. No, wait,
Rex,
what?
do you prefer the metric system or the imperial system?
Metric system, and what did you say next?
Imperial, like inches and miles and feet. Or meters? Do you prefer meters and centimeters?
Oh, I prefer meters.
Just okay. All right. Well,
Metric system, yeah.
I'll put it into the metric, and I'll send you a link, and it's got all of the calculations and everything. So
Well, I have a
I'll
follow-up. Like, where did this 0.993 came? Like, which equation links you this measured value of your refraction
that's
coefficient 0.993?
yeah, right. So that's based on the radius of the globe and how much the light would be bending in comparison to the radius value of the globe. So that's basically how they calculate for refraction. So it's derived by little k, right, which is the refraction coefficient. It's
Radius of globe and the what was the next? The bend of the laser?
how much the light ray is bending due to
Oh,
atmospheric
okay.
refraction. Yeah. But I can give you the this website with the advanced calculator on it. It
Sure.
will tell you exactly how it's calculated. It's kind of complicated though, but I will share it.
Wait, they're not playing. Yeah, I'm waiting for the second half to start. Until then, I'm just asking them. I mean, they were answering, so it's all good. If they tell me to find it by myself, it's gonna be a hard thing for me.
All right, here we go.
Wait, where's the link? Yeah.
It's all coming.
Wait, how did the value of K came? What did you say? Like, I think I didn't hear. Like you mentioned K. Like, how did you bought the value of K?
Just to give you you want to know how k is derived in general, or do you want to know what it means? What do you want? You want to know the specific formula on how to derive
No,
K,
like
or
I'm
what
asking
or
like
what
how.
is K, or like what is
No,
K?
no, 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 no. I'm asking how the value of K for this experiment was derived, like from your atmospheric condition, the measured atmospheric condition.
Oh yeah, K equals 0.
Yeah, I'm
Right,
asking how
because
did
if you do
you bring the value?
the only way you can have a positive or negative K value is if you have an actual gradient, right? A temperature, pressure, and humidity gradient, and we don't have the conditions for the gradient, so K would be equal to 0 according to the measurements of the temperature and pressure in the observation. But if you want to know how to derive K using the values, you would have to use one of many different formulas you could choose from, right? You could derive the refraction coefficient using the Edlin formula, and then you could use the Snell's law differential form formula to calculate what the refraction coefficient is. This is what the easiest thing to do, right? You would work out what refraction coefficient, right, which K value would be required for this to work on a globe. And then you would see if the values that we have would allow that to be possible.
Okay, okay.
Yeah, it's a much easier way of doing it because we already know that the laser's hitting the target. So we say, okay, if the Earth's a globe and we want the laser to hit the target, what refraction coefficient would be needed on a globe? And that value is 0.99, which is basically
Wait,
extreme levels of refraction.
yeah, yeah, I got you. Like when you say K equals 0, was it predicted before the experiment?
It's predicted because of the temperature and humidity measurements, and also because of the visual clarity, but
So
mostly
it was
because of the
so it was predicted before
temperature.
the experiments from the atmospheric measurements, right?
That's correct. Yeah.
Oh, okay. That's cool.
So the easiest way to do it is to see that okay, with 0 refraction, we would have 15 meters of hidden height according to the advanced Earth curvature calculator. So I'll just take a screenshot just of this one particular section. Okay, I'll paste it again. So here you can see visible 0, hidden 15 meters. Now that's with no refraction. Now you can see a red slider. It says refraction 0, and then you can see a red slider. Now what we want to do is we want to slide that refraction up until we have hidden 0.
Okay. All right.
Okay, so now I'll start to slide it up, and then I'll take another screenshot. So right, so this is now I've slid it up until it's got down to 0.
Hold on. Yeah, send it.
Yeah, yeah. So this is sent. Just a second. Right. So now we can see that now we have hidden 0. Okay. So now nothing would be hidden on a globe, and we can see that for that to be possible, we would need a refraction coefficient of 0.99. And if you look it up the top, it's extreme, right? That's basically maximizing the refraction limitations on the calculator. Right, this is an unrealistic amount of refraction, by the way.
Yeah, let me. I'm seeing it.
So for this, basically, right, so the radius on the globe is 6,371 kilometers. So for this observation to be possible on a globe, you would have to have a radius value of 907,600,000 meters. That's how big the
Yeah.
globe would have to be.
Okay. Okay. Hmm.
What I would recommend is just have a think about it. And if you find time, watch the video. But I recommend watching the AI breakdown of it because I just listened to it today and they do a very good job, a very honest job of breaking it down. You know, it's unbiased. It's literally just been asked to just break down the video, you know. So yeah, it's good. They explain it really well. They make it all easy to understand.
All right.
But
Yeah, I will definitely
you
check it
sound
out.
like yeah, you sound like a smart guy, so I'm sure you'll understand it very easily.
I don't know about that, but yeah, I will check it out.
What country are you from, by the way?
Poland.
Oh, did you say Poland?
Yeah.
Oh, cool. Yeah, I'm near Lublin at the moment. I'm in Poland as well.
That's great. That's great.
It's a great country. It's a good country, man. I love Poland. I've been living here for 5 years.
Oh wow. Wait, did they start the match? Oh shit, they have started it. Oh, there are so many things I have to look for. The first signs, where's the experiment, where's the derivation? All right.
Yeah, you're best off when you get time. Just watch the video and
I
listen
mean,
to the review. And
yeah, I don't want to ask everything from you. I have to find some things from by myself as well.
yeah, I understand.
Ooh. Well, all right. I'm gonna go and watch the FIFA, the World Cup. I will be back maybe after yours. So yeah.
All right, man. Enjoy the match. Catch you next time.
Yeah,
Yeah. Bye
good
bye.
talking to you. Bye.
See ya.
All right, once again, good assist there. Thank you, DJ. If this was a soccer game,
Good
I
job.
would be the one doing the easy work and then passing you the ball to do the actual goal. So well done.
No, that was good. I like that you've incorporated the game into the actual test, you know, because once they win the game, then they get a prize. And that's the test.
Yeah, well, your idea. I'm just trying to do my best in here. It seemed to
This
work.
is the
He
yeah,
was
man. I mean, this is a
laugh.
killer observation.
Yeah, I like it a lot. It's good. But this also shows that people can come in and be like jerks, laugh and giggle and do all of that stuff, and you can quickly take them down to, reasonable levels. It can work, even if they sound like total idiots at first. He was very reasonable at the end.
Exactly. Yep. I find that to be the case a lot. You know, you've got to build that rapport with them and kind of get their respect and get them past that flat earth is a stupid thing, right? Because that's the propaganda that gets to them, and they have a presupposition of flat earthers in their mind, and once they realize that we're not making crazy claims here and we have a lot of great data to share, they change their tune. That's why the conversations, if we meet their mockery and ridicule with hostility, um, what could turn into a good conversation can never get to that stage.
Yeah, they're going to
It's
be
weird. I
defensive
think
then.
exactly. Sometimes it doesn't work, right? But I think it's important that we give every person a chance to get to that stage rather than just have a combat with them, chase them away.
Exactly.
I prefer the conversation route until I start to see that they're being um, intentionally misleading and they're there on bad faith. Up until that point, it's like, let's figure out how we can come to mutual ground. Are we going to come to mutual ground?
Yeah, exactly. I think that's the real challenge as well. I mean, it's easy just to crush a glober by asking them to provide empirical evidence that we already know they don't have, right? And then taking it as a win when they have a rage quit or something because they weren't able to provide what we already know doesn't exist. I think the real challenge is to win them over, not necessarily to convince them that the Earth's flat, but to at least win their respect over and have them leave here with a good understanding that flat earthers have good arguments, right? And that they're polite and respectful and professional and they have data to back their claims up. Yeah, I think building that rapport with them at the start, it's a challenge in itself, right? Just the psychological aspect of the debate or argument or whatever you want to call it, to get them to listen, right? Half the challenge is to get them to actually pay attention. And once they pay attention, right, if you can get them to pay attention and maybe to respect you enough to pay attention, then the arguments are very logical, sound, and the empirical data speaks for itself. So, I mean, the challenge is getting them to that stage where they'll actually listen and respect you enough to hear you out and to really look at the data and to think about it rather than just being defensive and just trying to debunk it. I mean, it's good that they try to debunk it, but at least look at it. Don't just look for holes in it, right? Actually take in the data. I thought we were going to lose him for a second there when he said, "Has it been published like in a journal or something like that?" You know what I'm going to
Yeah,
do? I'm going to take this observation, I'm going to turn it into a very professional paper, and I'm going to put it all together with all the links, the sources, make it into like an academic paper, and I'm actually going to submit it to journals. I'll submit it to universities, right? So at least I can show those transcripts and and say, hey, look, we've tried to we've tried to present this paper to Harvard, we've tried to present this paper to all of these institutions, and they ignored the emails, which I think is probably what's going to happen. But at least we can say, hey, look, yeah, they're just hand wave dismissing it, right? They're not even acknowledging it. And then you never know. Maybe some of them will actually look into it and say, hey, this is pretty interesting.
By the way, DJ, you absolutely crushed it yesterday on that gravity pulling water equidistantly to the center of the earth to that guy. I mean, oh my gosh, the silence in those pauses.
Oh, the Indian guy. Yeah, he was listening. That was good. It's good when they actually listen. But I mean, look, that's the thing. That curvature has to be there. And if it's not there, then it kind of debunks the whole heliocentric model. And if they deny it, then they're throwing gravity under the bus at that point. If they deny that hump of water would have to be there.
Yeah, that's why I say, yeah, I absolutely do believe in gravity. And then it's like, does gravity make the earth a ball? And then that's where the contradiction takes place. Because hey, things fall down. I don't deny that. What that is, that's a different story. But one of the things that I've started doing is, when people say, you don't believe in this, you don't believe in that, I say, okay. And then I'll take them back to high school. Like, oh, yeah, the earth spins 24 hours a day. And that's what the sun is doing when it moves across the sky. And when when the earth is facing the sun, it's daytime. When the earth is facing away from the sun, it's nighttime. And I go through that whole entire heliocentric paradigm, right? Letting them know, like, hey, I was educated in the same exact thing that you were brought up in. And then turn around and say, but if the water is not curving into a ball like gravity says it's supposed to be doing, then that entire story is wrong. And I don't need to have a replacement story for you. And for a lot of them, they're just like, oh my gosh, he's right.
Yeah, absolutely, man. And I think it's actually good. It's a good way to build rapport and actually to get them to admit a bunch of things before you engage in presenting anything, is to actually just have a general chat with them about how gravity would pull all the water to the center, and how far away the geometric horizon would be, and have them admit a whole bunch of things before anything's even presented, and build rapport with them at the same time, because you're just having a chat with them about globe facts, right? And then by the time the observation comes around, they already respect you enough to listen to you, and they've already admitted to a whole bunch of different things regarding the geometric horizon, regarding that curvature having to be there, regarding hidden height, all that sort of thing. And then it would make it much easier mid-presentation, because they've already admitted this, they've already admitted that, and you can call them out on that, because otherwise they go into like cogdis mode. They have to think on the spot. They'll throw the globe under the bus just to try to save their ego, or to try to win that particular talking point. But if you can get them to admit a whole bunch of things before you've even presented anything, then I think it makes it much easier. I notice Cyclone does that a lot. It's a great technique.
Yeah, crypto did that a lot too. And yeah, no, yeah, I mean, I've had people, they're like, man, you know so much about the globe. Why are you a flat earther? I'm like, that's why I'm a flat earther, is because I know what the globe is telling me.
Yeah, man, if you got 5,000 random flat earthers and 5,000 random globe earthers, which group do you think knows more about the globe? Right? Obviously the 5,000 flat earthers. And 100% of the people in the group that knows more about the globe doesn't believe it's a globe. Isn't that funny? And it's not like the 5,000 flat Earth. It's know a little bit more about the globe. It's like orders of magnitude. So you got 5,000 people that know nothing about the globe, or maybe some of them know a little bit, but on average, they generally know crap all about the globe. And on average, the flat earthers know a fairly decent amount about the globe. So the people that know nothing about the globe all believe in the globe, and then the people that know a lot about the globe don't believe in the globe.
And your presentations have come so far so quickly, DJ. You know, kudos to you and Yoder. Yoder is just he's got all of
Yeah,
his
he's next
little
level.
yeah. He's got all of his quotations organized, and he'll drop like 20 of them on you in one sitting. I'm like, oh my god, this is amazing.
Yep. Yeah, he's very impressive.
But yeah, your presentations, man, they're like boardroom level, you know, great. And I mean, like I would even say they belong in classrooms, man.
Thanks, man. I'm just trying to get better at wording things. What I've noticed is just changing wording a little bit can make the same point come across so much differently.
I personally used to hate using buzzwords to try to like emphatically push what it is that I'm trying to push. But I like listening to what you, Yoder, and a few others are doing. Like I agree. Like sometimes you just got to use those words that kick the bucket over the edge kind of thing, and just say, hey, you know what? Here's the emphatic statement. Deal with it. So I love it. Like changing it from black swan to, well, I mean, it's really just white swans. We're having trouble finding black swans.
Yeah,
I
we
love
just
that.
need to change that. We should just change that to white swan. And that can be the new challenge, right? The Globers have to find the black swan because all swans are white.
You know, when you do the discussions on refraction too, you know, like for those anybody else that's listening, it's important to understand. Andrew Thomas Young said that it was extremely difficult to measure for atmospheric refraction, but there are certain conditions that are necessary, and so when those conditions are present, they're more predictable. It doesn't mean they're completely predictable; they're just more predictable.
Yeah, we don't need to perfectly measure for refraction because we're not making hyperspecific claims. We can just negate, right? Because we have such long distance observations, we need such extreme levels of refraction for this to work on a globe. If we can just negate that extreme level of refraction would be possible with the meteorological conditions, that eliminates the excuse of refraction right there. Because we're not saying this observation proves the Earth is flat. We're just going out and checking, like they're making the claim that they know the shape and size of the Earth. We're just going to test that. We can say, okay, we can see this thing very clearly that's 20 miles away. And to be able to see this thing so clearly, you would need a globe with a radius of 907 million kilometers. That means that you would have to have a refraction coefficient of 0.99. Okay, but we've got these temperature readings of on the day that show that that's not possible. Right? You don't have the building blocks, you don't have the material available for that refraction to occur. It's just impossible. It's scientifically impossible. It's physically impossible to claim that refraction can do that. And even the AIs that I've used, like that's why I say this Dr. John D. peer-to-peer is the best one. because he has uniform temperature, uniform humidity, and he's taken different readings at different heights at 3 points all the way along the path of the observation. And he even tested the accuracy of the thermometers, and he used not just one laser but 3 lasers using different spectrums, and then he did different heights, and he took everything into account much better than I've ever seen anyone else do. And that's why when you plug in the basic information into AI, it says that no, this is not possible to explain with atmospheric refraction, because you would need extreme downward bending of light. If you're putting the laser level 15 centimeters, which is 6 inches above the surface of the water, and you have extreme downward bending of light, where's the light going to go? Straight down into the water. It's not going to get there. It's not possible to explain this with refraction.
No, definitely that
Hello?
even temperature. Sorry.
No, I just said hello. I'm listening.
What's up, man? Yeah, you're right. What were you saying, Sheepdog?
I might lose signal, but what I was saying is that even temperature.
Oh, yeah.
And,
Yeah, you called it, man. You're
you
losing
have
signal. You're roboting now.
By the way, DJ, are you claiming that Earth is flat, or are you claiming that Earth is round?
I'm claiming that I don't know what the shape of the Earth is, but I'm claiming that we have tests that prove that the surface of water is not curving. That's what I claim. Does that make sense, right? Like, so I don't claim to know the shape of the Earth, but I've studied a lot of tests, and I've done tests myself where we're testing for curvature over the surface of large distances, and I can't find any curvature. I can't find any water curving as would be required on a
But
globe. That's my position.
didn't you try to discuss this topic with some physicists or some professors?
Yes.
That
Yep. Yes. I've had conversations with physicists and professors and satellite engineers and all sorts of different people. Yep.
you also said that artificial intelligence, I don't know what model you are using, but you said that they agreed that Earth is flat, or at least not
No,
the shape
it's not a
that everyone told us.
yeah. It's not agreeing that the Earth is flat. It's agreeing that the test that was done isn't possible to be explained with the current globe model of the Earth.
So
I can
you
link you
did
to
the test.
No, a PhD, a scientist did the
I'm
test.
just asking.
I've done my
I'm
yeah,
more
I've done my
about
own
artificial
tests.
intelligence. Okay. Yes.
Yeah, I've done my own tests,
And
but I was just doing my tests confirm that there's no curvature, that the surface of water is not curving. I mean, there's so many tests that have been done now, and they all confirm that the
I
surface of
don't
water is
hear
not
anything.
curving. Can't hear me?
Now I can hear you. There problem is sound. I didn't hear you for a little bit.
Yeah. There's many tests that have been done, and we can't find any curvature over the surface of water, so take that information and look into it if you choose to.
I'm just. It's hard for me to understand this information because I have different there are different peoples. Some people say that from their test there is curvature, and they say, show from camera and from other sources. And there are other people that say that there is no curvature. And because I'm not into this topic, I just use formal formal position in science. Because if you are sure about your experiments, if you are sure about your conclusions, you can try to send your investigations to the people who work with this topic on a more serious level. Didn't you try that?
Yeah, yeah. That's actually what I was talking about that just about 10 minutes ago. So yeah, I'm going to be making
Oh, I'm
these
just joined.
into yeah. I'm going to be making these into into professional papers, and I will be submitting them.
It will be really interesting to
Yeah, absolutely.
see them. Maybe your some YouTube channel or anything something like this.
I do. I also have a YouTube channel, which I'll be making videos in. I mean, I already have some videos there already, but I'll be going into a lot more detail, this year. Yeah, lots of plans this year for making content and for making papers and submitting the papers where I can. So yeah, it should be an interesting year.
I just like to watch some topics where are constructive discussions between people who think that Earth is not the shape that we are told, and between people who think that Earth is in a shape that everyone told us it is. It's really interesting to watch constructive discussions. And this
I'll
is
share a
important.
channel with you.
It must be constructive.
I'll share. Yeah, I'll share a YouTube channel with you where we have hundreds and hundreds of good quality conversations recorded and uploaded.
Oops. So,
All right,
how
just a second.
can I?
Yeah, here it is.
Oh, there is a chat. Yes.
Yep, there it is on the level. It's constantly being added to
On the
as
level
well.
archive.
Yeah, you'll see conversations with satellite engineers, conversations with physicists, and all sorts of different people. People doing their master's degrees in physics and all sorts of conversations.
Okay, I will definitely. 1 minute. I will subscribe now.
Awesome. And I'll share my channel as well, because I'll have a lot of content coming out on my channel also. Anyway, I have to go because I have a lot of work to do. So I'll talk to you guys soon.
Thanks.
Good luck.
See you later.
Catch you later. Is Yoda back? You there, Yoda?
Yeah, I'm here. What's up?
Oh no, just check. I just noticed you were back. Did you happen
Yeah.
to catch the 45-minute breakdown of the Dr. John D video?
I did. I liked it. It's very easy to listen to. I really like that format and the product. Notebook
Yeah, I
LM
thought it,
really helps.
yeah, really good. I loved it. Just the way they, the way they went over it was very honest and very informative and just well articulated.
It's really hard to find this channel through search on YouTube. Looks like YouTube doesn't like this channel.
This channel is the top channel now. It's been for a long time.
I tried to search video from this channel, last video, and maybe I typed something wrong. I try to check Master Yoder and New Lens on Reality. I tried to search this video. No. Okay. Oh, yes, this was a typo. Okay. I think that he already gone. 1 minute. Oh, he's gone. I wanted to say that there is problem with using artificial intelligence because it all depends on how you write prompts. If you do it in some sophisticated way, then AI will say anything that you will like. So it just adapts for you. This is actually quite dangerous.
I had a hard time decoding that, but I think he was asking for Master Yoder's views on reality. Is that a video?
So it might be something Magian put together on his YouTube channel on the level.
Makes sense.
That Yoder's lens on reality or view on reality, that was a 15-minute rant where Yoder gave a brief history of how flat Earth was brought back into the conversation.
Okay.
Nice
I
frame.
don't recall which one that was off the bat.
I know which one it is because I play it all the time for the bot. It's the one I asked you to give a history on, and you brought up the P900 and the Reddit posts and how you discovered this on Reddit and thought it was stupid.
Oh yeah. Yeah. So I'm kind of in the middle of working on something. I can't very easily start rambling right now. But as far as my views on reality, so you're asking me about my view on reality. Well, I mean, I kind of bought into the Big Bang. I went in begrudgingly and went in with the idea that the Big Bang was God's creation event in Genesis. And I even went so far as to allow for some parts of evolution to be true, presented under the idea that it's guided, intelligently guided evolution. But I didn't go so far as to accept that man came from apes. For the most part, pretty much mainstream. I spent most of my life as a regular Protestant Christian American living in the United States. I got the same education as everyone else. I love Star Trek. I love astronomy. I grew up in a NASA house. And yeah, I found flat Earth to be pretty challenging when I first came across it. When I first came across it, I wasn't necessarily looking for it specifically. I actually was on a quest at the time to find out how the ancients understood their world. I wasn't really thinking it was flat Earth. But around that time was when the Nikon P900 came out, and people were posting their images and videos onto Reddit. That's exactly what happened. I looked through and I'm like, wow, this is kind of weird because people are saying that they're seeing too far with this camera. Not too long after that, I think Nathan Oakley's channel came on, and people were posting clips from his show where he was talking about elevation angles and seeing too far. So really, I kind of, I was drawn to it because it was an interesting conversation, but I really didn't give it the due deference and the seriousness that it needed to be treated properly, and I just kind of laughed it off. I remember watching Behind the Curve from Netflix, and it came out. I was intrigued, so I paid whatever the rent money it was to Netflix, and I downloaded it and watched it. I'm like, oh, okay, that was kind of dumb. Honestly, I thought that was kind of dumb. And I really didn't give it much mind. I didn't pay much attention to it until the lockdown economy happened, and I was bored. I'm like, I wonder what this flat Earth thing's about. Let me go check in on the flat Earthers. And so I did. I also took the radius challenge. People said that nobody ever measured curvature in order to come up with the radius value. I was like, that's BS. So I took the challenge. I went to go find it. I couldn't. My research brought me to surveying. Surveying was kind of an obvious choice to go to because, well, I mean, everybody knows what surveyors do, right? They measure the land for a living. So let's check surveying. Checked mapping resources, checked all kinds of other places too. And I just couldn't find it. I mean, people kept referring to other papers. In one paper, you'd read in the references, another paper, which references another paper, trying to find the golden seed value for that curvature measurement, right? And it all goes back to Eratosthenes every single time. Everybody seems to refer back to Eratosthenes, providing that golden seed value. So you go look up Eratosthenes. Was he even a real guy? And it's like, well, no. I mean, we have at best like tertiary sources. So we don't have firsthand direct accounts written of Eratosthenes even being a living figure. And his entire thought experiment was really just that. It seemed to be that if he existed at all, and if what he said was true, then it should have been taken as a thought experiment for the classroom. Like, well, if we could measure the Earth, here's one way we could possibly do it. I don't think it was actually ever done. And even if it was done, all the baked in assumptions don't prove anything either way, because he had to assume that Earth was a globe to begin with in order to say that these diverging rays were being measured as shadow lengths around a curving circumference. So yeah, that happened. And Eratosthenes didn't even consider that the sun was putting out parallel rays. He actually thought the sun was 12 times smaller, than what people think nowadays. But maybe that's parallel enough, right? Parallel enough to be bathing the Earth in sweet parallel rays. Yeah, nobody's ever proven that. I mean, if you ask me, the whole parallel rays is a coping mechanism for why nobody can triangulate the position of the heavenly bodies, flat or globe. Nobody can do it. I still can't for the life of me figure out why globers are asking flat earthers to triangulate the height of something that they themselves can't even do. It's like, nope, can't do it. Difference is I don't have a magical space ray story to tell about parallel rays from far distant bodies of immense size and practically infinite distance at that. But hey, Glober's gonna start making stuff up. They'll start conjuring parallel rays from in a magical universe. Okay, cool. So in the chat, SIQ says that Eratosthenes should have been able to triangulate the sun at a certain height. Granted, one or two observers can provide an apparent triangulated height of these bodies, but once you introduce a third observer, their views do not converge onto a single fixed point that is common to all three of them.
Would you call it a three-body problem?
Yeah.
I was actually talking to Matrix the other day and talking about how I had an Eratosthenes-like experiment that I can do most days right now. If I have clouds near the mountains, because I can, I'm right in the middle of the valley, and the sun will be right above my head midday, and no shadows, right on top of me. But if I look towards either ridge, and I can see both ridges in a lot of places, you can see shadows on the sides of the ridges that are coming from clouds that are still inside the valley. Very similar shadow kind of thing. And I was like, so apparently I'm Eratosthenes, and I live on a concave Earth because that's the shape of this little trench here. So doesn't really prove much.
Yeah, it's funny. We hear things from Globers all the time, right? So, we'll bring up, Eratosthenes couldn't triangulate it for X, Y, and Z reasons. And then the Globers will be like, well, yeah, that's right. But you can't triangulate the height of a star or a sun or a moon over flat Earth because three observers don't provide a single point of convergence. It's like, okay, can you do it on a globe? No. Okay. So if you need three observers or more, right? I mean, and you can pretend Earth is a globe. Does that mean Eratosthenes was actually did not prove that Earth is a ball because there were only two observers? Well, for somebody who's new and paying attention as they do research and they start seeing all this stuff, right? You start wondering, am I honestly being fed the truth here? People are telling me from all angles that Eratosthenes absolutely coherently, fundamentally measured the curvature of the Earth and was bang on accurate. That's the claim. And everybody sticks to it. And then you start scratching the surface a little bit. Well, was Eratosthenes, did he believe in a heliocentric or geocentric cosmology? Question number one. Question number two, how big did he assume the sun was? Well, so he's getting all these, relative to the current globe, right? He's getting all these cosmological assumptions wrong. And he somehow magically calculates the circumference of the Earth using those assumptions. We see this again and again popping up, like when Ole Romer, an astronomer, I think in the late 1600s or something, he's credited with actually calculating the speed of light and the distance to the sun. He supposedly did it by observing, I think, Jupiter's nearest moon and its position and phases. So he made assumptions using the whole cosmic distance ladder as it was understood at that time to begin with, using Kepler. But his scales were all wrong because, I mean, all wrong compared to the current globe cosmology because his scales, I think, put Jupiter either much further away or much closer. I forgot which direction, but it was something way off. But the ratios were accurate, right? Because that's the thing with Kepler. You you can take the ratios and you can plug in any value you want, and you can scale things big or small. But anyway, there's a bigger problem with that. It escapes me real quick exactly what it was, but Gerard Hickson wrote about it in King's Dethroned, which is a great book that challenges current cosmology. But basically, it had to do with I think Ole Romer not taking into account the potential parallax that would happen with the motion of the Earth during the time that it was observed that Jupiter's moon was transiting Jupiter. And had he taken that into proper account as it's known today, then he would have gotten vastly different results. And yet somehow through all of these assumptions he made that were wrong, he somehow got really close to the accepted amount, the accepted velocity of light as it's understood today. Time and time again, we find all these great men throughout history, from as late as 1700s going all the way back to antiquity. Regarding the globe, they made all these assumptions that are wrong by today's understanding, but they somehow calculated the correct numbers. It's just fascinating how much they could be wrong in their assumptions and their outcomes are true. It really gets you to question history itself. Like how freaking lucky were they? And I actually wrestled with this early on in my journey into this topic. I thought, well, Earth has to be a globe, but nobody can prove it. Did they just get freaking lucky, like with the V2 rocket program? Or they just like Kerbal Space programming the shit out of this and just launching rockets and crashing them again and again and again until they brute force got one into orbit and then figured out, oh, holy shit, we can do this with satellites. At one point I was like, maybe that's it. Maybe they just got freaking lucky. And then I thought, okay, they got lucky and they were correct. But the fact that they're getting lucky is concerning to me. Like, is this divine knowledge that's being given to them about a globe? Or is this demonic knowledge that's given to them to deceive us about the globe?
So you're telling that there are no rockets in the space?
No, I didn't say that at all. I'm saying that I was recounting like the V2 rocket program. If nobody actually measured the dimensions of Earth, that means they got freaking lucky with their rocket launches, putting satellites up. And you can take that claim and go back even further. It means they got lucky with this and lucky with that, going all the way back to antiquity. Just, astronomers observing and declaring what the cosmos ought to be are just getting really lucky with their inductive reasoning, coming to these calculated values of the distance of the sun, of the size of the Earth, and of the velocity of light. All of these were based off of very faulty assumptions. It's just kind of freaking hilarious.
But maybe they just did a lot of assumptions, but some of them worked, some of them didn't work, and they chose only those that worked, and this is how it all became so advanced.
Well, it's like this, right? So how did Eratosthenes calculate the circumference of the globe and get as precise as he did if everything else about his assumption in that framework, literally everything else, was wrong? You just got fucking lucky, dude. Let's face it. Or
I just don't know if something is repeated one more once and so on. So if something is repeated many times, then it's just not right to call it luck. This is at least some correlations. It's like math. You import some data, and then in return you get the same result if same data, if you base your answer on the same data.
Did everybody stop talking or am I tripping? So nobody wants to talk to the queen. I see how it. I had the most perfectest idea ever. Basically, since I'm so artistic, y'all, I want to draw y'all based on how I think y'all look. Period. I cannot wait for y'all to see.
Oh no. Anyway.
Hello guys, I am Kid. You like is funny, right? Yes or no?
Was that some kid?
Hey bro, this is my song. I ain't gangsta creepy, bro. I like you blow, G man. I ain't gangster, bro. Gangster. Yes, yes, yes.
Sound like you're 12. Are you old enough to be here?
Can you just fucking talk?
Bruh.
Oh. So period, like who wants to debate me? Come on now. Be mature. Don't act my age.
Stop the cap.
Be mature.
Can I just say yesterday, I am disappointed we didn't get more 9,000-pound winch against Dave Hinkle because Dave just wasn't willing to. He was too toxic. Dave wasn't willing to engage with him anymore. But that was about the funniest shit I heard in a minute.
What are you talking about?
There's a guy who comes up here has on YouTube channel. Dave Hinkle. He has a really deep voice from Kentucky, so he has a real Southern accent. And this guy, 9,000-pound winch, was a toxic cannonball coming through the server for hours yesterday. He sounded just like Dave Hinkle. Well, Dave came in and they started talking to each other, and it sounded like the good and evil half of one person talking to each other. It was, but neither of them could tell because you don't sound like yourself to yourself. So neither of them could tell if they sounded exactly like each other. It was hilarious, but he was an asshole, so Dave stopped engaging.
Oh, okay. Guys, I'm ready to debate, like, period, bro.
I have big cock. Uh,
What the fuck was that?
what the fuck was that? But brother, I'm impressed.
Guys, who wants to debate, bro? I got all my evidence down and checked. Like, I'm so for real.
What do you want to debate?
The topic, duh.
Okay, so what position are you taking?
I'm taking that Earth is a square. So nobody wants to laugh. Okay, all of y'all are funky.
I know it's a little off topic, but this is one of my favorite old world video clips. It's been majorly upscaled and put to a very haunting soundtrack. It's really cool. It's about 8 minutes.
I'm Donald Trump, and I approve this message.
It's crazy to think that, like, I had grandparents that were born before the 1920s. And I've met my great grandparents, and in even one case, my great great grandfather. When you have that kind of connection, and you potentially come from old stock in your country, I do. I mean, we're descended from settlers, at least on major branches of our family tree. When you've got old family Bibles that are kept up to date through the years, through the decades or centuries even. You've got keepsakes. I've got furniture in my house from the early 1800s that I got from an estate of one of my great grandmothers. You're connected to this period in time where people think that life was way different than we can imagine. And I don't know how different it actually was compared to how we think of it today. But I often do spend time wondering, what would people from the early 1900s think if they could see the modern world today? Would they be unimpressed? Right? Walk them through an average American's house. An average American's house is built anytime within the last, I don't know, 50 years. Maybe just try the last 20. I mean, the building quality is just utter crap. The materials and craftsmanship, everything is just utter crap by old world standards, I would say.
Well, it's pretty typical in this world, man. If the profit margin goes up, quality goes down. I think that's pretty correlative.
It used to be in the 50s that your average home would have hardwood floors.
my house we had built about 5 years ago. And it's okay. I mean, it's a modern house. It's got all the modern entrapments. But I'm comparing like the joists in the basement, open ceiling. I'm looking at all this engineered wood. It doesn't even really look like real wood anymore. You can see the joints where the different pieces were sectioned together, and then it almost looks like looking at the grain that it was glued together. So, and then
You mean
you
like
wonder,
blue
okay,
lamb?
yeah.
Yeah, blue lamb isn't terrible. But
Or I look underneath the deck and like the footers aren't exactly lined up totally, which means that the floorboards on the deck itself actually warp in a couple places, and I'm like, this is just so shitty. I got a friend's house who's built in the 80s, and I go into his basement, I look up at the joists, and man, this is like really well seasoned wood, like really tight grain, planed perfectly, leveled off perfectly. No evidence of twisting or crowning either, which you get oftentimes in these newer houses.
well, my buddy's house there actually had full dimensional lumber in the for the floor joists.
Yeah, and you've got the scandals, right? Like the medium density fiber board. The glue that held that together has like a 30-year life, and then it's all coming apart, man. It's all demolecularizing. Yeah, so I think people from 100 years ago, I mean, I think of course they'd be impressed by electronics, but I think they'd be confused because they're going to look and see a microwave or something, or a modern freaking air fryer sitting on a kitchen counter. They're going to look at a computer or an iPhone and be absolutely mystified. And then they're going to walk through that house and see the shittiest building materials and construction and handiwork that they've ever seen. I think they'd be totally freaking confused by this. Like, what the hell is wrong with these people? I mean, like, first off, they'll be like, where the hell are all the brick homes?
Hey guys.
Hey man, welcome.
Thank you. Are you guys talking about flat Earth?
Oh, most of the time we do, not necessarily just now.
Okay,
But yeah, I mean, we can get into it. You got any questions? Have you been looking into the topic?
Are you a flat earther?
Yeah, and pretty much everybody else here is, from the looks of it. We all are.
Why? I'm not trying to get into an argument. I just want to understand your reasoning. Why do you think that the Earth is flat? If you don't mind and if you have time.
Well, I mean, I started looking into it and made my own observations and measurements, and I came to the conclusion that it can't possibly be a globe. And then I learned about the history of the globe, and I realized that everybody's got this insane belief in a mathematical model that has, at best, some explanatory power. the globe doesn't actually exist, man. It only exists in mathematics.
Really?
Yeah.
I always have had this idea that we live in an imaginary thing. Not in imaginary, we live in a real thing. But the way the scientists describe it doesn't really make sense to me. Like everything they say is made on assumptions. Like most things they said, they actually say, it's not tangible. You cannot really physically see it.
Right. They build models based off of imagination instead of off of observable reality.
But it doesn't mean I am a flat earther. There are evidence on Earth that say that show that the Earth is not flat and it is indeed round. One of the first and one of the most popular is the horizon. What's your say about the people that say horizon is proof enough to say that the Earth is round? I would like to have a logical explanation if you would like.
Sure. What about the horizon would inform you that Earth is a globe?
So let's say, for example, we're on a beach, right? And there is a ship that's going forward, right? And it's going far away from you, and you're just standing in the same position. It will reach a position where you would only see the flag. I would say, what do we call the thing, the cotton thing in the ship? Anyways, you'd only see the top part of the ship, and you wouldn't see the bottom part of the ship. And I think that's proven off that the Earth is a globe, because things don't disappear instantly. They progressively disappear from the bottom part to the top part.
I've hardly ever seen this happen. I mostly don't see that happen. So I'm kind of curious to know what makes you think that you've seen this happen.
I didn't actually see it happen, I wouldn't lie, but I saw countless videos that show that this happened. And there are countless articles and researches that have been done about this topic, because scientists have proven that the Earth is not flat thousands of years ago.
All right,
Actually, not
let's stay
thousands,
on the
just
topic of the
centuries.
horizons, right? Because hold on, I mean, we can stay with horizons. You know, there are many reasons why you don't see the bottom of a ship as it sails off in the distance. First and foremost is the fact that the ocean tends to have waves and can have swales. So if there's a boat that's like 10 miles away from you and there's a swale that is 5 miles away from you and is about 5 to 6 feet high, it's going to block the boat. And if you have a situation where there are multiple waves going up and down, one right after the other, spanning for miles, and these waves are also, rising and falling, this would appear off in the distance from your vantage point as a single wall of water, and it'd be blocking the bottom of the boat beyond it. Waves don't have to be very tall. I mean, at that distance, maybe 3 feet tall from a 6-foot observer, you're not seeing the bottom of a boat at like 10 miles, man. You're just not.
So what you're saying is that the bottom of the boat did not disappear. It's only behind a wave.
Well, yeah, especially given that these vast distances, and given that boats produce waves called a wake.
That's true. I
You know,
also
so
did.
yeah,
I also
if the boat
found
is
this
sailing away from you, the wake is in front of you.
Yeah.
And that's only one explanation. There's also other things happening at the same time. The
Yeah,
second thing that's happening is an inferior mirage.
What? I'm sorry? Inferior mirage?
Yeah,
Oh,
there's miraging happening.
Yeah. Okay.
Right? We see miraging very much in humid environments And most people in the world live within the tropical climates. If they have access to water, they're going to be seeing humidity in the distance. And the humidity and the air temperature can such vary that it creates a gradient, a steep gradient. A steep gradient can cause what's called sinking refraction. And sinking refraction is defined by an object that appears to be sinking even though it really isn't. It could also appear to be obstructed even though it really isn't. And this is a very common occurrence, sinking refraction. You can read about it. There's a famous optical physicist named Andrew Thomas Young, Dr. Andrew Thomas Young from
Andrew Thomas Young.
Yeah. And he writes about refraction. That's his bailiwick. That's what he loves to study and write most about, it seems. And he came up with different categories of refraction. Refraction being phenomena that seem to precede a mirage, which would be a much steeper gradient than one that produces refraction.
Is this guy a flat earther? I might ask.
No, not at all. But you should read his definition of sinking refraction.
Okay, that's interesting.
Yeah.
So
And
why?
and to make one more point about this, okay, I'll be done in just a second. We've done observations over a lake at short distance using radio-controlled boats. These distances and scales are so short that if Earth is a globe, then these observations can't be explained by a globe. And we can produce the bottom-up obstruction using radio-controlled boats on a small lake. And it's by virtue of the weather and by virtue of the waves and the foreshortening of perspective, the weather producing temperature inversions and steep gradients of temperature that contribute to sinking refraction, making the boat look like it's sinking over the curvature of the Earth, even though it's on a small lake and it's too short to be curvature from the observer's height. So, given the fact that we can produce what people claim to be boats going over the curve of the Earth at a shorter distance, and given that we've got testable and repeatable demonstrations of sinking refraction that match these observations that people claim are boats going over the horizon, there's no reason to accept that there should be globe curvature. And maybe if I make a final point, if Earth is a sphere with an average radius of 3,959 miles, which varies by about 14 miles, the distance to the horizon for a 6-foot observer is only going to be 3 miles. And after that, things would disappear bottom up. Nobody's been able to show that this is happening at that distance anywhere or at any distance.
Okay, interesting. Okay,
Yeah, that's horizons.
let's say all of what you just said is true, right? These research, these studies, all of them are true. What do you say about the circumvention, where you go from America to India, for example, where you circumvigate the whole world? If the Earth is flat, that shouldn't happen. If the Earth is flat, we theoretically cannot traverse the other side because it's blocked by I don't know what. So what do you say? Do you think that we're using ships and going by the perimeter of the Earth to reach the other side of the world, or do you have another explanation?
Well, flat Earth is not a map. It sounds like you have a map in mind.
Well, it has to be a map because something. If something is flat, it has to be 2D. It has to have 2 dimensions. And if something has 2 dimensions, then it could be demonstrated in a map. No?
Yeah, well, I'm kind of curious to know why you don't think we could go from like America to India if the Earth is flat. I have no idea why you'd be imagining that that's impossible.
Because
Unless you're imagining a map.
because people go from America to Russia, and Russia is connected to America. So you can see like it's a big belt that is connecting all of these continents together in the top. So if it was really flat, Russia and America, they exist in the top, and they shouldn't really be connected logically, because that wouldn't be logical. Like they can't. The only logical explanation for Russia and America to be connected, and you can go all around the America and Russia and reach parts of Europe, is for Earth to be flat, to be round, to be a sphere.
Can you show me what you're talking about? Because I don't understand what you're imagining.
Okay. You know that people have traversed America and Russia?
Yeah.
Okay. Let's say that's I can't share my screen. That's unfortunate. So the Earth and America are connected. Yes, but Russia is connected to Europe, right? And in a sphere, we know that Russia and Europe and America are in the top, the northern hemisphere of the Earth, where ice exists. And why do we know and we're certain that they are on the top? It's because of ice and low temperatures. So if the Earth was flat, the access from America to Russia shouldn't be possible. If the access from Europe to Russia is possible. Do you understand what I'm saying? The access to Europe from Russia, if it is possible, in a 2D map, the access from Russia to America shouldn't be possible, because there should be a barrier. There shouldn't be a barrier. They just can't. They just can't. Like in a 2D map, if you want to go from America to Russia, you would have to go from America to Europe, then Russia.
I don't know what map you're imagining works that way. And maps are not real. Like maps are built for specific reasons to display information in a certain way. There's a universal transverse Mercator map, which might sound like what you're describing. And these maps are all, for the most part, are all going to be spherical coordinate systems that have been projected flat. So like if you're thinking of a globe map, that's been projected flat, and you're calling that flat Earth, that really doesn't make any sense.
Well, you guys do have a representation of flat Earth, like a demonstration of how Earth is partitioned in a 2D dimension. Because
I don't know if I don't know if a whole map of the Earth has ever been produced without using a spherical coordinate reference system. So I wouldn't be able to show that to you.
Okay.
Right? I mean, if you want to pay me, I could probably do it for maybe $200 million, and I can go survey the Earth using flat surveying methods, Cartesian coordinates.
Yeah, well, if I had that money, I wouldn't be on Discord.
I mean, so one thing you need to understand is the coordinate reference system that has been used for since ancient days, it seems, the spherical coordinate reference system. latitude and longitude. This is based off this celestial sphere. What people think are globe coordinates are actually celestial sphere coordinates.
What does that mean? What is a celestial sphere coordinate?
Yeah, I'll begin with the North Pole, right? North Pole is 90 degrees north. Okay, and on a globe, this means you're standing on top of it.
Yeah, that's
But
right.
in order to know that you're at 90 degrees north, you don't look down, you have to look straight up. And you'd see Polaris 90 degrees above your head. Does that make sense now?
No.
Okay, well, let's continue, all right? Let's say I saw Polaris in the night sky at a 45-degree angle.
What's Polaris?
The North Pole star.
Oh, yeah, Polaris. I've never heard of that actually. Okay, continue.
Okay. Well, like I was saying, you're at 90 degrees north when you look up and you see Polaris 90 degrees above your head. If 0 degrees is straight out in front of you, 90 degrees is straight up above you. If you happen to be somewhere else on the Earth and you saw Polaris at a 45-degree angle, you know that you are now at 45 degrees north latitude.
I get your point. What you're saying is that Polaris shouldn't be on top everywhere.
Well, my point is we're describing now an angular relationship between the observer and the star and the location on Earth.
Okay.
Now, what people have done is they've assigned a distance. This hasn't actually been measured, but the distance is that they're going to be 69 miles that you travel on Earth for every degree of change of Polaris's elevation in the sky.
And were researchers done on that to prove it?
Well, this is where you get latitude from, right?
Oh, so that's the reference.
Yeah, so that's for latitude. For longitude, there are multiple ways to get it. Most common is with the sun. So you pick an arbitrary point on Earth, like Greenwich, England.
Okay.
And when the sun is directly at its highest point in the sky during the equinox, you say this is the prime meridian. Everything west of the sun goes that way in longitude, and everything east of the sun goes that way in longitude. And the sun marks the hours. And for every 15 degrees of change is 1 hour.
Every 15 degrees is 1 hour.
Yeah, of the sun's motion. Yep. So
Wow.
that's longitude. Now, what people have done is they've created a spherical coordinate reference system out of this. For the first half, you've got Polaris going from 90 degrees to 0 degrees on the horizon, and then you use the sun. When Polaris is 0 degrees on the horizon, you're said to be at the equator. And now as you head south, you got to pick up other reference points to know your latitude, and it gets a bit choppy.
So what you're saying is that because the math isn't precise between 2 points in Earth, that proves that the Earth is not a sphere?
No, I'm describing how they're creating a spherical coordinate system. So there's another point of apparent rotation, angular movement of stars in the southern sky. It's a black area. And if you could take high-powered binoculars and magnify the light, you'd probably see a cluster of 3 stars One of them is called Sigma Octantis, and this is considered the South Pole star. All right, so that's the claim. What you have is you have 2 points of reference for this coordinate system. The first point of origin is the North Pole. The second point of origin is the South Pole, and it's a sky ball. And if you're going to assign a fixed distance to the angles of degree that the stars move, you're going to create a spherical map for the Earth that you're walking on. You're going to create a spherical coordinate system for the Earth. And at this point, you don't have any proof what shape the Earth actually is. But this is what was done. This is what has been handed to us. And what people did was they took the spherical coordinate system of the sky, they did a one-to-one relationship and mapped it to the Earth. And they said, because it works, Earth has to be a globe too. And that's how the globe was invented.
And that doesn't make sense to you.
No, I understand why they did it. Now, what I'm challenging are all the fundamentals. I mean, first off, is a celestial sphere even true? The answer is no. If you study the stars over the course of a year, these things don't exactly form a sphere. Right? People have a false notion that if you follow a star in the sky and do star trail photography, that if you could over a 24-hour period, you'd be able to see the star connect with itself where it started, forming a complete loop. And that does not happen. You have to wait a whole year for that to happen, which means a star is actually forming a helical or a spiral shape in the sky.
So they never form a whole line around the Earth, just like a circle on one place?
Yeah, that's right.
But not around the Earth, just like on top of it, kind of on top of it.
Yeah, if you go out at the same time every night and track the motion of stars, you wait for it to come out and you identify where it is and you keep tracking it, you'll find that the star is going to migrate in one direction and migrate back to where it started.
Oh, so like in one line, as opposed to a circle.
Well, I mean, what it's tracing, if you could follow it completely, it's tracing a spiral.
Spiral, okay. And did you do that personally? Did you do this experiment personally?
I've not tracked it personally. What I have done is I've gone through meteorological records and tracked the time of the location of the stars, right ascension, declination. Right, so in the celestial sphere, you have right ascension and declination, and that's essentially longitude and latitude. Same thing by different names. When you're at a coordinate point on your map, you're basically informing everybody else that you're at this particular point in time relative to a star that or set of stars that you can see overhead.
I kind of understood that. I'm not as qualified as you are, but I'm trying my best to understand your points, and yeah, that's really interesting.
Okay. Well, yeah. So this is it, man. People created a sky globe, and they used it for the Earth. And the best way to use it for the Earth is to make a globe out of the Earth. And you know what? The coordinates seem to work for most people's use cases. But when we actually go to measure the curvature of the Earth itself to check to see if it's there, we can't find it. It ends up being flat every time. It does not comport to a globe. And that's a problem. So on one hand, we know how the globe was constructed out of subjective interpretations and math. And on the other, when we actually go test for the curvature of the globe and can't find it, we know it's not there either. So we know how it was created out of math, and it's pure mathematical concept. And then we also go test for it in reality, and it's not there. in concrete reality either. So we know it's an abstraction, and we know it's not real.
And there isn't a single contradiction that proves that Earth is not flat.
I mean, I don't know how you'd argue against measurements besides looking at the measurements themselves.
So all measurements lead to the fact that the Earth is flat.
Yeah, it does. In fact, yesterday I was posting some interesting citations. So in the field of surveying, surveyors are professionals that get paid to measure the Earth. It is very well known that the globe coordinate reference system, the spherical geometry, does not produce accurate enough distances for local building projects. They require instead using flat horizontal reference planes instead of a curving one.
Really?
And it's found time and time again that every time they ditch the globe and go with a local flat horizontal plane, they increase their accuracy and they simplify the calculations and measurements.
Okay. Well, if what you're saying is true, why aren't more people talking about this and doing more research? Why is there only a small group
Yeah,
of people that is interested in this flat Earth thing and is
I know.
why is
It's
that
a good question, right? I wonder why more surveyors aren't public about this, because they're the people I think who are closest to actually knowing this to be true. But I can tell you that surveyors will write papers describing this very phenomenon. I have one by a guy named Jesse Kozlowski. He goes by Maine Surveyor. He's come in here. He's chat with us a few times. He thinks Earth is a globe and thinks he can prove it. But I have a paper he wrote from 2006. It's publicly published, where he's describing how it is that he uses electronic distance measuring devices, i.e., lasers, to get precise measured distances. We're talking 3 decimal places of a meter. And it doesn't match the global coordinate reference system. It doesn't match GPS.
really?
Yeah. And he describes this actually being a problem for the kind of scaled projects that they work on all the time. You know, if you're cutting segments of steel for a bridge, and if you got like an 800-foot span and you're off by like 2 feet, somebody's gonna lose a job.
Yeah, I understand. If there is a single contradiction to a proposition, it makes that proposition false, and we learned that in basic mathematics.
Yeah.
In order for a proposition to be true, there should not be a single contradiction. I understand that.
Right. So here's what would happen, right? You send a surveying team out. One of them uses GPS. They take 2 GPS receivers and transmitters. Okay. In this case, they're transmitting to each other. They're transmitting their locations to each other. So receiver A and receiver B are transmitting their GPS coordinates to each other, and they measure a distance.
What? You mean receiver and emitter? What do you mean receiver and receiver?
So you've got 2 receivers, GPS receivers that talk to each other to communicate their coordinates to each other and calculate a distance.
How can 2 receivers that only receive talk to each
Yeah,
other? Do
I
you
know
mean like a
they are only
receiver and
receiving from
emitter?
GPS, but they're transmitting on radio. Call it like on a Wi-Fi or Bluetooth to each other, maybe using cellular. Okay.
Okay. Now
Right. So
I was talking
yeah.
about
Okay.
they were talking using not talking but messaging each other or signaling each other using the receiver thing. If it's
Right. I
separate,
mean, this
then I
technology
understand.
exists like surveyors have access to this stuff. They just drop these little pods, and and they can calculate out, the sides of a of an industrial project or something they're going to be working on. You know, and they can drop these pods and it will map out using GPS the dimensions of their workspace, their environment. I don't know what they call it. I'm not in construction. All right, but the point is if you were to take two of these that say that they're like 800 feet apart, and then say, "Hey, boss, I need a segments of steel cut to match this 800-foot span. I got these figures from GPS. It's supposed to be super accurate." Boss sends up an order to get that steel beam cut, and they bring it down. And surveyors go out there with laser devices and they measure a different distance, and they find out that the beam is too short. You know, that's what's happening here.
Too short. So it must be off by not a big number, but a meaningful number, a significant number.
Yeah.
Wow.
Yeah, I mean this happens. I've got another paper on navigation systems for unmanned aerial vehicles. And the paper describes how they improve accuracy for critical operations, including takeoff and landing, by using a flat Earth reference system instead of the global spherical GPS.
And are we the global or the spherical Earthers count these GPS inaccuracies as an exception?
No, this is the norm. This happens everywhere. I mean, we've got transportation manuals from states across the United States and other countries
No, I
where they
understand.
describe
Right.
that you got to use flat Earth coordinates instead of spherical ones if you want to improve your accuracy. I mean, this happens again and again and again. But the people that are writing these articles and these papers and the people coming to these discoveries, I think, still believe Earth is a globe. And the reason why they still believe Earth is a globe is because of social conformity. The power of belief is really strong in the globe, my friend. You can't swing a dead cat without hitting a globe somewhere. If it's on TV, if it's on your iPhone, if it's on a plumber's truck as it's driving by, you see globes on things that don't even make sense for the globe to be on them, and there's a fucking globe on it.
Well, yeah, I mean, like, there are 8 billion
Yeah.
people who believe the Earth is not flat. So
Right, right.
it's
So if I'm
really
writing a paper,
it's impossible
right,
to make them all change their minds.
if I'm writing a paper describing my struggles in surveying because I have to produce flat coordinate reference systems all the time in order to perfect and improve the accuracy of my surveying projects, I may still think Earth is a globe and I don't know how it fucking works, right? I'm just like, I don't know, maybe just flat works really well at a local level, but it's still globally curved, you know?
So they just don't give much importance to it.
Right, right. I mean, we have like gosh, I remember reading somebody was posting this in our home server, an observation in Antarctica from a ship seeing mountains that were 300 miles away. And at that distance, you should not see any mountains, no matter how tall you think they could get from 300 miles away.
And why is that? Is it because of the fog?
Curvature of the Earth.
No, but you don't
Yeah,
believe
if Earth
in.
is a globe, you shouldn't see those mountains from 300 miles away because of the
Yeah, you
curvature of the
should.
Earth,
Yeah, you
not from
should.
a ship.
And they saw it.
Yeah. These are logged, you know, like in I think it's like some United States Geological Survey that was done.
Wow.
Yeah, and the people that make these observations and write it down, they're not thinking about flat Earth. They still think Earth is a globe, and they're not really spending time with the consequences of what it is they're observing, because to
Yeah.
them the globe is a foregone conclusion.
Yes, it's an absolute rule. It's a rule of the universe. It cannot be changed. That's why that's what they say. You understand? I mean, I once heard that if you were a giant and you were to touch the Earth, the surface of the Earth, it would be as smooth as as a golf ball. So what you just said is proof that if a mountain, even if it's the Mount of Everest, at a certain point it shouldn't be visible if the Earth was a globe. But because it's visible, that does raise some concerns. That's really interesting.
Yeah, and 300 miles is also the absolute max distance
No,
that
300 miles
you'd
is
expect
way
to
too
see
much.
anything anyway.
You're not supposed to see a mountain at 300 miles.
Yeah, I mean, if Earth is flat from sea level, you should not see beyond 300 miles.
That's
Anyway, and this is due to the atmosphere. This is due to something called Rayleigh scattering. The reason why the sky looks blue is because blue's being scattered the most right now.
yeah, that's what they say. Blue is the strongest strongest type of color. I forgot about the definition because I got my high school degree so long ago. But you know, yeah, it's the strongest pigment, I guess. I don't know.
Yeah, so as the density of the atmosphere compounds with distance, at some point light would not be able to be seen by the observer because of all the scattering and absorption even over a flat surface.
So what you're saying, if the Earth is spherical, we shouldn't see blue light.
No, I'm saying if even if Earth is flat, you probably shouldn't expect to see beyond 300 miles.
No, but you were talking about blue rays.
Yeah, it's due to the scattering of light and the absorption.
So okay, so let's say the Earth is not flat; it's spherical. How should the light be scattered around? How should the sky look mathematically?
I don't think it would look any different. It looks as it is because the Earth is flat.
No, the sky that we see, right? Let's suppose the sky that we see is for flat Earths, right? But how would the sky look like, using your logic? How would it look like for a spherical globe?
Oh, okay. Sorry. Yep. That's a good question, man. One of the things I thought about was the Terminator line. So the Terminator line is what separates night from day. If you've seen pictures of the globe presented by NASA, right? And the globe may have one side of it illuminated and the other side is in darkness, and a dividing line between day and night. That's called the Terminator line. What I find fascinating is in the real world, with every sunrise and sunset, the sky undergoes a beautiful, lengthy transformation of colors.
Yeah.
But we don't see that from space photos from NASA. They never show us the beautiful transition of colors between day and night in these globe photographs. I wonder why that is.
I'm sorry, continue.
Well, I mean, they tend to just dither the daytime into nighttime, and it's a pretty sharp transition actually. And our view of the sky, especially from mountains, during sunrise and sunset, I mean, that's a significant portion of the sky that should be available and presented as such from these space photos of the globe. I mean, how many hundreds of miles can we see of the sky looking out in all directions from on top of a mountain? And if it's all red, let's say it's a red sunset, okay? Red sky sunset. You're on top of a mountain, the sky's freaking red. And then off in the distance, you can see into night. And then off in the other way, you see the sun on the horizon. They never show us that beautiful band of red from these space photos. Should be spanning quite a distance.
That's really interesting.
Yeah, so how should Earth look if it's a globe? Well, I mean, if I begin with all the pictures they show us from space, why don't they match what we actually see from the ground?
Well, if you're a flat earther, you believe that they actually went to space?
I think it's possible that human beings have been way up in that environment, but it's not over a globe.
Okay.
Yeah.
That's really interesting. So I'm assuming most of you here are mathematicians, right?
I wouldn't say that. I mean, we all
What's
come from different backgrounds.
what's your background, if you don't mind?
I make pizza.
Really?
No.
Space pizza?
Mm-hmm.
So how come you know so much about geometry, space, complex math, imagination in math, of course? How
I
come
just read.
You just read and do research?
He's an
I
Illuminati.
Listen, like one of the fun things about flat Earth is going out, and as you collect all the globe evidence, you find all the contradictions and problems. You start cataloging them.
So your job is like making a gallery of things.
Oh, it's not a job, it's a hobby, but it's definitely like this. Have you heard of computer hackers that are given money for finding bugs in computer software?
I've heard of them, yeah.
Okay, we're like that. We're finding bugs in the globe software and we catalog them.
And you've never done research?
Yes, I've done my own research. Many of us in here have done our own research. Some are content producers on YouTube.
Really? Wow.
Yep, this community's been around 10 years, and this is all we do, man, and we have so much fun doing it. We find bugs in the globe system, and we report on them. Some of them we don't tell people about because we're kind of holding it back. Because here's what's funny. Some of the issues that we've pointed out over the years, we've actually seen responses to. We've seen like NASA cleaning shit up. Not even joking.
What the fuck?
Yeah, so let me tell you about one thing. There was a program, okay? Sophia is a high altitude telescope on a jumbo jet.
Jumbo, what? What's that?
A jumbo jet, like a 747. Do you know the Boeing 747?
Oh, yeah, I know that.
They put a telescope the size of a Volkswagen Beetle inside of a 747. And it's called Sophia. The program doesn't exist anymore, but the program was SOFIA. It was a NASA program. And for 2 years, Sophia was tasked to do horizon studies. So they took this big fat telescope capable of infrared and aimed it sideways. There used to be a web page that NASA ran with media from this 2-year-long study of the horizon. And after one of us in our community found it and started talking about it, it was taken down, removed, like it's not even there anymore.
It's like that.
Yep. We've seen other cases too. We a couple years ago, we discovered that America has an investigative agency called the National Transportation Safety Board. Basically, whenever there's an airplane crash, they investigate the cause. I mean, it's a government agency. And they do this not really for insurance purposes, but for safety reasons, for updating safety standards for aircraft. They have a database that's been open to the public, and it goes back to the 1960s of all these air crashes involving crashes within the United States, or I think even American aircraft crashing elsewhere. And a part of what they publish includes black box data. And we'd heard from globe earthers that airplanes measure curvature, just get the black box data and it will prove it. Well, so we found a database that publishes that black box data. You know, the data can be big. I mean, I downloaded a 400 megabyte Excel spreadsheet. So we pulled through the data and we come to discover that no, there's actually no globe being measured at all in any of this stuff. Well, when we started talking about this database and the flight recorder data that was available, shortly thereafter, the National Transportation Safety Board took down that website and put a different page up instead. And on the page, it said, if you want access to this information, please send an email to this address. Basically, state your reasons. So we took a snapshot of it. Well, funny thing, actually, several weeks after that, they published the old site back up again. So the old page where you could find and search this went back up. And to my knowledge, it's still up today. But it's very fascinating to watch this kind of thing happen in real time.
Why do you think NASA is trying to hold back these informations from the public?
I believe that most people at NASA believe that Earth is a globe, 100%. They don't know it's flat. What they're afraid of is they're afraid of flat earthers convincing people that the Earth isn't a globe, because it's going to absolutely destroy the credibility of their institution. Now, even though they still believe Earth is a globe, and I really believe this, I don't think they're hiding flat Earth from anybody. I think they're afraid of like societal collapse, the loss of faith in institutions that told us that the Earth is a globe.
So it's basically because NASA is all about the Earth being a globe, and if they promote flat earthers, they would lose
No. Let me tell you what. They're afraid of societal collapse, and NASA's primary involvement is to be a propaganda arm for United States interests. This is why they were founded during the Cold War. NASA has a job to do, and we've got their founding documents. You can read them. I can go through them with you right now. Where their primary job is to project American technological capabilities and discoveries, even if they're not true. That's my assessment. They actually have within their founding documents a whole section on psychological exploitation. And the panel that put NASA together and funded it was the President's Psychological Warfare Board, called the Operations Strategy Board, or Operations Coordinating Board.
Wow.
Yep, the same people that plotted the overthrow of foreign governments in the 1950s and 60s were the same people that brought us NASA to cook up propaganda. So I still think most people working there think Earth is a globe, and they're worried that if flat Earth gets popular, that it will be wrong. They're thinking it will be wrong, but it could also topple faith in American values and exceptionalism, which is what NASA's primary job is to protect and project.
But the thing is, there isn't just America in the world. There are other countries in the world. So why isn't there a group of scientists in a country besides America that go about their ways and try to prove that flat Earth is a thing and it does exist? Why is it
Yep. So
only a group of people that are not official? Like,
yeah, their space programs were seeded by NASA from 1958 onward. Within NASA's founding documents in 1958 and 1959, the ones that I'm talking about with regards to psychological warfare and exploitation, they also describe partnering with other nations of similar interests so that they can set up the same kind of space program themselves and project prestige and power for their own people, and do it in concert with the US to align against the Soviet Union. Well, funny thing is the Soviets started lying about space too. They started to lie about space to lie about their technological achievements. When Sputnik happened, the United States Secretary of Defense, Charlie Wilson.
Sputnik?
Yeah, when Sputnik happened, the Secretary of Defense in the United States, the man in charge of the Pentagon, he told CBS News that what Russia did was a cheap scientific trick.
Wow.
So I wonder what trick he was having in mind. Maybe some tricks that NASA was developing. I mean, at that time, there wasn't a NASA per se. There was I think, a very nascent national space policy, but national space policy did come out in 1957 and 1958. There was an MIT professor who was commissioned to study the Russian space program and design an American program that had just as much power and prestige, if not more.
What would you do if you had a son or a daughter that believes the Earth is a globe?
Well, I mean, you can't force somebody to see something that they're not willing to accept. You know, my advice would be to teach them critical thinking. And if they're going to be enough of a critical thinker to examine this belief in society, then you won't need to tell them that the Earth is flat. They're going to figure it out on their own.
So you don't have this idea of making your kids believe that the Earth is flat. You want them to find that out by themselves, right?
Yeah, like when I first looked into flat earthers were telling me it was flat. I wasn't having any of it. I thought it was the stupidest thing on earth.
And
It
how come
wasn't
did
until
you,
well, because I exercised critical thinking. I first had an interest in the topic, an interest enough for which I dedicate enormous resources in terms of time and money, even in committing to investigate this. You know, and it was through that endeavor that I realized that Earth can't be a globe. It wasn't because somebody told me that convinced me. It's because I went and found out for myself.
you convinced yourself?
The evidence was quite convincing. And that's what I tell other people. Like, you know, don't take my word for it today. I would not expect you or anybody new to this listening right now to believe anything I'm saying. So I can present the evidence. If you don't want to accept it, then you won't be convinced, plain and simple. So apply some critical thought, have some academic integrity, investigate, be impartial and honest with yourself, and you'll see that it's flat.
Last question. What's your faith? What do you believe in? Do you believe that there exists a superpower that is above us all?
Yeah, I do. I'd say most people in the world do.
Do you mind telling me which religion?
Yeah, being that I'm American, it's pretty obvious that I'd be a Christian, just playing statistical odds. And if you were to guess that, you'd be absolutely right. I'm a Christian.
Yeah, that's interesting. And what do Christians say about the Earth? Do they also believe that the Earth is a globe? Because we Muslims believe that the Earth is a globe.
Well, that's funny. I've talked to many Muslims who believe otherwise. There's a Muslim flat Earth server. Actually, there are like 2 or 3 Muslim flat Earth servers.
Actually, I must take back my words. There isn't an evidence, but because because most of us Muslims believe the Earth is flat, is a globe. My mind just made it a rule in Islam. I'm sorry, I shouldn't have said that.
Well, I mean,
Yeah.
biblical texts do not describe a globe. I mean, and even in Quranic texts, I'm not Muslim and I don't read the Quran, but from what I've seen people share of it, the world is described as a carpet that gets rolled out. We find more allegories to a description of the flat world that we see and experience, than a globe one that we don't.
Actually, in the Quran, there are proofs that show the Earth is flat, and others show that the Earth is a globe.
I mean, it wouldn't be surprising. Ancient Christianity, as an extension of Second Temple Judaism, held to flat Earth beliefs and cosmologies. Through the 4th, 5th, and 6th centuries. So the whole Near East, encompassing, like North Babylon through North Africa and out into Persia. I mean, everybody there, all the ancient civilizations had a flat cosmology too.
Wow. I guess I just don't know much about this stuff. It's crazy.
Yeah. I've got a good book. It's on ancient cosmologies. If I can find it, I'll post it. It's a PDF. You can also find it online. It's in the public commons. Hold on. Yeah, okay. It's called The Earliest Cosmologies. I'll pull it up in just a sec.
The earliest cosmology. The universe is pictured in thought by ancient Hebrews, Babylonians, Egyptians, Greeks, Iranians.
Understanding information. This book talks about cosmos, right? The space.
Yeah, how people conceived of the world. No,
So basically,
some
how different
civilizations.
civilizations see the.
Yeah, I mean, some civilizations really tried to objectify it. To take the whole world and think of it as an object in a bigger space. But I'm here to tell you that there are many of us in this flat Earth community who don't think you can do that. You can't take flat Earth and objectify it. You can't define it in a space. It may not be in a space. This is all there is, man. This is creation. This is the whole world.
So what you're saying is that because there isn't enough proof, we don't know. We know that the Earth is flat, but we don't know how the Earth is flat, or what are the
Well, it's kind of
limits.
like this. If I were to ask you, what does the Big Bang universe look like from the outside, from God's eye view?
I don't believe in the Big Bang.
Okay, me neither. But let's say that you did, right? Let's say that you were to ask a godless atheist to conceptualize the Big Bang and describe it from the outside looking in. I mean, obviously they wouldn't be able to conceptualize it, and they would tell you straight up, you can't objectify it like that because there's no going outside of space to see space, right? I mean, unless you're talking to God's eye view, but they're atheists, so they wouldn't have that.
Yeah,
Well,
that's.
I mean, what if I were to say that this flat world cosmology is kind of the same way, that if you were to ask what it looks like from the outside, you'd be invoking how only God would be able to tell you how he has created it.
So
It may
basically,
not be, yeah, like it may not be a nice little ball sitting in a void of nothing, or a
so basically, it's
pizza.
out of the scope of our understanding.
Correct. Yeah, you can't objectify it. You can't collapse all of reality into a Platonic solid.
If we understand it, we're basically gods. So that's why we can.
That's right. Only God can understand. It's only for him to know.
That's interesting.
I'll tell you what, when we measure it, it's flat. And we somehow get by with a spherical coordinate system on this flat Earth. We get by enough, but it doesn't sincerely inform us alone about the actual shape of the Earth. The only way to get that is by measuring. Or by observations at such scales that you don't have to be precise with your measurements, like seeing mountain ranges that shouldn't be visible. In the ancient Christianity, we're talking before, the first 1,000 years at least, there wasn't this concern over trying to objectify and put into dimensions the Earth itself. The focus was on this being a place of divine mystery, of divine order, of creation, and in
Well,
some
also now there
aspects, a
isn't really.
revelation of the Creator.
Also now there isn't really a concern about the Earth being a globe or flat. I don't think many people are concerned about this topic.
Right. I mean, we have examples from like church history through liturgical texts and all kinds of missives that the emphasis was on thinking about your world as a place of creation. That's it. Like there wasn't any, I wonder if it's a ball. Like That wasn't really happening. You know, and I got to think, to the ancient mind in the ancient world, it was obviously not a globe, right? And a spinning one at that. When we all look at the sun, we see it move in the sky. We don't feel the earth rotating backwards. You know what I mean? So
Yeah.
it was very obvious to the ancients that you measure things flat, that the seawater was flat everywhere, it's level and flat, and the stars in the sky move overhead. Same with the sun and the moon. They move overhead for everybody on Earth at different times. Right? All the stories we get about the people who first measured the curvature of the Earth, they're all wrong. Like every single one of them, there are huge problems with.
And they're still being used to this day.
Yeah, like Eratosthenes. You've heard that name before, right?
Aristophanes?
Yeah.
No.
He was supposedly a librarian of Alexandria back in, I don't know, 300 BC, give or take.
Oh.
And using shadows in a
Do
well.
you mean Aristotle?
No, Eratosthenes. Although Aristotle said to have thought it was a ball too. But I chose Eratosthenes because they say he's the one that measured it using shadow lengths. So, you know, he assumed that the sun was 12 times smaller than people think it is today and much closer, and yet still casting out parallel rays. And he assumed that Earth was already a globe. For him to take shadow lengths and assume that these are arc segments around a ball, he did not actually measure the curvature. He measured segments of shadows on the ground and assumed that they were arc lengths of a circle. So you start looking into the story and you're like, yeah, that doesn't really fit, because just measuring a shadow length itself doesn't arbitrate whether or not the surface is curving. You're going to need a bit more than that. Well, Eratosthenes didn't have anything more than that but assumptions. Meanwhile, there was a Chinese contemporary of Eratosthenes. I don't know, it was just like the Ming Dynasty or whatever in China back in the day, 300 BC, our calendar. A Chinese astronomer proved that the Earth was flat for all the Chinese people because he measured shadow lengths on the ground, same as Eratosthenes. Only the Chinese astronomer didn't assume that the Earth was globed. He assumed it had to be flat. And when he measured those shadow lengths, by golly, he also affirmed that it was flat, just like Eratosthenes affirmed that it was curved. They both used the same methodology, but went into it with two different presuppositions. But they have the same observations. Imagine that. Imagine what's going on here. We have what's called an impasse, folks. So people are convinced that Eratosthenes proved it when logically he did not. And on top of it, whether or not Eratosthenes existed is in question too, because there are no primary records of his existence. It's based off of like documented hearsay.
Yeah, because I tried to search about him and I couldn't really find him on Google.
Well, he's like in all the textbooks in the West as the guy that measured the circumference of the globe, and it's flat out wrong. It's not true. He did not actually measure that. He may have never even existed. And the Greeks were famously known for creating archetypes, for creating figures, and attaching to them entire schools of thought and accomplishments of all kinds, whether or not they happen. But Greeks loved admiring their heroes, and they made them up left and right.
That's true.
Yep, and Eratosthenes was one such hero. And you know what? Aristotle might be too. And
Also,
Pythagoras most
Socrates.
of all.
Well, wouldn't that apply to everything? Wouldn't this logic make everything every historical scripture to logically not exist? Like have a chance for it to not exist?
Well, if you hold the historical record to the same standard, you're going to find that different figures will and will not meet the same criteria. Like the evidence for Jesus's existence. I mean, whether you're Muslim, Christian, or even Jewish, I mean, the man Jesus of Nazareth is something that most people accept based off the historical record. And if you were to apply the same scrutiny to Eratosthenes, it's going to be a much thinner provenance, much thinner resume. You know what I mean?
Yeah, kind of. Yeah. For something to for some for something for us humans to assume that exists in the past, there must be historical records for it to prove historical records that prove that thing existed. And for Aristophanes, or whatever his name is, there isn't much proof for his existence, right?
Right. And there isn't proof that anybody did what he claimed to do.
Yeah, it could have been just some stories made up by the Greek historians, I guess.
Yeah, and honestly, I mean, if you ask me, my personal take on this, Eratosthenes is probably represented by, one man is representing multiple real people, and furthermore, his story about measuring shadow lengths to get the globe circumference sounds like a thought experiment that you teach children in a classroom.
It may have been just an idea.
Yeah.
An idea represented in a person.
Yeah, and it may have started off as a thought experiment. Hey, children, listen up. We have a thought experiment. If Earth is a globe, do you think you could measure it this way?
Hmm. Yeah, well, thank you so much for taking the time and explaining all of this stuff. I know this takes efforts, and I really appreciate it.
You're very welcome. Listen, come back. We will show you our laser tests and our long distance observations next.
Thank you. I would really appreciate that. This
All right, man.
seems like a very smart community, and I like being around smart people.
Yeah, thanks. I appreciate that very much.
Yeah, one
Right.
last question before I go.
Okay.
Uh, how old are you, if you don't mind me answering questioning?
Late 40s.
Really?
Yep.
Because when I listen to you talk, I listen a 20-year-old talking, and at the same time a 40-year-old talking. Like it's very weird.
I hear you, man. I'm not. I'm very blessed with a youthful appearance too, but
Really?
yeah, you could say that. But I'm not a midget.
uh, well, Yeah, man. You have a good day or good night. It's all of you guys, not
Thanks,
just you.
appreciate it.
Yeah. Um, Thank you and goodbye.
All right, see ya. Send me a friend request if you want. And he's gone.
Appreciate you, Yoder, man.
It really is something, man. All the map reification going on. No, and people on both sides not understanding maps and getting it wrong. You know, like the Glober who presents the AE map and says that this has been debunked. That's a Glober who is basically throwing their own map under the bus because the AE map is a projected globe. And then the flat earther who draws a circle around the outer perimeter of the AE map and says that this is the 60,000 mile path that Captain Cook went on when he went on his Antarctic expedition. That's a flat earther who doesn't know that they're drawing a much tighter radius around a globe because they don't understand that the AE map is a projected globe. The projected globe preserves the distances between points, coordinate points. It preserves it because the scale goes from a linear scale to a nonlinear scale. The AE map will show you a nonlinear scale in order to account for the longitudinal lines being splayed out like a bicycle wheel, like spokes on a bicycle wheel. When south of the equator, those lines of longitude are not increasing in distance, not according to the coordinate reference system. The map is still at 89 degrees south latitude, the widest ring possible around an azimuthal equidistant map. That map is still informing you that that circumference around that outermost ring is just as big in real world distance, it's claiming, as 89 degrees north near the smack dab center of that map. Those are the same distances. And if you apply the non-uniform scale, you will see that that's what this map is trying to inform you. That no, that's not a 60,000 mile circumference way out there. The further out you go past south, the less miles is covered with the greater distance on the projection. And if this map is missing a scale, then you have to ask yourself, was it removed on purpose? Is this image that you received from another flat earther a map with a scale that somebody removed on purpose? Because if you had access to that scale, which belongs with that map, this would be obvious to you what I'm telling you. So going through Jean Baudrillard's 4 orders of simulacrum, first order being basically you are aligned with reality. You know, you see it for what it is and you can handle representations of it just fine. Second order being you're somewhat divorced from reality and you start to reify the map. Third order is when you have gone to the point of excluding things or including things on the map that don't exist in order to support your idea of what should be true. And the fourth order being completely divorced whatsoever from any semblance of reality. You think the map itself is reality. I would say the AE map without a scale has arrived to you based on somebody who's at the third or fourth order of simulacra in John Baudrillard's framework. They are multiple steps removed. They have reified upon reification. And then the glober who receives that map from the flat earther and doesn't even know that a scale was removed from it is also in the third or fourth order himself.
Yoder, man, I really appreciate you setting me and others straight on that, man. The way I thought about it is when you sharpen a knife, you damage it into sharpness, and you're out here sharpening knives, bro. You really appreciate it.
Yep, thank you very much. I've lost flat earth friends over this.
You know, man, when I think back back in my life, one of my old bosses here, at my jobs, dude, I hated him. He was so hard on us to the point of being some bullshit sometimes. He made me mad sometimes with how much just like bullshit, and everybody hated him, constantly had us on our toes. But when I look back, he's the best boss I ever had anywhere. He pushed me all of us so hard, and after he retired, you can see who stayed sharp and who didn't. I went from hating him to respecting him. It was almost like that movie Whiplash. You know, my best soccer coach back in the day was the hardest one I ever had. My best friend, my wife, has pushed me harder than anybody else, and sometimes to the point of, you know, it upsetting me. You know, but you know that's what we need sometimes.
Yeah, 24/7 is always community. When I first showed up and I was new, I took a licking from all the golds and some silvers and the moderators on things that I had wrong. So, you know, passing on the tradition, man. What can I say?
Yeah, I got muted and stuff a few times when I first joined too, but like I said, you guys set me straight on that. I listened to that AI video, or the AI reading that video. They were talking about the A, B, C types, you know, and the B type being the people who reify like the flat Earth map and then fight with the globe map people, and they're like, "Oh, this is reality," and that's where I was, and I didn't realize it. And the way I think about it, when you told me, I asked you that one day, and you were telling everybody about it, but your answer was stern. I would say it's stern, passionate, and firm. Um, there was that fire behind it when you talked about it. I could tell that, and you stress the importance of it and why and the facts on things and weren't afraid to tell the truth, even when you're telling it to, you know, your friends and your family and your peers and the people in the flat earth community. You're not afraid of that, and that's big, man. I mean, a lot of people say flat earthers, it's only one person standing up against this whole crowd of people. Dude, you're standing up against damn near everybody, and that's big, man.
Yeah, thank you.
What did you mean when you said a simulacrum? I've never heard that term before.
It's a fancy word that basically points to an image, or an image that points to something that's real, something that represents something else. Basically, like if there's a simulation is composed of simulacra, and one point in the simulation could be a simulacrum.
Gotcha.
You know, but it kind of goes deeper than that. In the sense that Baudrillard was using it was kind of like a objects that appear to be like they're representing something, but they actually don't whatsoever. Imagine a simulation that isn't actually simulating anything, because there's nothing real that it is simulating. A great example of this might be Google Earth. Google Earth is simulating a globe, but a globe doesn't exist.
That's crazy. I've never thought about that. Yeah, what does that mean to simulate something that, because a simulation means you're representing something, you're simulating something, but if that something doesn't exist, then then how is it even a simulation? That's turning my brain into a knot there. I'm gonna have to think about that.
Right. And so if you were to conduct yourself and build your world based off of a belief in a simulation that doesn't simulate anything real, then what you are doing is you're creating what he would call hyper reality. So an example like this would be going back to the map and the territory. If an emperor receives a map that depicts things on it that aren't true, and then he starts making campaign decisions for his next conquest based off of that, based off of the belief that these are true. And then he starts building and extending his empire under that false belief. This can happen with other things too. Like, what about the American dream? Suppose, you're like me and say it never really existed. But if you believe that the American dream refers to something real that actually happens and is happening, and that you conduct yourself in such a way that you start building a reality, you start creating your world around you based off of this belief in something that isn't true, then you're creating a hyper reality. Like if you were to go to a restaurant and you start eating the menu, there's a picture of a hamburger on it, you just started devouring the shit out of that page in the menu. And you liked it so much that you start printing out pictures of those hamburgers and you start giving them out to your friends to eat. And you convince them to eat it too, that this is a hamburger. This is now hyper reality. This is kind of what happened with freaking maps in the globe.
Yeah, I kind of get that. That reminds me of a time I went to a Pink Floyd concert, but we didn't have any weed. So me and my girlfriend during the intermission, we were in the we went up
We're just sitting down, and I started like fake passing a joint to her and like passing it back, and then when people would walk by, I would like fake pass them the joint, and they would hit it. It was just kind of funny. This guy saw us doing that and came up and just like handed me like a tiny little bowl and some weed in it, and so we like manifested that. I guess that's not really sort of like a simulation because we were simulating, smoking pot because we didn't have any, just goofing around.
Yeah,
And
like,
then
well, he
that ended.
started simulating it too, right? And then gets arrested for it.
There's plenty of people smoking pot in that place, so I don't think anybody got arrested. Well, really, it wasn't a Pink Floyd concert. It was a Roger Waters concert. He like built a wall out of these like little TVs or these huge TV screens. He had giant like balloons floating around. It was a pretty crazy show.
My favorite ever show was by a band that like nobody knows, it seems, unfortunately. If you ever heard of a Mute Math, they put on the best freaking shows, man.
What's the name?
Mute Math, MUTEMATH.
Mute Math. No, I never heard of that.
The last time I heard that band name was back when I was listening to Hum.
Never heard of that either. Is that an older band, Mute Math and Hum? Are those like 90s bands or early 2000s or something?
Yeah, I'd say early 2000s. Mute Math is kind of like, you could call like math rock. Like they're very technical. Their drummer is freaking out of this world. Honestly, like, dude is so good.
Hey, you really do like math together, don't you? You're like,
I guess so.
you got a big old brain, man. How'd you get so smart?
I don't like to be.
It's a burden.
If you're the type of person who takes interest in things that I talk about every day, you're not going to run into very many people like yourself out there in the world. So
Hello, niggers.